All right. Hey everyone, welcome to Posette 2026. My name is Sumedh Pathak. I am one of the co-hosts for this live stream. Also joining me is Derk. Derk, you want to give a quick
Yes,
intro?
it is so cool to start the fifth Posette conference. I'm so happy. Music also did a really good job in getting me energized to get started. I don't know what time it is for you, but for me it's 5 p.m., so I already had a long day ahead of me. No, not ahead of me, behind me.
Behind.
Yeah, but indeed, my name is Derek. I work for Adyen, and it's my full-time pleasure to play with Postgres databases. That's basically my job. Keep them afloat, make them
Awesome.
fast.
Yeah, and I am based in California, so it is 8 a.m. right now for me. Usually it's sunny, but today it's a bit cloudy out there right now. I am the manager for the open source Postgres team here at Microsoft, and in my past life also was a co-founder of Citus as well. But yeah, let's dive into Posette 2026. And Dirk, I think you had asked a question about what does Posette stand for. So
Yes,
did you get
because
the answer for it?
I remember Claire told me because the first two episodes of Posette were CitusCon, right? And
Yes.
then Claire was asking for what name should we get if we pick a new name, and she was inspired by Falstam. And I was like, Posette
Mm,
should be an acronym, but it should also be just something in itself. Like the word itself should mean more than the acronym.
mm.
So, all right, I practiced. I hope I get it. Postgres, open source, ecosystem for talks, something in education.
Training and education.
Training
Yes.
and education. I was so close.
Yes. Yeah. And like I said, this is the fifth iteration of Posette. So let's dive in. Oops, let's see. All right. So there are going to be four different live streams. Right now, you're in live stream one. Two of them are going to be in the Pacific time zone, and two are going to be in the Central European summertime, I believe. And I guess the idea is, so that everyone all over the world has a chance to attend, right? Or at least find a time zone which makes sense for them as well.
Yeah, so basically, 2 of the days you have to listen in at work, and two you can just easily listen in the evening, if you're living in Europe at
Exactly.
least.
Yeah, like we said, I'm Sumedh. We have Derk Van Veen hosting Livestream 1. We have some amazing hosts for the upcoming live streams as well, with Adam, Thomas, Divya, and Abe on Livestream 3, and then finally Claire and Floor for Livestream 4. And Posette, this, like I said, is the fifth iteration. I really love this format. Really makes it accessible to anyone with an internet connection. A lot of people don't have travel budgets or don't want to deal with jet lag, travel times, and I love the fact that this conference brings really high quality content to anyone basically with an internet connection.
At first, I was a little bit skeptical of the online setting of the conference, because for me the
Mm.
conference is really two parts, two equal parts almost. It's like on one hand you have the talks, but on the other hand, like in the hallway track, you can talk to people and get inspired or inspire other people. You make connections. And on a virtual conference, I was like, there's no audience I can talk to. It's a bit harder. But then with the Discord, it's nice to have this online chat as well. There is some chatter going on, so we will participate on the Discord chat as well. Don't worry, we will share the QR code with the link later on. And yeah,
Yes.
but I have to admit, this is my third year where I also give a talk on Posette. And it is cool. The quality is high. The captioning is really good in many languages. So yeah, it's an amazing opportunity
Yeah, awesome.
because at the conference you give a talk to an audience and that's it. And these talks, they live forever and ever.
Yeah, absolutely. Yeah, and it's brought to you by Microsoft. So we're really grateful to Microsoft for organizing this event in partnership with AMD. As a co-host, both Dirk and I, we got a little bit of a behind the scenes peek into how this event is organized, and the amount of time and effort that people spend in terms of the production for this is quite a lot. So really grateful to Microsoft for organizing this event.
And also something else has changed. I realized while we were preparing for Posette this year. When I think of Microsoft, like from my old days, Microsoft was good in selling encrypted CD-ROMs and books. And today it is hosting a open source online conference. I mean, how big of a leap is that? I think it's pretty cool.
Yeah. I mean, I remember Microsoft even back like 7, 8, 10 years back. It was still trying to establish itself in the open source world, but it's made a lot of leaps since then in terms of getting its credibility on that front as well. And thankful to AMD as well. This is the first time AMD is partnering with Microsoft to help produce and sponsor this event. So really appreciate AMD's help on this one as well. Code of conduct. Derk, you want to dive in?
Yeah, it's always a little bit of a struggle to talk about this for me, because for me it's so obvious. Like, you treat people well. Don't say anything you wouldn't say to a British person you just met. So be welcoming, be friendly. And also, a lot of people, they join the Postgres community because Postgres is a great product, but then they stay for the community. So be respectful, be inclusive. If someone asks a question, no matter what you think of the question, because you have maybe 10, 20, 30 years of experience, just say, this is a good question. Let me help you out. Be patient with someone. It's like being friendly costs you nothing. So please be friendly, help people like you would other people to help you. It's that easy. You can read the code of conduct and it's written in perfectly English phrases, but basically it comes down to just be honest with people, be respectful, be curious. Who are you? Why are you asking these questions? How can I help you? It's not more difficult than that.
Yeah, and the conference has speakers and audience members from all over the world, right? So let's be inclusive, friendly, treat each other well. And actually, I remember, and then Postgres, like you said, as a community, is very welcoming. And I remember I had attended PGCon like 10, 15 years back, and I walked up to Tom Lane and started asking him some questions, and he was very patient with me. And here's a new, asking him questions, and Tom Lane is like a titan of the Postgres community. But again, I think he just exemplified that spirit in Postgres as well. Awesome. Captions. So today's live stream is available with captions in English, but the videos of the talks will be available in 16 languages and on YouTube as well. And I mean, these are really high quality captions, have been reviewed, so it's not just auto-generated captions as well. But
yeah, and don't be mistaken how hard it is to get captions right. Someone once told me how many ways the automated capture creator tool has, I think, over 30 ways to write Postgres in the caption, like all kind of combinations we as humans wouldn't even think of. So going through these lines, creating these captions, it's a lot of work. And I really want to emphasize how much time this takes and how much you should enjoy them if you need them. It's a really, really important thing.
Absolutely. Gratitude to the speakers. It takes a lot of time and effort for folks to create the content, to share the knowledge and the experience with the rest of us. And that this is what we are all here for. So again, huge thanks to all the speakers here as well.
Yeah, let me ask you something. If you have to give because all talks are roughly 25 minutes, right? Does it take you more or less time to create a 25-minute talk with respect to a 45-minute talk?
It is challenging because once you start diving into content, to think about squeezing that into a 23-minute or 25-minute talk and still getting the message across is tough. It is challenging.
Yeah. I remember a quote. I'm not sure it was Churchill or some former US president, but he said, like, I want to talk for a minute. I need to know 2 months in advance. If I need to talk for 10 to 15 minutes, I will need a week. But if I can speak for an hour, I can start right now. So yeah.
Oh, that's a nice quote.
Yeah. So it's really hard to get your content and your message and your storytelling all in 25 minutes and get a really compelling story together.
Yeah, absolutely. There's also an ultimate guide. So there are a lot of talks in this event. So if you want to help, if you need help sort of navigating the conference, there's an amazing guide which walks into this, is aki.ms/Posette-guide. And it really helps break it down into 4 different groups, including core talks, ecosystem, Azure, and then a couple of keynotes as well.
It's really easy, right? 2 times you have to deal in at 8, and the other 2 days you have to dial in at 5, and then you watch them all.
That's the guide. Awesome. Yeah, you want to talk a little bit about the hallway track?
Yeah, because the social part is a really important part of any event, and this is a online event, so we can't bump into each other, but there is a Discord, and we encourage everybody to join the Discord channel, ask your questions to the speakers. I think today all or almost all of the speakers are available around their talks, so you can ask your questions after the talk and ask anything you want, right? Keep it maybe to the technical, not everything, but you know what I mean. Be respectful, be open, be curious, and ask whatever you want to ask. And hopefully, if you're not part of this community yet, you make good contacts and you will be part of this community next year.
Yep, absolutely. And like Derk said, if you have questions for the Posette speakers, they will be available, especially during the live streams of their talks on the Discord channel. So that's a great opportunity for you to ask questions about the content as well. Survey. So there are 2 different survey links. One's about each talk. And so there's a link, aki.ms/Posette-survey-talks-ls1. You can actually go, that's for the live stream one, and you can go select a specific talk that you want to give feedback for. And there is also an event survey, right? And feedback is a gift. Feedback is gold, right? So the socks are more of a nice to have, but what the speakers and what we as a team are really looking for is feedback and opportunities for us to improve as well.
Yeah, and I want to add a little bit to this, because sometimes you give feedback, and then as a speaker, I also get feedback, and people say, like, it was a nice talk. And it's like, yeah, thanks, but that doesn't give me anything, right? I mean, it's nice to get compliments, don't get me wrong. But what I love to hear from you is like, what is the one thing you learned? Or where did you drift off? Where did you came back? If I have to reduce my talk to half the time, what are the parts you would definitely keep in? Or what part would you leave out? So tell the speaker something to work on. And maybe the speaker doesn't agree with you, or maybe you are the only one giving this specific feedback. But the more feedback you give and the more clear you are on how to improve, the more the speaker can learn and develop. And yes, be friendly, but be also honest, because we as speakers can only improve if we get honest feedback. So please give your feedback.
Yeah, amazing. Awesome. We also have swag. So this is limited. So it's 1 per person per live stream. And you can get yours by getting a code. So you just ask for a code in the Discord channel, you'll get a code. And then if you go to that link, you can get a swag sticker pack as well.
Are you a collector?
Behind.
Oh, sorry.
I am a collector. Yeah. I mean, I have a bunch of them on my laptop as well, all given by Claire too. Yeah, Derk, you want to quickly walk through the socials?
Oh, I'm really bad at socials. I know logo. The X is probably X, but you really need to help me out here.
Yeah, I mean, there's Discord, LinkedIn, X. I think that's Blue Sky. And I actually don't know what's the last one. But if you are... Mastodon. Okay, got it.
Yeah,
if you're using social, please use the hashtag PosetteConf hashtag as well, so that you get tagged today. So let's look at the schedule for today's sessions. 11 talks in this live stream, some amazing ones as well. Derk, any ones you're looking forward to?
Yeah, I wanted to ask you the same question, and then I was thinking, like, should we ask each other this question at this moment? We had the luxury of already watching them because we had to prepare. Maybe I will share one thing. I think I learned most from the MCP talk. Maybe that's a good way. That's what I most learned from.
That was a good one as well. I looking forward to all of them. Actually, like you said, we've seen them. There's so much amazing content in all of these.
Really good.
Actually, and then let's key up a trailer for live stream 1.
Hi, I'm Charles Feddersen, and in this talk, you're going to learn about all of the ways that we're driving Postgres forward at Microsoft through open source, cloud services, and building amazing tooling for developers and database operators.
Hi, my name is Affan, and in this talk, you will learn about how Microsoft is contributing to the open source Postgres project.
Hello, my name is Boriss Mejias, Solutions Architect from EDB, and in this presentation, I'm going to try to show you how to use the JSON data type in Postgres for the best. Because some people have trouble with this data type, they even consider it evil, and they think that the B in JSON B is for beast. But we can tame this data type so that it provides you the best for your database schema, and that you're actually going to enjoy this data type and love it as much as I do.
So hello, my name is Tomas Vondra, and I'm here to talk about random page cost, one of the important configuration parameters in Postgres affecting planning. So if tuning Postgres is part of your job, you might be interested in this talk.
Hi everybody, my name is Adam Wolk. I'm a technical program manager at Microsoft for PostgreSQL. Today I'm going to talk about fuzzing PostgreSQL and knocking at its door, essentially. You will learn what fuzzing is, how to start your journey with fuzzing, and if it is for you, and how to approach a large complex code base like a database.
Hi, so I'm Chris, and we're going to be talking about Postgres design patterns. So this is a talk primarily for application developers, and we're going to go through a number of design patterns that I've used across 20 years of using Postgres. The talk itself is going to focus on one particular application and all of the different Postgres features that I used to make my life easier as an application developer.
Hey, I'm Pamela, and I'm going to be talking about building a MCP server for your Postgres database. We're going to look at the range of ways you can build MCP servers, from very exploratory servers where the agents can send full SQL queries to your database and do all sorts of things, maybe things you don't want, and then look at fully typed operational servers where you can have maximum confidence in the SQL that's going to get executed, but agents can still get their questions answered. So join me to learn more about building an MCP for your DB.
Hi there, my name is Matt McFarland, and I work on Postgres developer tools at Microsoft. This talk is about how our work around the VS Code extension for Postgres management is moving to a new set of tools to support new workflows that are emerging for database administrators and developers who are working on their applications. Please check out this talk if you are interested in AI-enabled workflows and managing your Postgres database with them.
Hi everyone, my name's Christian Miles, and I've been working with graphs and graph databases for about 15 years. My talk is about a Postgres extension called Apache Age that helps you run graph workloads on top of relational data stores. I'll be walking through the graph database landscape and where Age fits in and how it compares with other extensions like PG routing. And then I'll focus on something I'm really passionate about, graph data visualization. When to reach for it, when to reach for Apache Age, and the pitfalls to avoid along the way.
Hey everyone, my name is Andrew Ruffin, and I'm a product manager at AMD. This talk is about the Azure infrastructure choices you have and how that choice can improve your Postgres performance by over 60%, including the economics you care about day in and day out. This talk is best for database administrators or IT decision makers who are looking to optimize their cloud footprint when it comes to Postgres.
Hi, I'm Paula Berenguel. Have you ever tried to build expertise across a large organization? I have been doing this for over 2 years, and I will share in this talk what worked well, what didn't work really well, and what are the pitfalls.
Hi, my name is Taiob. I'll be talking about SQL Server and Postgres security model differences. This talk is for someone like me who is an accidental Postgres DBA coming from SQL Server world, and we'll be comparing and contrasting the security model differences between the two database platforms.
Awesome.
That looks good, right?
Yes, it looks
It's going to be a nice day.
All right. Given that we're already a little bit behind, let's kick off with the keynote. So Charles Feddersen heads all of product for Azure Postgres. Affan is the VP of engineering for all of Azure Postgres and also my boss. I think this is going to be an interesting keynote talking about all the work that Microsoft is doing on Postgres. So maybe let's kick it off, right?
Yeah, let's dive in.
Hi, I'm Charles Feddersen, and in this talk, you're going to learn about all of the ways that we're driving Postgres forward at Microsoft through open source, cloud services, and building amazing tooling for developers and database operators.
Hi, my name is Affan, and in this talk, you will learn about how Microsoft is contributing to the open source Postgres project.
Hi, everyone. I'm Charles Feddersen. I'm the Director of Product Management for Postgres at Microsoft. Welcome to Posette 2026. Today, I'm joined by Affan, who's the Vice President of Engineering for Postgres at Microsoft, to talk about the different ways we're working to drive Postgres forward at Microsoft. But before we get started, I'd like to quickly reflect on our Posette journey. We're now in our 5th year running this virtual conference, and it's great to see how Posette has evolved into a recurring event on the Postgres community calendar. When we started Posette, it was a bit of an experiment. There were so many fantastic in-person events for Postgres being run all over the world, and with so much online content, we weren't sure whether a virtual conference would succeed. But 5 years later, the conference continues to grow, with more speakers submitting great sessions and content from past conferences continuing to be consumed. This year, we had a record 238 talks submitted to the event, and content from past conferences has now been viewed over 380,000 times. Thank you, everyone who submitted to speak this year, and we appreciate the time and investment you made to submit these great sessions. And of course, events like Posette don't just happen. This year, we have a great organizing team spread between the US, Europe, and India who balance the Posette workload with their core day-to-day roles. I'd like to thank Aaron, Claire, Cornelia, Gary, Henry, Jeremy, Linda, Pooja, Sriram, and Silvano for their effort to put together this great event. But the hardest task of all is selecting the sessions. As I mentioned, this year we had 238 talks submitted. I'd like to thank Claire, Daniel, Divier, and Melanie for their work to finalize the talk selections this year. Now, for the remainder of the session, Affan and I will talk about 4 different aspects of how we're driving Postgres forward, which includes the open source project where Microsoft is one of the largest committers to the upstream project, Azure services, where we're enhancing Azure database for Postgres and have just launched the public preview of Horizon DB. And finally, our investments into tooling to deliver AI-enhanced capabilities for database development and management. So to get things rolling, I'm going to hand it off to Affan to talk about open source. Over to you, Affan.
Hi, everyone. I'm Affan, and I lead the engineering for Postgres at Microsoft. First off, when we talk about building Postgres the right way at Microsoft, we're really talking about responsible open source participation at cloud scale. Postgres runs some of the most mission-critical systems in the world, and our responsibility is to strengthen the ecosystem. So through our team of committers and contributors, we engage and deeply invest in core areas of Postgres. Secondly, we have the privilege of running Postgres at a massive scale across the globe. This gives us a perspective on operations, reliability, and tenancy issues that only appear at a very large scale. And our open source team brings many of these learnings back into the upstream project, which benefits the whole ecosystem. Finally, our committers and contributors often engage directly with our enterprise customers running their mission-critical workloads on Postgres to solve operational and sometimes functional issues. This gives our open source teams deep exposure to how enterprises are using Postgres in Tier 0 workloads. Improvements and bug fixes as a result of these interactions go upstream and again, benefit the whole ecosystem. In Postgres 19, Microsoft made about 345 commits to the upstream project and changed around 64,000 lines of code. These contributions were made over a number of different areas, but many centered around our work on the query engine, asynchronous I/O, and observability. Let's go over some of these in a bit more detail. Query planning and execution saw notable gains, including row decoding improvements and support for parallel TID range scans. Foreign key checks during inserts will also be significantly faster with the new fastpath, using compiled code instead of incurring SPI overhead. We also co-authored new SQL capabilities with the support for SQL property graph queries that enable native graph pattern matching. This work represents one of the largest single feature additions in the Postgres 19 major version. At the storage and buffer management layer, the team delivered major architectural enhancements, setting the stage for Postgres 20 improvements like buffer elasticity and using async I/O for writes. Updating the visibility map during access will improve index-only scans and greatly reduce wall volume. Finally, the team expanded Postgres' introspection and performance tooling with the new Explain I/O infrastructure, which adds visibility for I/O operations. Microsoft also worked with on critical CVEs, underscoring our commitment to Postgres security. Postgres' manageability also becomes much easier in Postgres 19 with automated resizing of the I/O worker pool. Collectively, these contributions strengthen Postgres' performance, envelope, standards compliance, and operational transparency. They also lay the critical groundwork for the next generation of cloud deployments. Now I'll send back to Charles to talk about Azure Database for Postgres. Over to you, Charles.
Thanks, Affan. Now, turning to Azure, we've continued to ship new feature enhancements to Azure Database for Postgres on an almost monthly basis. And while we've made improvements across the entire service, today I'm going to focus on just a few performance, scalability, and uptime improvements we've made to make sure it's easier to run your Postgres workloads at scale. Last year, for the first time, we shipped the new major version of Postgres in Azure on the very same day that the community announced general availability. This meant that our customers had access to the latest Postgres 18 features immediately, without waiting for any cloud lag. And this matters when newer versions bring real gains to performance, like query planning and observability, like Affan just talked about. Azure customers can standardize versions faster, reduce their version sprawl, and keep development production aligned with the community release cadence. Next, we announced the general availability of near zero downtime scaling to address one of the hardest production problems, scaling capacity without interruptions. Customers can now scale compute up or down, and the application just experiences a failover. And this provides significantly improved availability during these scaling operations and helps avoid over-provisioning or static configuration of compute. And for performance, we announced the general availability of SSD v2, which supports up to 64 terabytes of storage, up to 80,000 IOPS, and up to 1.2 gigabytes per second of throughput. But most importantly, these disks support independent scaling of each of these scale points. This enables you to perfectly fit the size and throughput of the disks to your workload. These disks are now deployed in 46 Azure regions today, and you can upgrade from SSD v1 easily using a replica and planned failover. Next, cascading read replicas enable you to extend read scalability beyond a single replica tier. With this feature, replicas can themselves be the source of other replicas, enabling global scale read distribution and better isolation of read queries, which reduces the load on the primary server, reduces read latency for globally distributed applications, and provides architectural flexibility as workloads evolve. Now, to show you how cascading replicas worked, I've asked Gary to provide a quick demo. Take it away, Gary.
Hi, welcome to the demo of Cascading Read Replica. In this demo, I'll walk you through how to create a cascading read replica and then show how to perform a switchover operation between an intermediate and cascading replica. Let's start by creating a cascading replica. This is my primary server. From the left-hand navigation menu, I'll go to the replication blade. On the replication blade, I'll select the read replica server. From there, I'll again navigate to the replication blade and click Create Replica. Since I'm creating this replica from an existing replica server, the source server is now read replica. I'll provide the server name, fill in the required configuration details, and click Create. Read replica creation is in progress. Now you can see the read replica creation is complete. It's listed under parent read replica in the replication hierarchy. Now, let's look at the switchover operation. From the Azure portal, you can click on the promote button to perform switchover. I'm going to use Azure CLI to perform the switchover operation. Let's do AZ login, then run the command for switchover by adding the resource group name and replica server. The switchover operation is in progress, and now you can see that the switchover operation is complete. The role of the intermediate and cascading read replica are swapped, and the replication chain is maintained. Thank you.
Thanks, Gary. Now, finally, with Elastic Clusters, we brought the horizontal scalability of Citus directly into Flexible Server. Instead of trying to pack large applications into a single Postgres server or implement application-level sharding, which could become complex and operate at scale. Elastic Clusters, a new feature of Flexible Server, enable you to deploy a cluster of Flexible Server instances to distribute your workload across multiple machines and multiply the throughput of your application. It looks like a single logical database to your application, and you can shard your data in one of two ways, either distributing tables using sharding keys or by the schema where an entire schema resides on a given node. Each approach has benefits and trade-offs, and the best approach will really depend on the nature of your application. Together, these features focus on performance, scalability, and operational simplicity to make Azure Database for Postgres more performant and easier to use. But this is only part of the Postgres on Azure story. A few weeks ago at Build, we launched the public preview of Azure Horizon DB. And I'm going to hand it back to Affan to talk about some of the key architectural enhancements in Horizon DB and how we're innovating to make it the best platform for new and existing Postgres applications. Back to you, Affan.
Thanks, Charles. Azure Horizon DB is built for enterprises that need scale, high availability, and modern intelligence without compromise. It delivers elastic scale across storage and compute, enabling you to handle the most demanding transactional and analytical workloads without redesign. Built-in resilience ensures sub 5-second failovers, keeping applications continuously available and minimizing business disruption. Horizon DB is a cloud-native Postgres service built from the ground up with a disaggregated architecture that lets you scale storage independently from compute and share that storage between the primary and read replicas. It supports up to 192 cores with sub-millisecond commit latencies and a sub 5-second failover time. Horizon DB scales up, it scales out across both the compute and storage tiers. Now, let's look at some of the late-breaking AI features that are part of Horizon DB. Vector search and AI capabilities run natively inside the database, so you can build intelligent applications directly on your operational data without moving it anywhere else. Our disk canon implementation gives you better accuracy, higher recall at the same memory footprint. It compresses vectors more efficiently, so more of your data stays in fast memory instead of slow disk. And it computes similarity faster, which means lower latency at query time. We also built AI model management directly into Horizon DB. With a single click, Horizon DB provisions 3 models on Microsoft Foundry, one for generation, one for embeddings, and one for ranking, and wires them directly into the database. Functions like extract, create embeddings, and rank just work out of the box. No setup steps, no glue code, no jumping between services. And if you'd rather bring your own models from Foundry, you can register those too in just a few steps. Every GenAI app rebuilds the same pipeline: chunking, embeddings, sync, retries, backfills. Today, that logic lives in external pipelines, which quickly become fragile and hard to manage. AI pipelines brings that lifecycle into Postgres with the declarative model to build, run, and monitor end-to-end AI workflows in one place with durability, retries, and production-grade execution built in. Now, to show you how AI pipelines work, I've asked Abe to give you a quick demo. Over to you, Abe.
Hey folks, I'm Abe. Today, I'll be using AI pipelines in Horizon DB to show you how little SQL code it takes to stand up a real AI pipeline directly inside Postgres. No external orchestrators, no glue code, just Postgres. So here's our starting point: a table with a few products in a store catalog. Now, watch how easy it is to make this table ready for vector search. The AI pipeline is fairly simple. It takes the data from the source, which is a document table, chunks the content, and then embeds that content using a text embedding model. and it's retriggered every time the data is updated. That's the whole pipeline. Literally an array of steps. So now let's run the pipeline. Behind the scenes, our docs just got chunked, embedded, and dropped into a vector-ready sync table. To make it easier, I created this custom dashboard to visualize the pipelines and the steps. Let's check it out. As you can see, the pipeline was kicked off with several steps. Most notably, the embedding step took the longest time. Let's click into it. As you can see, it used the right model to embed. And then let's also see what happens after. And after that is run, we can see that the chunks were created and each doc has multiple chunks, just like we expected. Let's go back into VS Code and do the vector search. I'm going to search for wireless headphones for travel and focus work. And let's see what gets returned. As you can see, it returns the chunk text that's most similar to my query, as well as the related doc IDs. And of course, the first few rows return chunk text with things like headphones and noise cancellation. So this RAG pipeline definitely worked. Now here's the part I really want to show you. I'm going to go ahead and add a new row about Apple AirPods, and let's see what happens to the pipeline. Pretty boring insert statement, right? Except the row is already being chunked and embedded. This is because we set the pipeline to run on table change. The pipeline notices that new row and processes only the delta, not the whole table. So let's run the set vector search again with Apple headphones. Nice. As you can see, AirPods come at the top because that row was automatically chunked and embedded in our database. And there you have it, an AI pipeline that reads like SQL, updates incrementally as your data changes, running in Postgres. These pipelines also support other complex workflows, such as data enrichment, approval workflows, and job scheduling. Everything you need to run a production-grade AI pipeline.
Now, to start wrapping up, I want to talk a little about how we're delivering tooling to make developers and database managers more productive on Postgres. About a year ago, we shipped a new VS Code extension for Postgres to help eliminate the constant context switching between building apps, optimizing databases, and just operating Postgres. It's available in the marketplace, works with any Postgres, and has some extra Azure integrated capabilities with support for everything from provisioning to monitoring and even migrating. It's been installed over 500,000 times in the last 12 months. We've got great feedback and asks from the community that we're shipping quickly to close some key gaps and increase functionality. As I mentioned, the extension works with any Postgres database, whether it's in any cloud, on-premises data centers, or even a local instance running on your laptop. It provides schema visualization, database context-aware Postgres code development, and real-time monitoring, where you can launch Copilot with automatic prompting directly from the resource usage chart and let the AI do the debugging for you. And the extension is also deeply integrated with Azure, where you can natively provision both Flexible Server and Horizon DB directly from the extension using the same familiar flow as the portal. And you can also review and modify server parameters. You can manage server backups and even clone a server where you have the choice to clone without data, which is a great way to quickly snap a new server with the exact configuration and settings, or with data if you need a quick dev test platform. But one of my favorite new features is visual query execution plans. Developers can check their query plans directly in VS Code and see how the query is actually being executed, and use Copilot to explain steps or debug issues. This shortens the loop between observation and fix, and it's a fantastic application for AI to enable developers to move faster without requiring deep planner expertise. For Postgres on Azure, the extension becomes an operational control plane directly inside the development environment. Developers and operators can provision servers natively, adjust server parameters, clone databases without managing backups, or without leaving the editor. Ultimately, the result is a tighter feedback loop to build, observe, optimize, deploy, and operate Postgres using a single extensible tool, assisted by Copilot, and integrated with Azure when you need it. Now, to show you how all of this works in VS Code, I've asked Matt to give you a quick demo. Over to you, Matt.
I'm working on our order service dashboard, and the query to show top customer spend in the last 90 days is a lot slower than I anticipated. Let me run it. Over a second for a query that should be instant. Before I start guessing, let me see what Postgres is actually doing. I can open up the new query plan visualizer and see the plan in just a few clicks. Right away, I can see what the problem is. Let me check out this sequence scan on the orders table. I'll click on the node to get details, and looking at the conditions, I see this is my filter, and there's a surprising cast here. Let me ask Copilot what's going on. It looks like the created at column is stored as text, not a timestamp. I think this is probably from when we bulk loaded this table from a CSV. It worked fine back then, but now it's causing problems. So the fix isn't a new index, it's fixing the column type. Let me search for this table so I can find it quickly, and I'll open up the new Object Properties view to see if I can understand why this column is text and not a timestamp. Here I've got all the details about the table, including its definition and security properties. Let me check out the columns. Sure enough, it's a generated column that's computed from created at. I can't just change the type on created at. Postgres will refuse because this column depends on it. So this isn't a one-line fix. I'll have to drop, alter, and rebuild the index. It's not the kind of schema change I want to try on my working dev box. Since this is an Azure database for Postgres server, I can use our new clone server feature to create an independent copy of the server, including all the data, with just a few clicks, and test my migration there first. This is going to take a point-in-time snapshot of the whole server, so it'll take a few minutes to be ready. Great. Now that it's done, the clone server is automatically connected in my Object Explorer. So I'll just run the alter query that Copilot helped me write to change the column type. And once that's applied, I'll run the orders query without the cast and verify it works. Just over 200 milliseconds. That's what I was hoping for. Let's check the plan on this new query and confirm we've lost that expensive sequence scan. Looks good to me. I think I'm ready to apply this migration on my main server.
So we've covered a lot today, and this really reflects both our depth of investment in Postgres and the velocity that we're moving. In Postgres 19, we've committed many of our learnings to the open source project. We've added an array of new features to Azure Database for Postgres to improve performance, scalability, resilience, and manageability. And these aren't small changes. They're meaningful advances designed to help teams run Postgres with confidence from the smallest workloads to the most demanding mission-critical systems. We also took a major step forward by making Azure Horizon DB available to everybody. With Horizon DB, we're rethinking what's possible for Postgres at cloud scale, bringing together elasticity, performance, and simplicity in a way that unlocks entirely new scenarios for modern applications. And on top of all of this, we've delivered new tooling that meets developers and operators where they are, simplifying operations, accelerating development, and giving teams deeper visibility and control across the entire lifecycle of their applications. This progress is the result of close collaboration with our customers, partners, and the global Postgres community. This is a shared journey, and today's topics are just the beginning of what's ahead of us. Thank you for spending this time with us today. We're excited about what's next, and we hope you enjoy the rest of the conference. Thank you.
Thank you, Charles and Affan, for this great introduction into this 5th Posette episode. It's really cool to see where Postgres is heading and evolving. I had a really interesting chat earlier this year with someone, and the person mentioned to me, like, you get the best databases when the committers and the users are actually really close to each other. And I think Microsoft now is using this mix to really speed up the improvements on Postgres. So yeah, really curious to see where it's heading.
Yeah, awesome. It was a great talk and a great overview of all the work. Some really exciting features. I know Matt McFarland is also going to talk about the VS Code extension later today, and then a bit of a deep dive into that as well.
Yeah, I've seen some teasers for other talks as well in the keynote. So yeah, it's really nice. Right, if you have any questions, please ask them in the Discord chat. There's already quite some rumor going on there. So please join us, use the QR code, and we see you there. Also, please leave your feedback. After a talk, you can get some nice swag in the end. You get a voucher at the end of the survey, and then you can use that one to get your stickers. And next up, Boriss. I'm really excited. Boriss is a really good friend of mine, and I really admire him for his talks. He can basically make any topic interesting. And he told me the trick of the swabbers. The swabbers is a way of designing stories for your talks. It's somebody wanted, but so. So I'm really curious how I managed to create the storyline into the JSON fields.
Yeah, I mean, he's makes any topic seem interesting. So I'm excited to see the talk as well, and want to learn more about the swabbers method too at some point.
All right, Boriss, take us away.
Hello, my name is Boriss Mejias, Solutions Architect from EDB, and in this presentation, I'm going to try to show you how to use the JSON data type in Postgres for the best, because some people have trouble with this data type. They even consider it evil, and they think that the B in JSON B is for beast. But we can tame this data type so that it provides you the best for your database schema, and that you're actually going to enjoy this data type and love it as much as I do. So, JSON in PostgreSQL. This is, as I said, there is two data types, JSON, which is the most basic one that just support the basic stuff, and the JSON B. And this is where people start thinking like, is this for beast or not? Because I'm seeing some evil behavior. And actually, it is not like that when you learn how to work with it. It's like kind of, it needs some comprehension, it needs some care. And we're going to show you not syntax specific stuff, not super complex queries on JSON. It's more about designing your data schema so that it matches what you need JSON for. And why do you need JSON for? I mean, why does people want to use JSON anyway? Well, the major reason that I think that people want to use JSON is not just because the objects run on the application with JSON objects, but it's because of schema freedom. Usually freedom is actually associated with evil stuff. That's why heavy metal music always talks about freedom and these kind of topics. And they say, like, oh, this is evil music. But no, it's just freedom what we are searching. So let me explain you a little bit what I mean by freedom in terms of data. Imagine that you have a collection of images, documents, videos, and all of them have a name, some attributes like when it was created, but they also have different type of data, metadata, based on the type of object that you're using. For instance, an image will have its height and width, which is specific to a picture, not to a PDF, for instance. But then some pictures, they will have also, if you took it with your phone, or you add it then afterwards, a latitude and a longitude to specify where this picture was taken. For instance, in this case, coincidence, it is in the place, the first venue that I saw a metal band playing in Chile. Now, in the other one example, for instance, you can have also the container of the video, which is OGG, for an interview of Slonic talking about Postgres, which is exactly the same time of one of my favorite metal songs. Now, if you want to have a use case to understand better what we are going to be talking about, it's always nice to have something that you understand. And I understand metal music, and that's why we're going to be using it again. Now, let's look at JSON object describing a metal band. The metal band, if you want to put it into your database so that you can find it and then associate all the data with this metal band, you will need to have an identifier, and then it's going to have a name. In this case, we're going to use the Swedish metal band Ambush, which has some different genre of music. This is from the new wave of traditional heavy metal. They started in 2013, and they are still playing until today. And the songs are about evil stuff, occult stuff, but also a lot of stuff anti-totalitarianism. Very long word, but it's a type of music that they use. Now, all this type of information that I gave you about the band Ambush could be completely differently structured for a different band, and that's why we have this freedom with JSON objects. Now, the JSON objects, we are going to have to put them now in a database to find information. So this is where we are going to see whether it's going to fit or not into our structure. So we are going to create a table, and I was discussing with a good friend about the usefulness about pen and paper. So I do my drawings about data schemas with pen and paper first, and then I try to match it into code. So in this case, I have a table, an entity, which is bands, and it's going to have just one single JSON object. Now, what is going to happen is that this metal band is going to just have the band, JSON B object, and that's it. Another recommendation here, usually we don't use the public schema because it's too mainstream. So we created here the schema metal, and it actually, the table itself reads much better. This is metal bands. Yeah. Okay, so we have our object there, and we say that we want to identify them uniquely. By name, it might be a little bit difficult because if you search for bands named Ambush, there are many of them. Actually, the one that I like is called Ambush Sweden or something like that. So what we want to have is an identifier, a number that is going to be unique. And see people say like, this data type doesn't give you this uniqueness of key. Well, you can do it in Postgres. And if in Postgres you say, I want to create a unique index on the metal bands table using, and here you're going to see that in parentheses, double parentheses, have the attribute band with an arrow, with a double arrow. That means I'm going to go inside that field and inside a little bit more to extract the text from it. That text, which is on the field ID, it have to be unique. So we'll never have duplicates on this JSON collection, which is very good. So it removes a little bit that this kind of lack of relational properties. We are going to see that it's not enough, but at least you can do it, which is good. So let's look at albums, because metal bands, they play live concerts, which is the best thing to have, but also they record music in albums. In this case, we have 3 albums, the last albums from the band Ambush. They have different years, and they have an ID also as a band, as an album, and they refer to the ID of the band as well, which it is a typical design that one band has many albums, right? So we draw it on paper, and we have this. Now, the thing here is that you get a little bit complicated, and here's where we see the limitations, because how do I refer from the album to the band if I have JSON objects? I can have uniqueness of IDs, but I cannot have foreign keys, and we want to have foreign keys. So what we are going to do now, it is in our design to extract this bad behavior, is that this unique ID, actually, we're going to turn it into a primary key. So instead of creating the table like that, I'm going to create it actually with one attribute, which is a big integer, and it's my primary key, and I'm going to move it out of the JSON object. So this is the first principle. When you see that there are some things that are more useful outside of the JSON object, you can do that, no problem. And then what I'm going to do now is I'm going to create the metal album, not even as a JSON object, because they all have an ID, a band ID, which is a foreign key, as you can see here, references metal band ID, and a title, which is the name title of the album, and then the year that the album was published. Then you're going to have songs that refer to the album, or you have an JSON object with all the songs there. Yeah, it depends on how you want to shape your objects. Okay, so now I have this diagram where I can clearly see where is the reference from the band to the from the album to the band that record this album. All right, now obviously there is a lot of opinionated people in the world, and they make reviews of albums. Some of them are very useful, and so we're going to talk about those people who really want to talk about the music in a very objective way, and not just being like, oh, this band that sucks. But anyway, so let's look at this one. It's an example about one of the bands, one of the albums, sorry, and it talks about how this Swedish racing force is more evil than ever in this last album, the evil in all dimensions, of course. Interesting here is that it has its own ID, the review, but it refers to the ID of the album. This is going to be useful that we have this as a primary key, so we can refer to it as a foreign key. But look at it, the two fields, score is a float number or a double number, a real number, and then from 0 to 1, and then you have the content of the review, which can be a very, very long extended text. We are going to get back to that. So the two first one, we are going to take them out of the JSON object, and we are going to use them as primary key and foreign key. So here we have it, ID, album, primary references the other one, and then you have the object with the entire review. Now we complete our design, and we have a very beautiful relational entity relation diagram, which I think it's very useful to establish some properties of uniqueness and integrity of your data. So let's look at how we use the JSON object now inside each of these tables. Let's index stuff, because if you just do full scans, it's going to be too slow. We know that. It's going to load too much data on the RAM, so we just want to create some indexes, and sometimes we're going to resolve some of the queries just by using the indexes. So let's see some of the possible indexes that we can use. it is said in the documentation that if you have a composite value, for instance, like a JSON or an array, use gin. Yeah, it's like in some bars they say like if you want to drink tonic, put gin. In the same case here, composite gin. That's it. Gin is for inverted index. That's the I and the N, and it means that it's going to take the elements that are inside your composite, and it's going to create an inverted index going from those to the places that you have to find the information. Right, I'm not going to go into too much details of that because that would be a completely different presentation. But let's look at the album here. Sorry, the metal band ambush. Yeah, we are going to take this object into a table that we set. We have the ID as one particular column, and then we have the band, which is the entire object. That object actually is what we are going to index as a gin stuff. Yeah. So you create your index on the metal bands table using gin, and then you put into double parentheses the band itself. So you take the object that is inside the band and you can index that. Now that might not be as useful, I think, but it's possible. So you can start with that and see where it goes. The problem is that people say, oh, but this stuff is evil. Look at the size of my index, because the size is almost the same size of the table. Yeah, that's true. So let's go a little bit deeper and see where do we really need indexes, because indexes are useful based on the queries that you run on it. For instance, I would like to search for names of bands or the style of music that they play, the genre. Okay, so let's look at this. Here's our table. We have here that the genre is not only one type of, well, some of the bands, they have one, they just play thrash metal, that's it. Or some of them just play like black metal, and they stick to black metal until they die. But this one plays either heavy metal, speed metal, or now it's called new way of traditional heavy metal. So you have multiple ones, that's why they are inside an array, and that's beautiful in a JSON object. So that's a composite inside a composite, so we can actually index that particular one. Let's do it. So we create an index for the genres of a band using gin indexes, and we, in this case, look at the arrow. It's a single arrow. If I would have put a double arrow there, I will go inside the field and I will extract the text, and that wouldn't be so good for a gin index. A text is not good for gin. Well, in some cases, yes, but I want to have the elements of the array. So I want to have the object. That's why I use a single arrow there. Band, single arrow, genre. Okay, but I can create other stuff. What about B-tree indexes? Well, if the value is a scalar value, just text, for instance, then I can use a B-tree. So for the name of the band, this one, look, I'm using the double arrow because I want to extract the text of the field, which is the name, and then I can index that with a regular B-tree index. Yep, this is what we usually have for every column in Postgres. So as you can see here, now we have the object and we have two types of data inside the composite. One is text, one is array, and we use two different type of indexes depending on what we are using. And that's how we start taming this beast. We start understanding how it behaves. We understand how the data inside is being stored. And this is what is going to make us work more with the developers of the application, because they know more about the data, and the DBAs are going to also be helping you to create the indexes. So this is about collaboration between human beings as well. All right. So there is another directive, as I said, composite use gin, that says like for text use 3 grams. 3 grams is a super underrated type of index that I love it. It takes the distance between 3 characters, and like that is going to find similarities, and it's going to be super fast. The size of the index is also quite small compared to other type of text search stuff. I also have some vectorial things, and it's very, very powerful. And we can use it here with gin, and this is the way of using gin with text for one particular one that I think is interesting. We are going to look at, again, at the metal album reviews. And in the reviews, we find that the content, it can be very, very large, because here's where the journalist or the metal fan is going to start writing and writing and writing about the album, all the passion, all the emotions, everything that comes by listening to this album. All right. So that particular one, so you see we have a table with 3 fields. The third one is the object, and then you have inside that object the content. That's the one that we are going to index with 3 grams. So we do it like this. Before we create the index, we need to create the extension. Create extension. This is just in Postgres contrib. You don't need to install untrusted code that you don't know who is maintaining. This is from the Postgres contributor. And then you put it in the schema metal, the one that we are using, and then the index is going to be created as follows. We say the name of the index on the metal reviews, and then using gene, but with the operation of the gene trigrams operations. And again, I'm not going to get the object that is inside the field, but I'm going to get the text that is inside the field. That's why I'm using the double arrow. Okay. All right. So now we know how to use the correct type depending on what structure of our JSON object is giving us. Let's continue now for some other stuff. They say like, okay, but I still don't like it. People say all this dynamic data typing. I want strong typing, especially if you like metal. Some people like strong stuff. There are some very soft sounds as well. Especially, I would say the emotions are strong, but talking about soft feelings as well sometimes. Heavy metal goes much more beyond the mainstream comprehension that we observe from the outside. So we want strong typing. How do we do that? Let's say that we were talking about the score of the review that goes from 0 to 1. That means that I want to have there a double precision type of value if you're talking Postgres term, a real number if you're talking in mathematical terms. So that particular one, what we are going to do is we're going to create an index which is going to cast the text that comes from that field. That's why I use the double arrow. I'm going to say, cast this into a double precision. If somebody tries to insert a JSON object where the field score is not a double precision, this is going to fail. So it's going to guarantee you that every time that somebody puts a score there, it has to be matching double precision. And this gives you a strong typing for fields inside a JSON object. Some people praise the fact that said, then we should have schema definitions for all the fields in the JSON object and be explicit about all the specific data types. But in that case, why don't you just use columns? I mean, I like JSON objects because they are dynamic when you need them, and they can be with some guarantees when you want them to be like that. Like, I want to have a unique value for this field, or I want to have all these values being double precision, which is with this index. And so, like, isn't it weird to use an index for a constraint? Well, yeah, an index is kind of a unique index, for instance, is a constraint, basically. But you can also just add a constraint. So let's do it like this. We alter the table metal reviews, we add a constraint, numeric score, and we are going to say, check this constraint, which is the function pg input is valid. So we're going to validate this input, which receives two arguments. One is the score, and the other one is the type that we want to get, double precision. If it fails, it's not going to accept this value. Now, the index, of course, is going to help us also to search for, give me the reviews that are in value higher than 0.666, just to give you a number randomly, you know? All right, good. So there are some type of JSON things that you could use, like JSON in SQL, like this one, for instance. I'm going to add a constraint, which is called a scalar score, which says that the object, see that I used now a single arrow, is a JSON scalar. But be careful, this one is not going to be guaranteeing a number. It can be also a Boolean or a text. It just guarantees that it's not an array or another JSON or something else. Well, look at the documentation of scalar. I might be wrong about all the possibilities there, but it's not just numbers. But this gives us an opportunity to like, if I can say like, if this is something JSON, I could use it for something else. And remember that we were doing an index, which is a gene index for arrays, which means that for the genre, so I want to have the genre always as an array. If somebody by accident put just black metal, because it's the only style that they play, it should be an array with one single value, which is black metal. So we can add then a constraint saying that the genre have to be always an array. And like we do like that. The object that comes in the field, that's why I use only one single arrow, is a JSON array. And like that, we guarantee that. And our index is going to give us good results. Gene is also going to be able to index all the stuff, but I mean, we want to have arrays, otherwise the index is not going to be helpful. All right, so let's get back to the concept of schema freedom. What do we mean by schema freedom? I mean, if I define it and I know what it is, I could just turn it into columns. But what if it changes later? Well, let's see some example. I want to have reviews that not only have these fields that I have, but I also want to add how many people like this review. So say, well, this one has 234 likes in this ID. So I can actually, like that, update the object by adding a new field. I don't have to do alter table and add a column, which is going to rewrite the whole thing. I can just add the field that I want in the object that I need. I can also say, okay, how many people reposted this? 134, fine. Or I can also say how many people share this without reposting it, so send it to somebody else, which is 1717, which 1,717 is by coincidence the amount of people that fits into one of the rooms in Tivoli Vredenburg, which is the venue for PG Day Lowlands this year in September 10 in Utrecht. Okay. But I can have this dynamicity for free? No, there is a price to pay. And let's look at this. A tuple, let's say that I have a review that is 1 megabyte. If I look at multi-version concurrency control, at the moment it's just using 1 megabyte. But if I update it, I'm going to create a dead row, and that is going to cost me 2 megabytes. If I update it again, 3 megabytes. But then again, it's going to use 4 megabytes. The tuple is still 1 megabyte, but it's using 4 megabytes. So when you are accepting clicks of somebody in an application, instead of adding them to the database immediately, what you could do is to wait for all the changes in that article and put them all at once. So this is how you tame your JSON beast. One object that contains 3 new fields, you add them there, and the tuple is still going to be 1 megabyte, but it's only going to be using 2 megabytes as your multi-version concurrency control system. Much more efficient. Now, there's one concept that I'm going to introduce here that I haven't seen it before. It's called FUF, is candidate for columns. What a FUF means, it means frequently updated fields. Likes, posts, and shares are going to be updated frequently, so we are going to put them as columns. You see? The advantage here is that now I can update those without touching the JSON object, because these are frequently updated fields. So I take them out of the object. And I can do things like this. In this case, the tuple is still 1 megabyte. It's not smaller, but I can just change those columns. And then the multi-version concurrency control is only going to add the row that is fixed size, and it's going to point to the JSON object. So in general, I mean, unless the JSON object fits into the block, and that means that the JSON object is such a small thing that you don't care. But if this JSON object is large enough, it's going to go into what is called a toast table. And the toast table is just a reference. So you just update the things that is fixed, and then you just say, okay, and my object, JSON object, stays the same, so it doesn't going to increase my usage into the table. I think that's a nice way of naming the beast. All right, this thing I'm going to just mention it briefly. I don't believe too much into the usefulness of this, but since this was a question from one of the people who asked me, okay, what about partition table with JSON data? Is it possible? Yeah, you can do this. So for instance, you can have a new table called venues. You see, you only have one, because we don't know yet what type of information we are going to put up for the venues. So we're just going to have a JSON object. It gives us the freedom. But what we know is that we are going to sort them by country. We're going to partition them by country. So this is a table partitioned by a list and is dependent on the text value of the country. And I'm going to just create 2 partitions, one for the metal venues in Chile, where there are many, and the ones that are in Belgium. And as you can see in Belgium, we don't know whether we write them as Belgium, Belgia, or Belgique, because depending on the language that you're speaking here in this country. So there you go. You can do partition tables also with JSON objects. I don't know if that is useful, but it's possible. Okay, so some closing words. So let's wrap up all the things that we were discussing here. The reason that I love JSON is because it gives you this freedom. I like freedom in general, in combination with some agreements that you need to have so that everything flows in a relaxed and natural way. Okay, so you mix this freedom with some relational best practices in the way that we took some volumes out of the JSON, convert them to primary keys, and then we were able to do foreign keys. So it gave us the guarantees and the integrity of your data. So extract every useful field out of the JSON object and put it as columns. We saw it in a few examples. Then when you want to index inside the JSON object, make sure that you understand your JSON object and you use either gin or trigrams or B trees or whatever fits better for your use case. And you can also add constraints on your type. So you can say, in this particular field, I only want to have double precision values. I only want to have arrays. And with that, I would like to close this, but as an invitation to continue this discussion, you can do that in the Discord channel, because this is a recording. And if you are watching this live, I'm going to be trying to answer questions there. But also afterwards, we can discuss about new opportunities of using JSON. Some of the stuff that I presented here today are actually questions that I got in previous presentations or in just discussions with people. And also, if you don't care about JSON, but you care about music, not even metal music, but music in general, or connection between people, you can also contact me, and we can always have a chat about how music connect people, how designing databases connect DBAs with developers, and how we can make a happier world if we all collaborate a little bit more. So thank you very much, and please feel free to reach out.
Thank you so much for this amazing talk, Boriss. I love how you can tell stories about a complicated, or not even a complicated topic, but almost a dry topic like JSON fields, and you can make it so interesting with these examples. And I'm a little bit sorry for putting you on the spot in the live chat on Discord about saying like, well, every time I give freedom to developers, they kind of make a mess of it, and then performance becomes an issue. And also thanks for the community, because Chris immediately corrected me like, hey, the freedom comes with responsibility. So yeah, don't store everything in the JSON field if that's not the way to go. So thank you, Chris, for correcting me immediately there.
Yeah, no, amazing, presentation. I used to be a bit of a metalhead myself, so it was really good to see all the metal bands and the examples in the presentation. And it was really good to help demystify JSON and JSON-B. I remember when it came out, it was the next big thing in Postgres. So really good to see all the examples, especially the constraints and how to add constraints on columns as well.
Yeah, it's an extremely useful tool to master, to know how to manage this JSON and JSON-B fields. I use them in all my databases just to tell the database how I want to maintain them, for example.
Nice. Awesome. So again, questions for Posette speakers, they're all going to be in the Discord channel. So, please follow the link and feel free to ask questions, there on the talks. We had mentioned before as well, but feedback is really valuable both for the event and for the speakers and their talks. So please, fill that out, and as a reward, you also get a pair of socks. And next up is Tomas. Tomas Vondra is a Postgres hacker and a Postgres committer at Microsoft. He comes with a wealth of knowledge on performance, and this is a talk I'm actually really looking forward to. I remember back in the Citus days, this was a topic we would discuss, right? Because SSDs were just coming up, and there was a question around what should we do with random page cost and sequential page cost. Yeah. So I'm looking forward to this talk as well.
And every time when Thomas gives a talk on a topic, when you see it, you never have to look at it again, because there will be performance tests, there will be stats, it will be like case closed. This is how it is. So please, Thomas, show us the way.
Let's take it away.
So hello, my name is Tomas Vondra, and I'm here to talk about random page cost, one of the important configuration parameters in Postgres affecting planning. So if tuning Postgres is part of your job, you might be interested in this talk. Okay, so let's talk about the purpose of random page cost, how we ended up with the default for the row, and whether it's time actually to change it. So we only have about 25 minutes for this talk, so the agenda is pretty tight and pretty short. At the very beginning, I'm going to explain what random page cost is actually for. It came up with the cost model, which was introduced in about 2000, so it's about 25 years old. And I will try to explain how we ended up with the default for the row, how was it selected, and whether we could actually repeat the process, the experiments that led to the default 4.0 on current hardware with the current version of Postgres and so on. And the main question that I tried to answer is whether the default 4.0 is still the right default, or whether we should follow the usual advice and lower it on, say, flash storage, on SSDs. And while working on this talk, on preparing the experiments and so on, I also realized, I learned about a number of interesting effects the random page cost has, and the purposes it serves in the optimizer. And I'm also going to mention those during the talk. So let's talk about the purpose of random page cost. What is it for, right? Postgres is one of the databases that is using cost-based planning, which means that whenever you execute a query, the database will construct a number of different execution plans, possible plans for this particular query. And it needs to pick the best one, which usually means the fastest one, right? The database doesn't have any perfect way to predict the duration, but what it can do, it can calculate the cost, which is essentially a sum of resources, the amount of resources needed to execute that given plan, right? So the database calculates the plans for different, calculates the cost for different plans, and then picks the one that is the cheapest one, the lowest cost plan. And this is based on the assumption that the lower the cost, the fewer resources the execution plan needs, the faster it will run. And the resources are typically things like CPU, disk I/O, and that kind of stuff. And this works pretty well, but it requires assigning costs to some basic operations. And those are, there are a number of configuration parameters in Postgres that actually do this, right? There are parameters like sequential page cost, which is set to 1.0, which is like a virtual currency. And then there's random page cost, which is set to 4.0. So these actually are costs of reading a page sequentially, 8 kilobyte block from a data file. And random page cost is the same thing, but reading it in a random access. Right? And then there are additional cost parameters that are about CPU resources, right? So for example, reading a tuple from memory, from a page that is already in memory, costs 0.01. So it's much cheaper than the I/O costs. And then there are additional costs for like reading a tuple from index page, evaluating a condition, like a where condition, for example, on a tuple, and so on. And those are the CPU costs. And one thing you should clearly notice here, which is obvious from these numbers, is that the I/O costs usually dominate the cost, right? The disk I/O could be divided between like sequential access and random access. And the simple truth is that sequential I/O is much faster than random I/O. And that is true even on SSDs. But both the sequential and random dominate the cost of a query that actually needs to do any meaningful amount of I/O. So for example, a simplified formula for calculating cost of a sequential scan is on the slide. And you can see that if you are reading a table sequentially, then you know how many pages the table has, and you will multiply the number of pages by the cost of reading a single page, right? And that is number of pages times 1. And then we know that we need to process all the tuples in the table, and we will multiply the number of tuples by the different CPU costs that are, however, much lower. Right? So sequential scan is going to be dominated by the CPU, by the I/O costs, right? Similarly, for index scan, the formula looks a little bit different, but it's the same principle, right? You get the number of pages that you need to read randomly, and you will multiply that by the number random page cost, which is 4.0, and then you will add the different CPU costs. Again, those will be much lower. Another thing that is worth mentioning is that number of pages accessed is not the same thing as the number of pages in the relation, right? Because we will be accessing the pages randomly. So, and every time we will only read potentially a single tuple from that. So if a page has 20 tuples, you will visit the page 20 times. So the number of pages accessed is actually much higher, right? Which further increases the cost of reading, of performing the I/O. Anyway, the I/O costs are pretty important. So where does the current default for random page cost, which is 4.0, where does it come from? The cost model is roughly 25 years old in Postgres, right? It was actually proposed and implemented by Tomas. There is a link to the thread discussing the patch and introducing not only the cost model as a concept, but also all the cost parameters, including random page cost. But as I mentioned, that is like 25 years ago. And since then, the environment completely changed, right? We don't have spinning drives anymore. Like now, all the hardware, all the storage is either flash-based or it's some sort of like network attached storage, which is usually also backed by SSDs. And there's large amounts of caches everywhere, right? That's a completely different thing from the spinning drives, right? But not only the hardware changed, Postgres also improved quite a bit. And even the code paths that were not as optimized because everything was dominated by I/O got much better, right? Because the storage is so much faster that even those code paths actually matter, right? So that can also affect the costing, right? But of course, Postgres is not like running directly on the hardware. There is the operating system in between. And a lot of stuff improved in, say, Linux kernel. So for example, when the cost model was introduced in 2000s, Postgres actually didn't have a read ahead for sequential scans. That only came in like mid 2000s, and it was actually done because of Postgres to actually do the prefetch for Postgres. So all these things can significantly change the efficiency of different query plans. So it's possible that the default 4.0 no longer applies, right? Maybe it's not the right one. So maybe it's time to readjust, right? To update the default. The usual advice, tuning advice that you can find in different tuning guides is that on SSDs, you should actually reduce the random page cost quite a bit, right? Maybe to 1.0 or something like that. So I tried to do slightly different thing. I decided to reproduce the experiment from 2000s because supposedly there were some benchmarks done back then, Unfortunately, the original scripts seem to be lost, right? They haven't been published, posted to the mailing list, but based on recollections of the people who worked on that, I came up with a very simple benchmark, which essentially generates a large table with random data, uniform distribution, because that is very easy to actually estimate from. And then you can read the table either sequentially using a sequential scan or randomly by forcing an index scan. And you calculate per page timings, right? You calculate how much time is actually needed to do a single page read. And if you divide these two timings, the random timing and sequential timing, that is what should be random page cost, pretty much, right? At least that was the idea. I also want to mention that especially the index scans are subject to different caching effects, because as I mentioned earlier, we are actually accessing each page repeatedly, right? So maybe the later reads are not actually reading the page from disk, but from some sort of cache, like page cache, for example. And that would affect the results. So to account for this, you can do a very simple thing. You can use larger amounts of data, sufficiently large table. And I also use direct I/O. So that almost perfectly eliminates the caching effects. So the process that I just described, you can also imagine doing that from like explain, analyze, right? Because that actually gives you all the information that you need, right? So for example, if you do a simple index scan on a table with, I think, 1 million rows, you will immediately know, like the explain, analyze will tell you how many pages were read from the operating system, from page cache. And because I'm using direct I/O, that also means from disk, right? And that's roughly 661,000, like a bit more than 500,000 pages. And it took about 110 seconds. So if you divide this, you will get the random page time, which is like a time needed to read a single page in a random access. That's 0.17, right? And if you repeat the same thing with a sequential scan, the table only has about 45,000 pages, and it took about like less than 300 milliseconds. So you can see that the sequential page time is 6,000ths of a second, right? And if you divide those two things, you would get something like a true cost of random I/O with an SSD, because this was done on a machine with SSDs. And you can see that the result is about 27, right, or 28, which is a little bit surprising, because that's actually much higher than the current default, which is 4.0, right? So, and we kind of expected the initial assumption that I approached this topic with is that on SSDs, we should actually lower the default. And that's also the usual advice. But maybe this is just like something weird with this particular hardware. So I actually did this on a number of different machines. And I got these results. And I did that on machines that I either have at home or machines in cloud environment. And at home, I even had machines with still, the spinning drives, the thing that was used like 25 years ago. And that's the first row. The table also says the estimated random page cost, which is the results that I just like showed you how to calculate. And for the spinning drives, it's 140, which is roughly 2 orders of magnitude higher than the default, right? And for different types of SSDs in different configurations, different types of RAID arrays, the results are much better than for the spinning drives, but it's still much higher than the current default, which is 4.0. So what does this tell us, actually? Well, first, the current default was never the raw random page cost, right? It was never just about the cost of the I/O itself, and that applies even to the spinning drives. There definitely is a difference between SSDs and spinning drives. SSDs do better, but the cost of random I/O is still not as low as sequential I/O. And maybe the results actually tell us that we should increase the random page cost, not lower it. So what if you increase the random page cost? Well, is it even like a good idea? So you can obviously try that, right? You could try that on some sort of like a test machine or staging environment. And let's say you increase the random page cost to something aligned with the results, say 30. Well, you will probably learn that it fixes individual queries that are running in isolation, but it likely performs rather poorly for the whole system. And the question is why? Like, why does it help individual queries but actually hurts the system as a whole? And the answer to that, as far as I understand it, is that there are indirect caching effects, and the cost model is not actually accounting for these things, for these caching effects. So what do I mean by that? A cost model is inherently approximate and simplified. Like having a simplified version of the world is the whole point of having a model, right? And when I say approximate, it means that the system is actually calculating cost based on, say, approximation of the data distribution, and even the cost calculations are making various assumptions about like independence of columns and that kind of stuff. But it also is simplified in the sense that it does not actually consider a lot of stuff. Because, for example, Postgres has no concept of an active set, right? If you have a 1 terabyte database, it doesn't mean that you are constantly querying the whole terabyte. Like if it's an e-commerce site, for example, you will probably be, or users will be querying only the most recent data, right? Because they are much more interested in like the orders from the last week or a month than in orders from 5 years ago, right? So there will be much smaller subset of the data that is usually in cache. But Postgres doesn't actually have any idea what's in the page cache at the moment. It doesn't know which subset of the data that you are querying is in page cache. And furthermore, there is like a very limited consideration of concurrency when planning queries. Like each query is planned as if it was the only query running on the database, right? So what does this mean? Well, when I mentioned what resources are considered when calculating cost, I actually didn't mention memory at all, right? I was talking about disk I/O, I was talking about CPU, but memory was not part of that. We do have Workman, but that's just like a limit, right? It doesn't kind of affect, it does not affect the cost in the sense that if you are using more memory, the cost should be higher. And in particular, there is no cost assigned to pushing data from a page cache. And that's exactly what the sequential and random I/O actually affects, right? Because if you are doing imagine you are scanning a table which is 100 gigabytes, but you only really need 1 gigabyte of that, like 1%. If you are doing a sequential scan, you will read 100 gigabytes of data into page cache, possibly pushing out 100 gigabytes that already is there, right? But if you are doing random I/O, if you are doing index scan, you will more or less read just 1 gigabyte that you actually need, and you will not push other stuff from the page cache, or at least not as much of it, right? So the point here is that the random I/O is maybe more expensive, but it's also much more localized, right? It only reads the data that you actually need based on the conditions, clauses in the query. So I'm going back to the initial question, like, should you lower random page cost, or should we actually lower the default? Like, should we adjust the default? I think it makes sense to actually lower the default on SSDs, because we saw in the results that SSDs do much better in compared to the spinning drives, right? So if 4.0 was good for spinning drives, and it actually worked quite well over the years, then maybe 2.0 is reasonable for SSDs. They can actually handle much more random I/O than spinning drives. But you need to be careful, and you need to be monitoring performance of the whole system, right? You need to be watching how all the queries, not just the queries that are immediately improved, but also the other queries that are accessing data, how they are doing. An important lesson that I learned from this is that it's not just a question of the raw I/O cost, right? It's a trade-off between improving like local performance for a single query and optimizing the performance of the database in general. A simple experiment can't give you a good number because exactly it doesn't actually consider the caching effects. And this applies even to like a command line tool that you could run, and it would tell you, oh, random page costs this much, sequential page costs this much, and therefore the random page cost should be this value, right? It just is not possible. I think it needs to be driven by monitoring of the system and kind of like doing iterative tuning based on evaluating and monitoring of the performance. I mentioned that the cost model is kind of like incomplete. There's a lot of things that could be improved, like added to the cost model. We need to be careful about not making it overly complicated, right? It still needs to be simplified and approximate. Otherwise, other than that, it wouldn't actually be a very good model. There is a number of things that we definitely need to consider in costing, and we are not doing that right now. One of the things is, for example, asynchronous I/O or prefetching and that kind of stuff. And my last slide is just a couple of links to resources related to this talk. The first slide is actually, the first link is about office hours, which is that you can actually have a chat with me about anything related to Postgres, discuss a patch idea that you had, and I will try to give you advice. Right? It's an attempt to help the community to actually grow. And then there's a bunch of blog posts about random IO, which is what this talk is based on. And then there's a recording of a talk about performance cliffs, which is again about making costing mistakes in the optimizer. And finally, some weird stuff with SSDs. And that's all for me.
Hey, this was so cool. The talk was amazing. And it was surprising. I mean, the results were interesting, right? Like I didn't expect that the cost difference would be actually much higher than what has been sort of encoded from model perspective as well.
Yeah, it's like one of these things I learned as a junior DBA. It's like, yeah, random page cost is 4 and sequential is 1. And then Thomas takes like the trivial number and say like, yeah, well, today's disks are faster, so let's lower the value. But to what value? And then suddenly you learn all of this. I love it.
Yeah, and I especially like the context of, individual queries might get faster, but what does that mean in aggregate, right, for your workload as well, especially when you start looking at the memory usage and things like that as well. So it was an interesting, very interesting talk.
Always another surprise around the corner.
Awesome. So just another reminder for survey and feedback, and get your socks as well. Another reminder, or I guess a discussion on talking Postgres. So this is a podcast hosted by my colleague, Claire Giordano, who interviews a bunch of folks in the Postgres community. Derk, I see you're on there as well.
Yeah, I must be there somewhere. Episode 12 on the very right of the screen. Yeah.
How was your experience on talking Postgres?
Yeah, it's so nice. It's because Postgres is about the community, and this is exactly what the podcast is about. How do people are part of the community? How did they become part of it? What are they good at? How do they think about Postgres? And Claire's a really good host. She always knows to inspire a how do you say this in English? A spark. Thank you.
Yeah.
Inspire a spark at people in the podcast, and always have good questions. The conversation is so easygoing with all of us. So yeah, she does it really well.
And actually, just recently there was a podcast with Tomas as well. So talking all about performance again. So, but I mean, if you just look at the folks like Tom Lane, Melanie, Andres, so it's a really nice lineup for the podcast as well. 47 amazing guests on 40 episodes of Talking Postgres. So definitely check it out. I believe you can get it, on wherever you get your podcasts, like Spotify and things like that as well.
I think so. And let's hope there will be many more. So please continue, Claire.
All right. This, I think, is a good point to take a bit of a peek ahead at Livestream 2. So let's roll maybe the trailer for that.
In this keynote panel, we're going to be talking about what actually happens as we approach the annual Postgres feature freeze.
You'll get the inside scoop on how Postgres contributors develop all of your favorite features coming in Postgres 19.
Why do some Postgres patches make the cut while others miss the boat, or even get reverted in the end?
Join us to hear from 4 experienced Postgres hackers and committers who have had years of fun with Postgres and experience with patches both making it and missing the boat.
Hello everyone, I'm Marco Slot, and my talk is going to be about PG Lake, which is an open source extension for connecting Postgres to the wonderful world of data lakes and lakehouses. So I'm going to talk about how you can use PG Lake to import, query, export data in object stores and use it for fast analytics using table formats like Iceberg and file formats like Parquet.
Hi, my name is Aditya Kumaranchak. I'm a principal engineering architect in the Azure Data product group. So my talk is going to be about migrating very large Oracle databases to Azure database for PostgreSQL. So if you're a decision maker or if you're looking to migrate to Azure Postgres, then this talk might be interesting for you.
Hi everyone, my name is Richard Yen. I'm here to talk about PT Stats and about how Postgres statistics work internally. It's a talk that's geared towards beginner and intermediate users, people who want to get an idea of how Postgres internal statistics operate and how it influences the query planner and how to improve their performance on some of their queries.
Hi, I'm Shunan. In this talk, I will share a practical path for getting started with Postgres hacking. And we will look at why Postgres hacking feels differently and how to start small and how small compounds over time. If you are interested in Postgres hacking, then this talk is for you.
Hello, this is Murat Tuncer. I'm going to talk about PostgreSQL authentication, that is from trusted tokens and short history of PostgreSQL authentication. It is about how PostgreSQL authenticates your connection. I'm not going to rank methods, I'm just going to explain why each authentication method exists and how you can choose between them.
Hi, this is Gülçin Yıldırım Jelinek. I do product at Zeta. Today we will talk about what's new in Postgres 18 with constraints. I read all the change log, so you don't need to go through it yourself. And the talk is for everyone who is interested in constraints and app development with Postgres and into also database internals. I hope you will enjoy it.
Hi, I'm Alexander Kukushkin, Principal Engineer at Microsoft. Today I'll talk about PGQ, Postgres extension implementing queues that has been around for almost 20 years. I'll explain why it outperforms keep lock-based design and how to use PGQ on cloud-based Postgres.
The title of this talk is Fast Guard Need Fast Breaks. I guess that's the whole point in one sentence. In our industry, people, tend to go faster. They do want to do things faster, but nobody really talk about breaks. Nobody really talk about the safety mechanism that needs to be built around, getting it faster. And in this talk, I'm going to talk about how to build your safety mechanism when you're building your AI solution.
Hi, my name is Joseph, and I want to discuss scaling Postgres multi-process architecture, because it's not just about throwing more hardware at the problem. Each connection carries some hidden tags, and it could be Linux level memory and CPU overhead or Postgres level MVCC and locking constraints. So to manage high performance workloads, we need to understand these limits. So join me for a deep dive into these topics, because we shall stop guessing and start tuning our systems.
Hi everyone, I'm Paula Mechiora, and today I'm talking to you about the Postgres generated column. I'm doing that using some example and using Django ORM and some beautiful picture from Italy to show you how to use this fantastic feature from Postgres and Django.
So, Sumedh, now the million-dollar question is, will you be able to watch them all live tomorrow?
I hope so. I don't know. I'll have to drink lots of coffee and stay up in my time. But the talks look really interesting. Obviously the panel discussion should be really cool to hear from, Heikki, Thomas, Alvaro, and Melanie in terms of how things work from a behind-the-scenes perspective. I also wanted to actually hear Shuneng's talk on getting started in hacking Postgres and sort of get to see a newcomer's journey into the community as well.
Yeah, definitely gonna be fun.
Awesome.
All right, if you didn't join yet, please join the virtual hallway track, scan the QR code, and join us on Discord. And then next one is Adam Wolk. He is a principal product manager of the Azure Postgres team. And from his talk, I really learned a lot, because I had no clue what his talk was about. Don't tell anyone. Maybe I shouldn't tell this then when I'm hosting this, but Yeah, I had no clue what fuzzing was, and I learned a lot. And even though this will not be applicable to me in my daily job, the line of thinking was really, really inspiring for me. So yeah, I'm really curious what you think on this talk.
Yeah, I mean, it's really cool, and actually, it's also interesting given all these AI tools coming up, right, and finding bugs and issues in Postgres. So I think sort of security as an area and aspect is getting quite relevant these days.
Oh,
so fuzzing is
absolutely.
definitely an interesting topic here as well. So let's dive in.
Hi everybody, my name is Adam Wolk. I'm a technical program manager at Microsoft for PostgreSQL. Today I'm going to talk about fuzzing PostgreSQL and knocking at its door essentially. You will learn what fuzzing is, how to start your journey with fuzzing, and if it is for you and how to approach a large complex code base like a database. Okay, let's start throwing some stuff at the database. So first off, what will you get out of this talk? You will learn if fuzzing is for you, how to start, and how to approach a very complex software like PostgreSQL, for example. So who am I? I'm a principal program manager for PostgreSQL at Microsoft. I'm also an OpenBSD committer, but slacking for the last few years. I have background in information security and systems programming, and I believe that operating systems, databases, and web browsers are like a flavor of the same thing. And yes, I actually worked on all of those on operating systems via OpenBSD and FreeBSD at my previous job, databases via PostgreSQL, MySQL, and Oracle. And for browsers, I'm actually a contributor to the Otter browser, and I happen to port Dartium, which is a Chromium fork, onto the BSDs. I'm a contributor to many, just inconsistently productive. So the agenda for today is what is fuzzing. We will go through a toy example also, why you should fuzz a database like PostgreSQL. We will figure out what are some good fuzzing targets, how to fuzz networking, which is a gnarly beast, and we will go through some conclusions. Okay, so first off, you may have heard of testing, which is figuring out how to check stuff. But there's a different form of testing. You can call it adversarial testing, for example. When you have a system and you want to look for some security problems with it, you don't have necessarily the access to the source code. And you can imagine this was there since 1988, for example, where first mentions of random input testing have been around since. And you can imagine, for example, a web server and somebody throwing HTTP requests at that web server and seeing what happens with the web server. And they can throw random garbage at that web server and see it fall over, or just continue buzzing. And with that testing, they may find bugs, may find security bugs, or nothing interesting may happen. This is not consistent, right? Like you don't know what happens inside the black box, and it takes a long, long time to find any issues with that. So then people started doing smarter things, right? It's still a black box, but you know a bit about the black box. If this is a web server, you know it takes HTTP requests. So maybe don't throw completely random garbage at it. Maybe start mutating the inputs so that they are still valid HTTP requests, but slightly malformed, right? So you're covering a more likely path that a program can take. Or if this is a database, maybe you're not throwing random strings at it, but you're throwing mangled SQL statements, which are more likely to trigger inner paths of the code base. And you can employ some more advanced algorithms on your inputs, like genetic algorithms, to get more interesting inputs. Later on, you have instrumental fuzzing, and this introduces a feedback loop. So you can imagine this puts probes inside of the web server in a way that you would understand what's happening as your inputs are executing onto it, right? So if you were throwing things at an elephant, right, like you could throw random stuff at it, you don't know what's happening inside of it.
But then if you can approach it and maybe, put a stethoscope on it or have an X-ray, then maybe like throwing that banana did something to it that you didn't see from the outside. So what is fuzzing? Fuzzing is automated testing that throws unexpected inputs. It often will trigger crashes, hangs, memory bugs. It uses coverage feedback to find new ways to get deeper into the program. It finds weird, non-obvious bugs that go very deep into the code base. It's especially useful for certain areas like parsers, security critical code, and protocols. Let's go maybe to a sample toy program to get the concept hammered in. On the left-hand side, you see a C program. It's not very important what it does in general, but it has a deliberate crash in it. You can look on the flowchart on the right, which represents all the instructions that are in the code. There are 6 branches denoted by forgot the word. Okay. There are 6 branches that have to pass in order to reach the crash. What a fuzzer like AFL would do is a small piece of code. It would add a small piece of code into each branch to know which code paths were taken and which were skipped. So if you would trace the execution of this program, starting with a random input, you can see the input string here in the upper left-hand side. It's an empty string. We can see that the first highlighted line is a length check. It checks if it's 0, then the program will exit. So since it's 0, the program exits without a crash. We have not reached our error condition. So we may speed up things a bit by giving the fuzzer a better input seed. So instead of an empty string, we will start with the text test. And this allows us to jump past the first check of length, and we would fail on the second check because the first character is a T, not an F. But the fuzzer knows that the previous input opened a new code path. We got a bit further into the binary, so it will use this as a basis for further mutations on the input data. Applying various strategies on the data, it will expand, change various letters, do many manipulations to the string, resulting in newer strings. And this way, the fuzzer actually starts to see new code paths. We are getting further into the program as we are keeping mutating the inputs, right? So we see the first 2 letters were kept from the previous iterations, and we have a new mutation that will fail. But on the next mutation, we pass. And on the next, we finally passed the whole first if statement. And we are into the second if statement, which actually looks for the string crash in the input. We don't have a string crash in our current input, which is fuzz OC. So the program will exit again with return 0. You can see it here on the flowchart. After some more executions, this is an actual input stream that a real fuzzer found. And you probably wouldn't come up with this specific one. It's not like the most intuitive one a human would come up with. But it actually finds a valid string that makes us go through the whole execution tree into the final crash. Now, I mentioned that I'm using a fuzzer, so let's talk a bit about fuzzers. What you see on the screen is a screenshot of the American Fuzzy Loop, AFL for short. This is how our sample program would look like, run under this fuzzer. And American Fuzzy Loop is a security-oriented fuzzer that employs a novel type of compile time instrumentation and genetic algorithms to automatically discover clean, interesting test cases that trigger new internal states in the targeted binary. It was created and popularized by a Polish security researcher, Michał Zalewski, also known as El Kamtów, who at the time worked at Google.
on this screen, and I know it's a lot, but the details are not that important. It's a screenshot of another tool running our program. This tool is called HongFuzz, and it's a general purpose fuzzer that uses code coverage, software and hardware based, to find bugs and it is multi-process, multi-threaded, and supports persistent fuzzing for extreme speed. This is a report that a fuzzer would generate. This one is actually from our toy example, and it shows some details in the file that it spits out that contains the input that it used to trigger the crash that it found. And here you can see me invoking the toy program, and I'm passing to it on standard input this file that the fuzzer produced. And you can see the program printed boom and immediately crashed. Segmentation fault, core dumped. In the next line, we print out the content of the fuzzing file that we fed into the program, and you can see it's the weird string that we saw in the previous slide, which is fuzz crcra crash. Now, the interesting thing with fuzzers is they learn by observing the software. And by that, they can figure out very complex patterns like XML format, HTML format, programming languages. There's a great blog post by the author of our AFL called Pulling JPEGs Out of Thin Air, and it's exactly about that. They start with like an empty file and fed into AFL running some image parsing software. And after about 6 hours on an 8-core system, it got its first very unassuming image, a blank scale, 3 pixel wide, 784 pixel tall image. But the moment it is discovered, the fuzzer starts using the first image that it found as a seed, rapidly producing a wide array of more interesting pictures for the new execution paths. And what you see here on the screen is taken from that blog post, and it presents a sample set of images that AFL found, knowing nothing about how to create not only images, but also the image format that's needed to store and represent an image on disk of a computer. So why would you want to fuzz software? Testing is polite. You assume or you know the interface of a program, you approach it, you test it in a polite way. You knock, you pass things that are expected, and you get results. Fuzzing is rude. It doesn't go to the door, it goes through the window or through the back door. When that happens, assumptions break. And when assumptions break, you see bugs appear. So an unexpected piece of input in one part of the code base can result in something 3 parts later failing in an unexpected way that will cause your program to crash, collapse, or enable an attacker to gain escalated privileges. Many existing databases use fuzzing extensively. SQLite has a reputation for bulletproof reliability, and it is strongly tied to their fuzzing investment. They use continuous fuzzing using OSS fuzz and DB-SQL fuzz, and has fixed real issues because of that. One of the first bugs found with AFL was a pre-authentication MySQL remote denial of service via integer overflow, and it was affecting MySQL in a way that an unauthenticated attacker from the network could cause the loss of availability of a target database by simply sending some packets over the network to the database. So why fuzz PostgreSQL? Databases are like operating systems. It's not one attack surface, it's many overlapping ones. Traditional testing assumes that you know the inputs, you have expected control flow, you have stable invariants. And PostgreSQL breaks all three. Inputs come from untrusted clients. Execution paths depend on planner decisions and invariant change across versions, roles, and configurations. And with such a huge surface, how do you select interesting fuzzing targets? So here is a graphical representation of some, not all, subsystems in PostgreSQL. And you can think of that like as an attack surface complexity map. And if you look at some parts of it, like the most obvious one would be the SQL parsing. There are plenty of existing tooling that can smartly mangle SQL, and it's easy to test and pass, as you can simply connect and execute queries against a server. It's a high reward area to test, because SQL injections are still a common class of software errors, and hence vulnerabilities within it can lead to wider exposure. There are some existing nice tools like Sumedh that generate valid schema-aware SQL statements. In this section, you can also find other parts that are worth exploring, like the SQL lexer parser, the copy input format for like JSON, XML, and CSV. PostgreSQL is a very extensible database in so many ways that it only increases the potential scope of things that can go wrong. So some existing extensions that are interesting surfaces are PageInspect, L3, HStore, pgcrypto, and custom C extensions. Also foreign data wrappers, because that introduces network file input from external systems into your system. But there are also extensions that hook in very deeply into PostgreSQL, like Timescale DB or Citus. And those can have implications of the behavior of the whole system. There's a whole replication subsystem, how logical decoding works, replication slot behavior, hot standbys, anything related to handling files, so storage and wall, file and data formats. So for example, storage and page logic, heap page readers, tuple decoding, index access methods, utility and DDL function paths like alter statement, create statement, reindex commands, and table partitioning logic. Now, there's also the networking protocol. It's a high value target because it's external, right? Like with the MySQL example, you may not even need to be authenticated to send data to the database and have unexpected results, especially because of that the libpq startup packet feels like a good vector of attack and also a nice target for fuzzing itself. So I'm not the first one who had this idea. There are some talks from online recorded from 2023-2024 by Nikolai Shaplov from Postgres Pro, where they describe their approach of fuzzing PostgreSQL. They found at least 3 bugs in the database, and they selected the same targets as I, but with a different approach, which will be nice to compare a bit later. In 2020, also, there was this paper testing database management systems with language validity and coverage feedback. And Squirrel ran for 11 days on PostgreSQL and MySQL, found 63 bugs, 51 from SQLite, 7 from MySQL, 5 from MariaDB. They haven't found bugs in PostgreSQL, but they focused on the query parser, which I think is a very hardened piece in the database today because it's also very easy to test. Google runs like an OSS fuzzing project, which consistently runs fuzzers across many databases. It's so far, like at the time I checked, found 19 SQLite bugs, 15 from MySQL also, 0 from PostgreSQL over a span of 3 years. So what are the challenges in fuzzing PostgreSQL, especially areas like networking? So first, PostgreSQL is not one target. It's a stateful, multi-headed system where every input wakes something up. There's a socket per connection because there's a process per connection also. There's TCP/IP overhead that requires setup and delays. You have complex persistent state between connections that can impact other connections, right? Because every SQL statement may result in some files being modified and stored persistently on disk, and that can impact further executions. PostgreSQL also is heavily defensive. It handles a lot of errors. it interjects signal handlers in C code. It has long jumps in the code for error handling, and it traps a lot of exits. So it's very hard to distinguish between, oh, the database crashed versus the database figured out something is wrong and decided to shut down, which is a completely different state. So how did PostgreSQL Pro approach it? They evaluated running PostgreSQL in single mode and decided against it because they wouldn't have parts of the system they wanted to test available, like the networking stack. What they decided to do is modifying the database in a way that connecting to it will not spawn a new backend process. Instead, it would remain as a single process system. They started using Btrfs file system for snapshotting, and they replaced the networking codes with their own implementation, hijacking the networking code, and that way they fed inputs from the fuzzers into the running database. That's a very nice but very complex setup. I approached something simpler, which is I isolated the code I wanted to test. Then I wrote simple test harness programs, small programs that called directly the parts of the database I wanted to test and fed it the input data from the fuzzer, hoping that I would hit some errors. So here's an example of the fuzzer running on PostgreSQL using my method. It's very slow. You can see only 40 executions, almost 40 executions per second. It even says it's slow. And it's slow because I run it with full code coverage because I wanted to show you what parts of the code are hit or not. If we go on the next screen, I know this is a very big picture, but it's just overview. This box here is another fuzzer running, slightly faster because 7,000 times a second. And in the background, you can see code colored with lines hit and not hit. If we zoom in a bit, you can see that in the line of the if statement, if we zoom in on it, you can see we took 3 paths and 1 we didn't. So a plus denotes a path we took, a minus a one we didn't. And if we focus on the next if statement, we never hit a length more than 0. And this is because when I was calling this function, I provided a hard-coded length. And since the fuzzer didn't control the length variable, it never attempted something different. So I could have been running this for months and not find a single bug because it would simply never go further. The fix for that, of course, is making the other parameters also parts of the fuzzer input, and that allows you to explore deeper into the PostgreSQL codebase. So also be mindful to check things. So I personally have not hit very big bugs, mostly because PostgreSQL is a defensive code base. So it handles a lot of errors, like you mentioned, and it's very well battle tested. I had very slow test cycles. So I was running on a local laptop with code coverage enabled and not for a very long time. So what could be done next is testing on bigger hardware and maybe adding entry points for fuzzers to PostgreSQL. So every fuzzer has like a special batch mode. So if you design specific entry points for them, they are able to directly invoke code from the database without setting things up themselves. So that makes testing easier. So if I were to continue on to this, I would say run more fuzzing. There's plenty of room for everybody to try, and run it for long and repeatedly, especially after new releases and new changes. So with that, I hope that you come out from this excited to try fuzzing yourself and dipping your toes in testing new places. There are also very small programs in PostgreSQL like pgdump, for example, that could be good fuzzing targets that wouldn't require setting up the whole database for testing. Thank you.
Awesome. This was a really nice talk, a great introduction to fuzzing as a topic. Right? I was really interested, like you typically think of SQL as a as a typical target, right? But when you start looking at all the surface area for potential attack, including like foreign data wrappers, JSON parsing, replication, it's interesting. Yeah.
Yeah, it's a scary place to be.
But also it's like he said, he hasn't found any big bugs, so it's also a testament to, I guess, a security sort of posture and the amount of work that all the committers put in making sure it's hardened.
Yeah, definitely. There was someone on the podcast, on Claire's podcast, and talking about what it makes to be, or what traits you need to have to be a good system engineer. It was like, you need to think about all the weird things that might go wrong. It's not about the happy path. You have to be creative about all the other things that can go wrong and also protect yourself against them.
Yeah, awesome.
And again, please leave a review for the speakers. Be polite, but also really tell them something they can work on. What can they improve? Did you drift off somewhere? When did you come back? Share something they can learn from. That makes them a better speaker next year. Thank you.
And the swag. So the sticker packs. So feel free to go get your voucher and get these sticker packs as well. Again, supplies are limited, so one per person per live stream.
And then, next, Chris. He is an amazing system engineer, a really good coder, but he also is famous in the community. I have to look down because he makes this really cool electrical elephants.
Oh, wow.
So
that is really cool.
Yeah, this one he designed for Lowlands, the second best Postgres conference in Europe. So that's really cool. I'll leave this one on. And also, I learned Chris is way too fast when it comes to paying beer. So for all the community members listening, please, next time when you see Chris on the conference, make sure you can actually buy him a beer, be faster, because he really deserves that we are getting him some beers this year. But that's not what he will be talking about today. Besides, he's a good engineer. He also knows a lot about Postgres. And he has some really cool design patterns. And everybody can learn something from this one.
Awesome. Looking forward to it.
All right.
So let's take it away.
Let's take it away.
Hi, so I'm Chris, and we're going to be talking about Postgres design patterns. So this is a talk primarily for application developers, and we're going to go through a number of design patterns that I've used across 20 years of using Postgres. The talk itself is going to focus on one particular application and all of the different Postgres features that I used to make my life easier as an application developer. Okay, so let's explore some different Postgres design patterns. So first off, a little bit about me. I'm Chris. I kind of run a small application development house in the UK called Nextteam. And I tend to go around calling myself a bit of an IT jack of all trades. And I've kind of done everything from designing hardware to building websites. So I worked across an awful lot of different kind of domains across my career, from building search engines for local government websites to industrial IoT platforms to kind of a booking and subscription management platform. Now, an awful lot of these examples, to keep the kind of talk coherent, are drawn from one single application that I built recently over the last few years, which is an event management and subscription platform. And I'm a very big believer in that engineering still needs creativity. And this is a fun photograph I took whilst I was over in Germany last week of the Wuppertal suspended railway. Now, this particular town is in a very steep valley with a river at the bottom. And they wanted to build a transit system across there in the early 1900s. And they kind of came up with this very unique solution where they suspended a car above a track, below a track, and then allowed it to be suspended above the river. And I think it's really easy for us to kind of get locked into that engineering is this kind of dull kind of pursuit. And I think that's completely wrong. It's about creativity often and coming up with creative solutions to problems. And this still works in kind of software, just seeing the database through the eyes of an ORM or as if SQL 92 is still the predominant standard, you're missing out on so many different features and all the power of Postgres, to my mind. So this is much more of a talk to try and get you to think about using Postgres slightly more creatively. Now, we're first off going to start talking about kind of events, and I'm not talking like browser events here or database events. I'm talking about physical events. And these are kind of nothing more complicated than something that's going on in a particular venue at a particular time. So, every event is going to have a start time and an end time, and it's existing in a venue. So our very basic data model is not much more complicated than that. And the first kind of interesting Postgres feature that I'm going to talk about are kind of what we call range types. Now, this allows us to deal with the concept of something having a kind of lower bound and upper bound. And a range type that exists in Postgres is actually a timestamp range. Now, this was very useful to solve a particular problem where we needed to deal with club holidays. So a club or a venue might get closed for a period of time. So we have a kind of start time and an end time where that venue is closed. And we want to find all the events that are going to be affected by that closure. Now, this problem obviously can be expressed in standard SQL. We're going to look at the start time of both situations, compare them, and the end times. But this gets complicated, especially we deal with those edge cases of like there might not be an upper bound. For example, the venue might be indefinitely closed for the future and we don't know when it reopens. But this is where range types actually gives us a very succinct way to express this. And it can actually be very useful just semantically. So in this particular instance, we're going to construct a timestamp range from the start and end times of our event. And then we're going to see, does that overlap? And this is what that double ampersand operator means. It's actually, does a range overlap with another range? So in this particular case, this query is going to find all events where the event duration is going to overlap with our holiday duration. Now, this is just, frankly, from a semantic viewpoint, a lot easier. And actually, we've got different features in Postgres where we can actually go and use this more longer term. For example, we might have just needed this for a one-off ad hoc query, but actually we might also want to persist this. So we can use another feature of Postgres, which is generated columns. Now, often with applications, how we go about storing those more exotic data types of Postgres can be difficult. And sometimes actually it's just easier not to bother interacting with those particular columns. And this is kind of an example of that, where in my application layer, I don't really want to have to deal with the complexity of parsing the textual representation of that timestamp range when I don't really need to. I can just interact with those existing columns we've got of start and end time. And we can use Postgres here to add a column, and it's always going to compute the value of that column and store it based on those kind of input start and end times. Now, this can then get very useful for another particular problem when we deal with events, which is we only really want one event happening in the location at the same time, or that is often the physical constraint, right? It's very difficult to have two competing events happening in the exact same room at the same time. And Postgres gives us an interesting way to try and model and solve this problem. So Postgres has the concept of exclusion constraints. Now, an exclusion constraint is going to say that two rows cannot satisfy this same criteria at the same time. Now, most of the kind of situations here, we're the real world, right? We don't just care about that time range, we care about that time range also in the venue. Now, to deal with that particular situation, we're going to actually have to install a Postgres extension. This is provided by core, it's just not installed by default. And this adds B-tree support into the pluggable index system of Postgres. So in this particular case, it's adding B-tree support to the gist index mechanism. And then this allows us to construct an exclusion constraint that's going to match the venues with the equals operator, and then it's going to look at our time ranges with that overlaps operator. So now we can construct an exclusion constraint very easily, which specifies that no two events can happen in the same venue at the same time or an overlapping time. And this is very useful for those kind of situations where it's easy for people to kind of accidentally double book things. And it's often very difficult for an application to enforce this using standard kind of business rules in a safe manner. And then range types don't just stop with time ranges. You can actually create a range type for all different Postgres types, and there's a number out of the box. And obviously another very simple one that comes out of the box is an int4 range. Now that's obviously a 32-bit integer, and we have a lower bound and upper bound in that kind of space. And we use this in a situation to deal with how we manage about restricting or recording that events have an age range attached to them. So we might have events that are only for children and we have events that are only for adults. But you might have an event where it's like for 6-year-olds to 12-year-olds or something like that. And these kind of ranges of just using standard integers then become very helpful for that situation. And we don't just have to use a overlapped operator like we previously used. We actually also have a contains operator. So we can actually specify, does an event have an age range that's suitable for a 13-year-old, for example? But often, in Europe, especially under the GDPR rules, we don't necessarily want to restore the exact age, especially of children. So actually, we might go back to using that kind of overlaps operator and say, well, find me all events where the age range actually overlaps with the kind of age bucket that we have stored on the member. Now, this is just a great feature of, again, those kind of range types, and shows that we can use them in multiple different ways for the same kind of problem domain. But another part of this kind of problem domain is we might have other filters going on our event. So a very simple example of this is actually an event might cater with multiple different types of martial arts at the same time. So in that situation, we, rather than having to add a linking table and a lookup table and do it more the relational way, I kind of like keeping things simple. So we just had a text array which stores the sports that that particular event is catering for. And then we can very easily just use features of Postgres to match this up. So again, we can use that contains operator to say, well, find me all events where the sports contains karate. And another nice little feature of doing it this way is we can also match 2 different sports at the same time. So we basically get and matching for free. So we can say, find me an event that's catering for karate and kendo at exactly the same time. But not all the filters are just like as simple as this, right? They're not just lists of properties. Sometimes we've got situations in our applications where administrators of the clubs can create their own sets of properties and filters. So actually, I tend to find that Postgres' JSON support is really handy for these kind of situations. So in this particular situation, we have a metadata column on our event, and that's kind of using this JSON-B data type. So that is basically a binary stored version of JSON data structures in Postgres. Now, that lets us do the very basic things of like simple kind of key value matching. But those values might not necessarily just be simple scalars. Like, for example, we have different styles of events, be it just a standard kind of like kata class, or it could just be like, a grading event. But also, like, maybe we've got information about the different belt gradings that are dealt with by that event. And that's then more of like an array type structure where we have a list of belts that are handled. And JSON and Postgres has all the capabilities for us to deal with this in that kind of very flexible way that often we need as application developers. So we can kind of very easily, again, use that sort of contains operator, but again, it's now working on a different data type where we say, find me all events where the metadata property is containing an attribute style and matching a value kata. But we can also go more complicated this and say, well, actually, I want to look at these kind of other properties that might be non-scalar. So for example, we can take, well, I want to match that style. I'm looking for a grading event. So I'm going to match that style as of grading. But then I also want to look at, there's a belt property and it's got a list of belts that are supported. And I want to find a class that's suitable for a yellow belt. And again, this is something where the power of Postgres and actually in this particular instance using JSON path expressions kind of gives us that feature. And actually we can kind of construct these a lot safer in the application layer than, say, having to fully generate custom SQL for every single kind of filter that's going on. And this is kind of a great way to have us that flexibility inside our application, but let us still deal with all of this in Postgres. And the great thing with Postgres is we can even index accelerate both of these use cases. So again, with Postgres' pluggable index support, we can actually create a GIN index across both our array as well as our JSON columns. So in the situations where we do need index accelerated lookup on these values, we can do that. In this particular instance, we're primarily filtering events based on time. So these are more used for sort of rechecking as opposed to a primary search criterion. Now, this then brings us on to the next part of kind of this problem where all venues exist at a physical location. And a very basic way of capturing this is, we have some form of textual postal address of these locations. And we've maybe got external services that let us translate that kind of physical kind of address into a geolocation of some form. And Postgres actually has all the power for us then to be able to deal with this information. So rather than us having to rely on an external third-party system for doing some of this stuff, we can take that information and we can store it inside Postgres. So we're going to actually look at another extension here called PostGIS. Now, this adds full geographic information support to Postgres. And this brings in a number of different new data types, and geometry is an example of this. And that is basically a geometry in a two-dimensional Cartesian or, say, polar coordinate system. And there's lots of different types of geometry, right? The very basic type is a point, and that's literally just like an XY coordinate. We could also have like things like polygons, where you have like a shape that's describing a particular area. For example, the outline of a country can end up as very complicated polygon geometries and multi-polygons. But for this kind of little, very simple problem, we literally just want to store that every venue has a physical geolocation point. Now, this little magic number we have in this line of SQL, 4326, is what we call a spatial reference system identifier. Now, that basically just provides PostGIS and Postgres with a whole bunch of metadata about that particular geometry column. And specifically, 4326 is the GPS coordinate system. So what we're actually storing here is a single point in the latitude, longitude of effectively the kind of GPS coordinate system. Now we can go about then using this information to find us different venues that are within a certain distance of our current location. So to do this, we can use a bunch of the built-in PostGIS functions. And a very simple example of this is a function called stdwithin, i.e. the distance between these 2 points is within a given distance. So here we're going to basically query our table where we're looking that venue location is within 0.018 degrees of our current location. And we're going to use stpoint to create that current location from our latitude and longitude. Now this 0.018 is a bit strange. And again, every single coordinate system has their own different distance units. So if you were using a local grid for, say, a specific company, these are normally Cartesian systems and typically would be in, say, meters. But when we're dealing with like a GPS style coordinate system, then those are degrees of arc effectively. And 0.018 is roughly the equivalent of about 2 kilometers. So in this particular query, we're going to find all the venues that are within 2 kilometers of effectively Greenwich Mean Time. And again, the great thing with Postgres and the pluggable index support is we can, although using a slightly different index style, create an index on this geography column and still have our index accelerated lookup and access to these kind of venue searches. And for me, one of the places where Postgres really starts to shine is our ability to bring all of this different types of data together into one system. And, I remember 20 years ago working on systems where we couldn't do this, and we would have to either manually translate kind of geographic system lookups into flat file matches and all that kind of stuff. And Postgres gives us this ability to do everything together. And I think that's one of its massive advantages. So we can actually construct a query like this, where we sit and say, well, find me all the venues, all the events that are happening in the future in a venue that's within 2 kilometers of where I currently am, where the sport that's being practiced is karate, and it's a grading event. And we can construct all of these kind of complex different filters in just SQL and using just features of Postgres. And for me, that's where some of the real power and value of Postgres starts coming from. Now, if we're going to move on to a slightly different part of this whole application, and another little very neat design pattern that's had a number of use cases across different projects, is the ability to deal with sort of those little situations where things can go a bit wrong. So in the system, we obviously have subscriptions where a member has a subscription to a plan, and those subscriptions have a different form of status. And this is a very common pattern across lots of different applications where we have a domain has a life cycle. So for example, a subscription might start off as sort of pending. You've not really fully taken it out yet. You've not made the initial payment. It's then going to go active. It's then maybe paused, and it's then maybe going to be cancelled or expired or terminated. And you've got that whole kind of life cycle of that particular object going on. But there is one very key thing in this particular domain and system where, funny enough, people don't really like being billed twice. So there's one situation here where we really want to protect things, which is we only want to make sure that there is only ever one active subscription at one time. Now, this is actually something we can model in Postgres by using two different features of Postgres together. So Postgres has this concept of partial indexes. So when we create an index on a table, we can specify a where clause with a predicate, and it means that only rows that match that predicate will be indexed in that particular index. So we can use this for a whole bunch of different use cases, but we can also combine it with the fact that an index can be classified as unique. Now, in this particular situation, we can express that situation where we only ever want to have one active subscription at any one moment in time. And this is a perfect way of being able to do that. We can specify we're going to create this unique index where we only index records where the status is active. And if this situation comes along where we either try to update a subscription to being active to make two active subscriptions for one member, or we insert another subscription that would be also active, Postgres is going to error and say, sorry, you can't do that. And this has really saved my own ass a few times when trying to kind of deal with this problem. And then kind of the final different pattern I'm going to talk about is how we can go about sort of managing automated payments within this style of application. So this is obviously a multiple different approaches to this, where, for example, we could just have a kind of old-fashioned style cron job where we basically query the list of subscriptions, and then we go through, find all the active subscriptions, and then check the last time that they were renewed and, process it that way. But that's actually not very useful for a whole bunch of situations and can be very difficult to test. So I much prefer if we can break this down into a situation where it's actually more of a scheduled task style problem, or potentially what you might consider a slow-moving message queue. Now, I don't want the complexity of having yet another system involved, so we can actually use Postgres to deal with this. So we don't need nothing more complicated than we have a table of tracking all the tasks that we need to process and that we have processed. And a task is nothing more than a time where it's going to have to execute after, the fact whether we processed it or not, maybe some information about how many times we've retried it. And there's some basic information about that particular task, like what needs to be executed, and then some basic properties. You can almost think of that as like a function name and some function arguments. It's kind of important that we don't really want to make the particular value we're storing here, again, we're using JSON, too large. It really should just be a couple of like key values that we just want to use in a kind of flexible way. But we don't want to be storing, megabytes of JSON value in this particular case. And this is where we can then use another very nice handy feature of Postgres. We can actually build, using this single query, a multi-consumer kind of parallel safe task execution environment where we're going to execute everything atomically. So very importantly, we need to make sure that we have this executed inside a transaction. And then what we're going to do is we're going to select from our tasks where it's not been processed, where it needs to be processed, i.e. that time is now in the past. And we're going to just keep it simple. We're going to select one row and we're going to process one thing at a time. Just keeps our application logic very simple. And then we get the real magic. So by these 4 keywords at the bottom, for update, skip, locked, we can build that kind of parallel safe consumer. So for update is going to say for every record that we select, we want to lock it as if we're going to update that record. And then skipped locked means if we come across another transaction that has locked a row in our task table, we're just going to skip it and go to the next one. So those 4 keywords build us that parallel safe kind of atomic processing and consuming logic. Now, actually, how do we go about making sure this is not ridiculously slow? Well, again, this is where we can use Postgres's partial indexes to kind of deal with this situation. So we can create a partial index on our task after column where everything is not processed. So we only ever contain inside that index the tasks that have not been processed yet. And if we look at the kind of explain plan, we then see our particular query in this case, all it's got to do is a very simple backwards index scan on this, and we defer a little bit more work to vacuum to deal with kind of expiring stuff out of that index. And then retry is not much more complicated than we're just going to put the execution date back into the future, and we're going to track it with our attempt counter. So again, this is a very simple, lightweight update where we're not updating kind of too many instances of stuff. So we kind of get the advantage of being able to use hot updates and stuff like that. But again, like this is not for necessarily really high throughput systems. And this kind of works perfectly fine for majority of lots of different use cases. And then obviously when we come to completing a task, that's as simple as saying, well, we've processed it now, so we don't need to process it again. And then maybe we want some information about, was this task failed or not? But especially when we're dealing with payments, there's a very important aspect where we need to be sure that we deal with certain things in a kind of idempotent manner. So when we talk about idempotency, we mean effectively the concept of if we rerun this task, we will always have the same result. So we will always have the same set of side effects. And that's a very important concept, especially when it comes to dealing with payments. And a situation like this is where we kind of have a renewal job that happens, and then the last step of that renewal job is scheduling next month's renewal. And we want to make sure that we only ever have one of those tasks in the system at any one time. And so we can do that as simply as by adding the concept of an idempotency key to our tasks, and then using a couple of other Postgres features to make sure that we only ever have one. So we can add a constraint, which is unique on this particular idempotency key, so we can only ever have one record with the same key. Now, as long as we're calculating these keys in a deterministic way, that's going to solve a significant part of our problem. And then what's very important is, because we're actually using all of this kind of in a single transaction, is to make sure that we don't have an error when we insert that record, which is where another very handy feature of Postgres called onConflict is very useful. So we can actually specify we do the insert, and if we get a conflict on that idempotency key, in this particular instance, we're going to do nothing. We can also instruct with Postgres to do an update instead, and this is a very powerful mechanism in Postgres where we can kind of get an upsert style functionality that I also use in lots of other use cases. So with that, thank you very much for listening. I hope there was some very interesting and useful tips for people there, and I look forward to chatting in the comments.
Thank you, Chris. That was so cool. I think these are all real-life examples from my application you're building at the moment. And for me, what really stands out is if you understand more about the Postgres database, how much easier you can develop your application in a so much easier way. So yeah, I think everybody learned something from these examples.
Yeah, absolutely. And I like the way he took sort of an example of events and then just started, building and layering more and more features and capabilities on top of that, and leveraging Postgres features to do that as well.
Yeah.
And sorry, go ahead.
Yeah, sorry. I was a little bit too quick there. I love the introduction. I wrote it down. I have to pick. It's a nice way to think about engineering. It's like you find creative solutions and you'll have to look a level above and a level below what you're actually seeing. That's a really nice way of be creative in engineering.
Very useful. And also Postgres as an introduction, and that's another beast as well. So I know somebody, I think, put a comment around a podcast on talking Postgres, so I'd love to learn more about that as well.
Yeah.
All right. So survey, we're going to keep hammering this message. Feedback is very helpful to both us and the speakers. So please, do fill that in. Again, all the speakers are on the Discord channel, so and answering questions live about their talks. So please do go there and ask questions if you have any.
Yeah.
And let's also maybe take a sneak peek for Livestream 3. I'm really excited to get a sense for all the talks that are going to be there. So Dwight, let's roll that.
Hi, I'm Bruce Momjen. Today I'll be delivering a talk called The Wonderful World of WAL. The write-ahead log is a fundamental part of Postgres. It allows implementation of crash recovery, physical replication, and logical replication. People who are curious how these features work and how to make best use of them will find this talk entertaining and useful.
Hello everyone, my name is Diradwan. I'm part of the Global Black Belt team in Microsoft, covering EMEA, focusing on Postgres and other open source databases. This session is building event-driven systems with Postgres, logical replication, and RASI. In this session, I'll show you 3 ways to tap into that stream and build event-driven architectures directly on Postgres. We will run live benchmarks, compare real latency numbers, and look at working code that you can deploy today.
Hello there, my name is Paula Golub, and I'm a senior developer / consultant at Cybertech. And today I want to introduce you my new tool, PGCov, which helps DBAs, developers, DevOps, managers to measure the coverage of SQL and PGSQL code to know which parts of your code are actually executed during the tests.
Hi, my name is Jeremy. I am a Postgres engineer at Geico.
Hi, my name is Leo. I am a native PG maintainer.
We're going to be talking about an exciting feature in cloud-native Postgres called failover quorum.
And you definitely need to know it if you use synchronous verification.
Hey everyone, my name is Abe, and today I'm going to be talking about one of the most important shifts in the way we work with databases today. The move from simple queries to AI agents. So if you're a builder or someone who just loves to make apps on the side, you can stay for this talk.
Hi everyone, I'm Divya Bhargav from Postgres team at Microsoft. Today we are going to be diving into the real-world performance gains of Postgres 18 over 17 using actual production query patterns. No synthetic benchmarks here, just SQL you'd really run. Let's explore not only how much faster it is, but why it's faster and what that means for your workloads.
Hi everyone, I'm Julia.
Hi, I'm Paula. And together we are responsible for the development of Serenity Star. We are also active users of Azure database for PostgreSQL. We've been using it for the past couple of years as part of the infrastructure setup of our platform, and we want to share with you some of the lessons that we've learned along the way. Today we'll walk you through how we implement the retrieval augmented generation in Serenity Star, including some of the architectural decisions behind it. We will talk about the challenges we face and how we solve them using Azure for database for PostgreSQL.
Hi, my name is Varun Dhawan. I'm a principal PM with Azure Database for Postgres team at Microsoft. Today, I'm going to talk about the massive shift which is happening in the data architecture pattern and the rise of Postgres as the everything database. So please join me.
Hi everyone, I'm Sai Srirampur and I'm here to talk about Postgres isn't slow, your storage is. In this talk, we'll double click on what are the common problems that Postgres users run into. We'll see that most of these common problems tie back to disk and IO performance. We'll also present the secret sauce that solves most of these problems, which is local NVMe storage. We'll do a bunch of benchmarks which show local NVMe performance over EBS-backed storage. And as an icing on the cake, we'll talk about how do we take this to production? How do we get an enterprise-grade Postgres with local NVMe? Great to be here again.
Hello, everyone. My name's Ding Ding Lu. I am a product manager at Microsoft. Welcome to Posette 2026. Today, I'm going to bring you a talk called Why We Built Azure Horizon DB. If you are a developer or a DBA and wondering what additional benefit Azure Horizon DB may bring to you, this is the talk you want to join.
Hello, my name is Sarath Balathiyapalli. My talk is about maintaining large tables in PostgreSQL. I'll be discussing about various performance challenges associated with maintaining large tables in Postgres database, along with recommendations or solutions to have a consistent performance. The talk basically targets database developers and database administrators.
Yeah, another live stream full of amazing talks.
Yeah, interesting. And it was interesting that lots of sort of real world examples and use cases in this live stream as well. So looking forward to that. I know a couple of talks stood out. I think one was just Bruce. Momjani is one of the OG developers of Postgres, I think coming from all the way back in the mid to late 90s. And for us to hear about from him on Wall, I think will be very interesting. The other was actually, Sai is a very energetic speaker. So I think that's going to be fun to learn about, the storage aspect and how that could help with performance as well.
Yeah, Abe was the speaker who surprised me the most last year. I never heard of him, and then he delivered this talk like he's been speaking forever. It's like it was so smooth and so good. It was really good. So yeah, cool to have them on board. But
Nice.
with on our stream,
Yes.
Pamela is next. And as I mentioned in the introduction for today, this was the talk I learned most from. Up to now, when it was about AI talks, it was a little bit like, yeah, it's kind of cool, new technique, but how does it improve my life? And after seeing this one, it's like, this is how I can improve my on-call service, for example. So it's a really good way to use AI knowledge in your advantage using MCPs. And I think this is a great introduction. What do you think?
Yeah, same here. I mean, I also did not think about some of the challenges that she brought up in this talk. So it was very informative and really useful talk for me as well. Pamela is a cloud advocate in Python in Microsoft Azure. So let's take it away.
Hey, I'm Pamela, and I'm going to be talking about building a MCP server for your Postgres database. We're going to look at the range of ways you can build MCP servers, from very exploratory servers where the agents can send full SQL queries to your database and do all sorts of things, maybe things you don't want, and then look at fully typed operational servers where you can have maximum confidence in the SQL that's going to get executed, but agents can still get their questions answered. So join me to learn more about building an MCP for your DB. So my job is to help Python developers build with new technologies. And for the past year, it's been all about MCP. It's the hottest new technology and the first standard to really get embraced by all of the generative AI industry. And people are really excited about it. So I'm excited that I have the chance to talk about MCP for the Postgres audience. So let's start off with a little demo that I recorded where I use GitHub Copilot to ask a question. Here, the question is, hey, which bees are active in El Cerrito in April? That's where I live. So now GitHub Copilot, the agent, is thinking. It's using Opus 4.6 to think about this. And it sees that it has an MCP server that it can query to get back an answer. So it's okay, I can query this database using this MCP server. It queries it, runs some SQL, gets back a bunch of rows about bees and observations and says, hey, the top groups are bumblebees. And I can confirm that that is correct because I can look outside right now and see bumblebees all over the garden. So this was just an example of how we can connect agents with MCP servers in order to get our questions answered and get our jobs done. So what even is MCP? It stands for Model Context Protocol, and it is an open protocol that defines how AI apps and agents can get context from external tools and data sources. Now, this protocol was first proposed by Anthropic, but then it got adopted by everything, and now it's part of the Linux Foundation. So it is a full, proper open protocol. Before MCP, when we wanted to integrate AI apps and agents with different data sources, we'd have to come up with these custom integrations. But now, thanks to MCP, we simply put an MCP server in front of each of these data sources, and that creates a common protocol for getting information from them. Now, one of these data sources could be a Postgres database, and that's what we're going to dig into. So let's actually build that MCP server that I demoed. Now, what we're going to see is that there's a range of ways that we could build an MCP server on top of a Postgres database. On one extreme, we have exploratory servers where the agent can actually write the entire SQL and send that whole query to the database. And that's where you're really putting a lot of trust in the LLM and the agent. But there's a lot of risks there. So on the other extreme, we have these more operational servers with these fully typed constrained tools where we don't have the risk of full SQL. And then we've got options in between as well. So we're going to explore that whole progression today. Let's start with freeform SQL. It has the maximum flexibility, but also the maximum risk. So here is our simplified Python MCP server code. So we create a server using FastMCP, which is my favorite way to build MCP servers in Python, a very, very popular package. And then we define two tools on this server. The first one is a tool that gets the database schema. So we say, okay, when you call this tool, it's going to do this SQL statement that gets back the schema and then dumps it back as a string. Then the next tool can actually take in a SQL query, any SQL query, and then it's just going to execute that SQL query against the database connection. So that SQL query could be a select, but it could also be an insert, update, or delete, right? There's a lot of options for what you can execute on the database. So what that looks like in action is actually what we saw in the demo already, is that, first the agent says, okay, I'm going to call that schema tool in order to find out the schema of this database, see what tables are available, what columns they have. And then once it sees that, then it can execute the SQL against those tables to get back the answers that it needs. So this works, and I was able to get my question answered, which is awesome. But there are some definite problems with this server. So the first is that schema tool. It dumps everything, the whole schema. In this case, that's not a big deal because this is actually a small demo database, which only has 5 tables and 60 columns. But you can imagine in actual databases, you may have hundreds of tables, thousands of columns, and that schema is just too big, right? Like, it's going to confuse the LLM. We've seen so much information, most of which it doesn't need. And it may exceed the context window of the LLM because LLMs do have limited context windows. So you're not going to always be able to have a tool like this that dumps the entire schema. What you can do instead is that you can have the kind of progressive schema discovery. So you can have this list tables tool that'll just give back the names of the tables. You can even describe each table. And then you have a describe table tool, which is going to get back the columns for a specific table. So if we give these tools to the agent, it's going to first call list tables to see all the possible tables it could use. Then it's going to call describe table only on the tables it cares about. So in this case, it describes the species tables and the observations table and gets back the columns for each of them. So what you can see is that it had to do 3 calls instead of 1 call in order to get back the schema information that it needed. So that is an increase in calls overall. And that, so it may not be worth it to move to this progressive schema discovery tools. But if you do have a really large schema, then it's definitely something you want to consider as a way of, the agent just being able to discover the schema information it needs to answer its current question. Now, a really big problem is mutations without guardrails. It is way too easy to mistakenly update or delete. So in this example, the user said, oh, how many bee observations have a low quality grade? Actually, delete those. So the user is actually suggesting they want to delete, but they're doing it in a really casual way, right? So they say that to the agent, and Opus 4.6 is actually like, wait a second, are you sure you want to delete almost 20,000 rows? It's kind of a big deal, right? And maybe the user would think like, oh, wait a second, do I really want to do that? That's just a lot. Now, Gemini 2.5 just goes ahead and deletes them, doesn't even ask, right? It just goes for it. So, I think Opus is kind of nicer in that it asks for confirmation for, a big deal of deleting that many rows. But here's the thing is if your tool exposes the ability to do a deletion, there is some agent, some model out there that will do that deletion. So you cannot rely on the safety of models. You have to make your tools themselves be safe, right? And that's what we're going to look at is how can we make the tools be safe? So the one option we have is to try and enforce read-only SQL. Just allow selects. That's it. Only safe selects. So here we have the code for a read-only SQL tool. It has this read-only hint at the top, which annotates the tool as read-only. It starts off with checking the SQL statement to see that it is only a select statement, and then it executes that statement and it limits to a certain cap so that it's not fetching too many rows. So there's a couple interesting things here that we'll dig into soon. Now, when we actually use this agent from, we use this MCP server from the agent, we can see that it is able to send a complex select query and execute that query and get back the response. So we can still use this tool to answer that question I had earlier. So how do we enforce the read-only? So the first thing is we have that read-only hint. You saw that that was on the MCP tool. Read-only hint equals true. This is something that's in the MCP spec where tools can be decorated to describe how they work. So there's like read-only, idempotent, destructive, etc. So in this case, we're saying, hey, this is a read-only tool. But it is only a hint. It is a hint that MCP clients can use, and they might change maybe the way the tool is rendered, maybe change the way they do approvals. But it's really just to be used for UI, because the thing is that it's only a hint. It's not a contract. It's not a guarantee. So you could totally annotate a tool as being read-only, but in fact, the tool might allow non-read-only operations, right? So it is up to us as the developers of the MCP server to make sure that the tool is in fact read-only if that's important to us. So how can we do that? So the first thing we have is that call that validates the SQL. So this call uses the library in order to parse the SQL statement into an abstract syntax tree, an AST, and then checks to make sure, hey, there can only be a single statement here, not multiple statements. And that single statement has to be a select statement. Can't be insert, delete, update, etc. Right? So that actually does block a lot of potential queries that could go through. So it'll block any sort of invalid SQL. It'll block multiple statements like this one. It'll block a delete for sure. And it'll still let through the select statements. So that is our first attempt at enforcing read-only. The next thing we're going to do, and this is really important, is to enforce read-only at the database level. So we can do that at when we set up the connection, we can say, hey, for this connection, it is default transaction read-only on. So that's going to say only read-only things can happen. And then even better, we can create a dedicated read-only role and use that whenever we're sending the query. So this role only has the ability to do select on this particular schema in this database. And with those combined, that gives us a high-level enforcement on the database level itself. So that'll block inserts, drops, deletes. It also will block this trickier thing, which wasn't blocked from our parser. So this is a CTE, a common table expression, where it starts with blah, 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 select from. That might have passed through the parser, but it will get blocked from this database level enforcement. And we're still letting through the selects that we want. And what happens is when the agent tries to send in a delete operation here, it'll get back the error response that says, hey, that's just not allowed. You can't do that. And then it'll try and suggest like, oh, maybe you can like try and run this locally, right? So this is the kind of experience we want, is for the agent to realize, oh, okay, this can't be done, and to give the user more information. But what we can see is we need a lot of layers of protection to try and make this SQL safe, right? Like we've got these four layers of protection because you can really construct a lot of tricky SQL queries. And some of them will make it past different layers, right? So that with statement actually passes the parser, but luckily gets blocked by our database enforcements. Now these ones are interesting. You can do these selects with Postgres functions that have side effects like terminations, reading files, etc. We don't want to let those through either, right? Now, fortunately, those get blocked by using a least privilege role, right? So it's really important that you have that as well. And then we can also have operations that just take too much time on our server, which is basically like DDoSing our server. So you can do a PG sleep function or a cross join that's just way too big. So those we kill using a timeout that we put on the tool and said, hey, this tool can only take 30 seconds max. So we need those 4 layers of protection just to feel confident that, we can let agents come up with SQL queries themselves. But are we still confident? I'm still not 100% confident, right? I think there's still a possibility that something could get through that, that I haven't accounted for, right? So if I really want to feel very secure, then the best option is to not allow the agent to write the SQL, to not allow the execution of arbitrary SQL statements. So that's when we move to our strictest level of tools, which would be fully typed tools. And these are all using templated queries. So this example here is a tool, a read-only tool. It searches the species table. It takes in specific parameters, the query and the limit, and then it uses this templated SQL query that it passes that query and limit into. And it also enforces a max limit here so that we don't pull too many rows. And then gives back the typed results based off of the rows. So this is very restrictive, very specific, but can still get back a lot of information. So when we call that, you can see that the agent, instead of passing in a SQL query, it's just passing in the parameters, right? So here it's just passing in, oh, the query is carpenter B. When it calls this other tool here, search observation, that one actually takes 6 parameters. And so the agent's going to suggest all 6 parameters, and those get passed into the template SQL query. So we can do fairly complex queries, but we're still asking the agent just to come up with the parameters and not the query itself. Now, that works in order to answer those questions, but then there's other questions that I simply can't answer with these tools. So if I ask, oh, how many total observations are in the database, the agent realizes like it simply doesn't have the tools it needs to answer that question. So that's the issue with type tools. They're the safest, but they limit what the agent can do. So if you are going to have type tools, you really want to monitor users and see what do users want to answer, and then add more tools as you need to. I didn't drink some water. Now let's look at elicitation. Elicitation is another way we can add a layer of safety. So in this tool, here we're adding a tool for deleting observations. Now this is a destructive operation, so we've also annotated it as being destructive. And so we really want to be certain that the user wants to delete this observation. So what we can do is use elicitations where we say, hey, are you sure that you want to delete this observation, and give the user the option. So the MCP client, like GitHub Copilot, will actually send up a prompt that has this elicitation here and ask the user to confirm that they want to do this operation. And then depending on what the user says, so this is actually, getting back input from the user. Depending on the user's input, we're either going to go forward with the with the deletion, or we're going to cancel it. So this is what it looks like in VS Code. So, it runs delete observation and says, oh, you're about to permanently delete this row. And what's nice here is that I can give more information about what they're going to delete because I've already looked it up in the database. And so then the user can really think like, oh, wait a second, maybe that's not the one I want to delete. So I think this is a really nice user experience. And so then I can confirm yes or no, and then the tool can, decide to delete or to cancel the deletion. Now, you can use elicitations for all kinds of things. So I think it's a really great thing to use when you're doing any sort of destructive operation, just to double check. But you can also use it if there's any sort of ambiguity, in the user's query, or if you want to refine the parameters, if you want to suggest a different sort of a query or parameter. There's many things you can use it for, right? Just imagine all the things you might want to throw up an additional prompt for and get back more information from the user before you continue on. Okay, so we've built the tools, we've got this whole range of tools. Now, as you're getting excited about building tools, you might want to build more and more tools, right? And you might have, dozens or hundreds of tables that you want to build tool for. Well, then as you build more tools, you're going to have the problem of the agent having to select between those tools. When an agent only has a few tools to pick from, it can do a great job. When it has more and more tools to pick from, and those tools are increasingly similar to each other, it can have a harder time picking which tool is going to be the right one to answer a particular question. So I wanted to talk about this tool selection problem and do a little experiment to think about how we can handle this. So for my experiment, I added 2 tools. The first one is search observations, and that is searching recent B observations from 2020 to present. And, it says that you need to use the other tool for older ones, and you need to call both tools if you need to span all years. And then the second tool is searching the historical observations before 2020. And, it has the same tips about the other tool and to call both tools. So you can see these tools, they know about each other. They reference each other in descriptions. And so the agent is going to get all this information. Generally, when an agent is looking at an MCP server, the information it gets is the tool names, the tool parameters, and the tool descriptions. So this is actually all prompt engineering, is deciding what you're going to put in those names, parameters, and descriptions to help the agent decide which tools to use and what to pass into those tools. So then I ran a little experiment, right? If I send a bunch of queries that should need both tools, how does, what tool does the agent decide to call? So here we have some successful queries. So I said, oh, past and present, it called both. Compare 2010 versus 2024, called both. Compare these 2 years, called both. Okay, great, good. But then there's other ones like, oh, have we ever seen these leafcutter bees? All right, it only called recent. Include all years, only called recent. All records in a year, it only called recent, right? Full history, only called historical. Always historical, right? So these are all examples where it should have called both, but for whatever reason, it only called one of the tools. And that means that the answer is not going to be a full answer. It's not going to be a comprehensive answer. It's not going to be an accurate answer, right? And that's a big problem if people are expecting to get accurate answers from these coding agents. So in this case, we really do not want to have to make the agent choose, right? If you have these two tools that are so similar, so ambiguous, it can be just too confusing for the agent to decide between them. And, it's just not going to call them in all the situations you want them to call them. So in this particular situation, we have a few possible fixes. One fix is that we could return a hint in the result from each of the tools that says, oh, okay, this tool only covers this kind of data. For the other kind of data, use the other tool, right? And so that kind of might remind it like, oh, good point. Maybe I'll call the other tool, and so it'll do a follow-up tool call. The other thing that would be nicer, that would be more agent friendly, is to add an additional tool or a different tool, actually replace, take out those tools and instead define a search all observation tools. And that tool is just going to query both tables internally, right? So we shouldn't expose the data split to the agent. We should just take care of that behind the scenes. And then, of course, you could just refactor the tables in your database to keep everything in one table, and that might make things easier for lots of people, not just your agents. But generally, this was a specific example where we have a tool selection problem, but you're going to have other kinds of tool selection problems, and they all follow a general pattern where if you have tools that are too similar to each other, where it's really not clear to the agent which of the tools are going to answer the question, then you have the risk of it not calling the right tool. So what you want to do is think very carefully about tool descriptions and names, and consider, whether you're defining the right tools. Set up some evaluations like I did, and see what the agents actually do, and decide, do you need to change your tool design, merge some tools, make some changes. Okay, so we've looked at a lot of ways to build MCP servers on top of your Postgres database. As we saw, you can do these more exploratory servers where you're letting the agent send in the full SQL, and that has the advantage that you can answer all sorts of questions that way, and can be really useful, especially for people who are using databases internally and need to get a lot of questions answered. But it has this huge risk of allowing all sorts of SQL operations, right? And then on the other side, we have those fully typed tools, but they can only answer a more limited range of questions. And then in the middle, we have the read-only SQL queries there. So you can figure out where you are in the spectrum, what is going to work for your situation. You want to mix and match different things here, but definitely keep in mind all your options for how you can, enforce that only the operations happen that you want to enforce, because you can enforce a lot of this at the database level, and that is going to be your safest approach. And then adding more layers on top, because it's really powerful to build MCP servers for your databases. So I want to encourage everyone to do it, because it can really empower your users, whether they're internal users or external users, to be able to use natural language to interact with the database. So definitely do it, but keep all of this in mind when you are designing your servers, and consider how you want to go about your server. So thank you so much for watching. You can grab my slides from this URL here. You can grab all the code from this repo. And if you have any follow-up questions, you can always hit me up online, and I'm happy to chat more about MCP. Bye, everyone. Thank you.
Awesome. This is such a fun talk. Thank you, Pamela. Thanks a lot for the presentation there.
Yeah, it's definitely not only fun, it's also so useful and so practical. It's like, I know I need to do this. Like, I will try to make time for this next week.
Yeah, and especially like, kid proofing, or I guess AI proofing your database, or at least thinking about that, right, is how you go about it as well. And yeah, I mean, it's just super useful. I mean, I know folks in Azure have been using this for their operations, right? Investigating tickets. And so these kind of MCP servers and the capabilities they expose to your AI tools really makes that super simple to do.
Yeah, I also like the skills, like from exploratory to the operations, where you want to be much more in control and more safe. And here you just want to learn things, and you can separate these things. It's like, oh, that's a good way of looking at it.
Cool. And I guess, Derk, how are you doing? I know it's about 11:15 a.m. in the Bay Area. How's your energy levels?
Yeah, I can use a little bit more of the introduction music at this moment, but I have a nice new cup of tea, so I'm good to go.
Awesome.
You?
Cool.
Coffee?
I've been sipping on coffee as well. I had a brief snack, so I'm ready to go. Survey again, and the socks. Please do take that, and feedback is really amazing. And coming up is Matt McFarland, who is a principal software engineer at Microsoft, and he's going to be talking about sort of the Postgres tooling across AI editors and agents. I think that's especially talking about sort of some of the VS Code, extensions and Postgres extensions on both VS Code and other AI coding tools as well. Have you had a chance to try this out, Derk?
I had a small moment where I could try this out, and then suddenly it appeared not to be approved by security, and then it got removed from my laptop again. But what most sticks with me from his talk is not only that this is something you want to integrate, but also the way he looks at your coding IDE.
Got it. Yeah, let's dive in. Take it away, Matt. Right.
Hi there, my name is Matt McFarland and I work on Postgres developer tools at Microsoft. This talk is about how our work around the VS Code extension for Postgres management is moving to a new set of tools to support new workflows that are emerging for database administrators and developers who are working on their applications. Please check out this talk if you are interested in AI-enabled workflows and managing your Postgres database with them. All right, so let's dig into a little bit more about what Postgres tooling across AI editors and agents mean. Around a year ago, we launched a VS Code extension for Postgres around this conference, actually. And that was a practical choice for us because that's where many developers are already spending their day, writing code, debugging, managing their applications. And our goal has always been to take and make useful and high quality Postgres tools and bring them where developers and DBAs are doing their work. Since then, that past year, the extension has grown to over 500,000 installs, and we've been able to get a lot of great feedback about what's been working well, what hasn't, and more importantly, where folks want to see these tools moving to. We had some clear demand about supporting the cursor IDE, but we also noticed a shift that's happening. I'm sure many of you have as well, which is that development isn't just happening in editors anymore. The work is moving into new terminals with AI-driven tools, and our goal remains the same. We want to meet developers where they are. Just initially, before we kind of dig into some of these new things, I want to do a sort of retrospective and look at what the VS Code extension has. If you haven't used it in a while, we've been working on it for the last year, and we've got some new features. So the core of the application is an object explorer with some search. You can manage your connection profiles. You can walk your database tree, do some searches across your database and schemas and find objects. There's a lot of contextual menus and opportunities to invoke actions here. Obviously, you'll be able to write your queries and look at results. We have IntelliSense and syntax highlighting. You can export in a variety of formats, do searching and sorting and filtering and all that kind of thing. If your results happen to be graph-shaped, like for instance, data from Apache Age extension will automatically determine the graph and be able to render an interactive display. For your explain analyze output, we have a query plan visualizer. So this can read your plan, come up with a number of visualizations to help you really dial into the expensive parts of your query, see where it's underperforming, and get node by node details about what's going on. We also have ERD style schema diagrams where you can see your tables, your relationships, columns, data types, things like that. You can filter by schema to only look at what's important to you in a large database. And we have performance dashboards. So we have live and historic metrics that lets you correlate across slow queries and do a lot of debugging and investigation to how your server and database are operating. And of course, Copilot, AI everywhere. Pretty much every surface area has a way to engage with an AI Copilot and not just launch a new chat, but actually we have tools to provide context about what you're actually looking at so the agents can also see, and it becomes a good partner for your debugging, investigation, and application development. Now, the tool has always been platform agnostic, and that's a core principle, a core goal of the project. However, if you are an Azure database user, we do offer a number of integration features that are more like convenience features. The primary one is around authenticating to your database using Enter ID. So that's something that happens sort of fluidly within the application. But we've also spent the last few months building out a suite of tools around server management. And these are things that you would typically bounce out to the portal to or have to go to a separate CLI to manage. And now you can do directly within the VS Code editor. So let's take a quick tour of those tools in action. Okay, I'm just going to run through a quick tour of some of the Azure management features that we've got added to the extensions. Here I've got an Azure server, a flexible server. I'm going to connect to it. After I'm connected, I'm going to pull up a dashboard. And because this is an Azure server, we have some extra metrics that we're able to pull in from Azure Monitor. If this is a non-Azure server on a different cloud or local or on-prem, you'll still be able to pull up metrics. They'll all be coming directly from the database server. But I have a number of features and configurations that I can pop over to here. So I'm going to pull up these network settings. You can see I can manage my firewall and public access. I'm going to actually go back to the Object Explorer tree, see if we can do it from both places. We can also view and list and sort of filter on our server parameters. So we can make changes just like we could in the portal. Here we're listing our backup settings that we can change. We can see if they're automatic or on demand and manage them, delete them if we want, make new on-demand ones right away, and restore new servers, restore new flexible servers from a specific backup. And you can also get your server logs if you've got those configured. And some control features as well to start, stop, and restart your server. You can also clone directly from a backup going through the clone server page. And there you have it, a number of Azure server management features directly in the extension. Great. So as I mentioned, one of our clear design signals for where folks wanted these tools was to support a Cursor IDE. Cursor IDE is a VS Code fork, so it has the same extension model. So in a lot of ways, the extension was already a little bit supported, and some people found ways to use it. We've been working towards a fully officially supported deployable extension within Cursor, and this includes all of the Azure and Entra integration points, and also integration into the agent experience that's not Copilot within Cursor. And I just want to point out that Cursor just recently launched V3. It includes an agent-focused app. This has an entirely different an entirely different extension model. So we're still kind of looking for what our integration approach is going to be there. So yeah, the next demo, we're going to take a look at Cursor. We'll see the extension running inside of the IDE and see all the features that you can use. So here's Cursor Classic, and you can see there's the familiar sidebar with the Object Explorer in it, listing all of your connections. You can browse connections, walk the database tree, use the search functionality, so you can find database objects throughout large schemas or databases that have many schemas. Here I'm going to pull up this orders table in a little shop demo I have and open up another new feature of object properties. So this will work on any type of database object that you have in the database. A header row up there has some sort of highlight information. It lets you reanalyze the table directly from there if you want to update some estimates or statistics. It has a full definition SQL, so you can look at how this object was created, and it breaks down all sorts of constraints and indexes and gives you a couple different lenses to look at the details for those. Additionally, we surface all of the security information. So if you have specific grants, those are listed with the grantees and grantors, the SQL for it. You can open it up in the query editor. You can browse what dependents and dependencies there are for this object. If there's things like row level security, that'll be surfaced here as well. And you can sort of link in and link through to different database objects and get all the information you need from it. So this is working across VS Code and Cursor. Obviously, you'll need to be able to run queries. So the same kind of query editor and query results interface exists across Cursor that you get in VS Code. We do have support for one of our newer features in both products, which is a visualizer for query plans. So running any query, you can opt in to generate a query plan, select some parameters, and you get this really nicely rendered graph with some color highlights identifying high cost areas of your query plan. I made a particularly complex one just to kind of showcase some of the UI that we have around it. There's a bunch of adjustments you can make to the layout and also to the rendering to help you sort of hone in on particular issues that you're concerned about. Here we can select, what we're rendering to try to highlight what are the most expensive parts of this query. I'm going to shift this back to the normal rendering and show a couple of different views we have. We have what's called an icicle chart, which is kind of like a flame graph that can also help show which nodes are the most expensive based on a configurable set of attributes and parameters. We can also show it as a table view. So this is sort of a top-down view, but we pop out a few columns so you can sort by them. So if you just really wanted to look at cost or the number of rows, that's something that you can really easily get to. And then what we kind of have everywhere across all of our sort of feature points is when you find something that you want to interact with, whether it be in a query plan or something else, you'll always find a Copilot button. Here, this is going to ask us if we want to include our query, so we can or cannot send the actual SQL query to the AI service. And now we're using Cursor's built-in model management and AI chat feature to use the MCP server that ships with Cursor, which is also the same one that ships with VS Code extension. And it's going to use some of the tools we provide about getting query plan context and node context, and actually will reach out to your database, check out some table statistics. For example, it's not going to recommend that you do a vacuum or something on the table as part of this query plan analysis if you've done it recently. So it has some sort of smarts to let it dig into your actual table and give you good recommendations about what this query plan is telling you, and potentially, if there's room for improvement, things that you could improve on it. Now there's more features that I'm going to show here that still work across Cursor and VS Code. So I'll head back to the Object Explorer, and this connection was to a local Docker database, and now I'm going to connect to an Azure flexible server just to show that the Entra authentication still works as normal. We can still pull in some specific Entra and Azure functionality. So here's a new performance dashboard. Because this is an Azure server, we have a lot of rich information we can pull in about what the platform is, what the version is. We can do some analysis to see what kind of metrics emitting services you have or don't have enabled. because that allows us to pull in various kinds of metrics or enhanced metrics. You still have the ability to use all of the Azure management features I spoke about recently, which were like downloading your server logs or changing your network parameters or your server parameters, all without having to pop out to the portal. You can just do it all within VS Code, and I'm sorry, you can do it all within Cursor. And because it is an IDE, you know, these text files can show up, and you can look at them right in your session. And of course, here again is chat functionality, so you can pop in and chat about this particular metric or metrics across your database with MCP tools that will reach out to Azure using your Enter authentication and get that information. So this brings us to the next architectural piece of the setup, which is Model Context Protocol Server, MCP. This is probably something a lot of you have been hearing about lately. It's basically an open protocol to provide tools and tool calling and tool context to AI agents. Previously, with the VS Code extension, we had built into some VS Code specific tooling, but obviously that locked us into that specific host. So instead, we've built all those database integration points into this standalone MCP server that can be shipped across these different host platforms. Not every feature belongs everywhere, so editors are a sensible choice for some of the rich tools that have graphical elements, and terminal or agent-focused applications that just rely on structured data have a smaller subset, but it's the same project that we're using across all of these surfaces. And getting that into your hands is where the new tool PGSQL Tools comes in. So PGSQL Tools, it packages standalone MCP servers with a number of utility functionality like creating and managing connection profiles, keeping connection credentials out of config files and in secure OS, keyring supported formats, registering the MCP server and running it with your particular agent harness. And this is basically how we complete the circle and provide the same functionality to these new CLI-based agent apps. And the next demo, I'm going to show you how to get that set up and run through it with the Copilot CLI. So we're going to start off by showing that the PGSQL Tools CLI is installed. I'm just going to check the version here. That'll be a different version when you're using it. And the first thing that I'm going to want to do is add a connection to my connection profiles. Now, keep in mind that these are different connection profiles than what you may have added in Cursor or VS Code extension. It just takes a connection string, a standard PG connection string, and you'll note that it prompted me to run a set password command because we didn't include a password on the initial add because we don't want it showing up in the CLI. So instead, we want your TTY, we let you enter it in securely, and it gets stored in your OS keyring. Next, now that I've added it and added a password, I'm going to list all my connections and expect to see this demo. And here it is, and it indicates that the password's been set. Now, the next thing I want to do is register an MCP server with Copilot. So really that just edits the configuration for Copilot to let it know that this MCP exists, and that gives it access to the connection profile and the tools that we're going to explore right now. So let me launch Copilot here. It loads the MCP servers. And without giving it too much context, I can just go ahead and give it a natural language question. What Postgres connections do I have? It'll see the servers, it'll see some of the indicators and find the right tool, which is PGSQL list connection profiles, which is right. It's going to ask me for confirmation. Do I want to use this tool? I'm going to say yes. And I'm also going to just turn off all permission requests going forward. For this demo, you may want to keep some tools on, like things that modify your database. You may want to be prompted each time it does that. You can do that. Right now, it's going to do everything YOLO. Let's ask it another question. What's on the server? So it goes ahead and uses some more tools, and it sees that I've got a couple databases and a couple schemas, which doesn't really help me understand the shape of it. So let's ask it to generate an ERD-style diagram of the shop schema. It's going to think about that, make some more tool calls, and gives me a pretty nice overview of what tables are in my schema and what the columns and the constraints are on it, which is really nice. Next, maybe we'll just have it write some queries to explore the data a little bit. So what are our top 5 customers by spend? So again, it has context about the actual database schema because of the tools, and it knows how to write queries in SQL. So it's going to go ahead and write a query for us. Here's the top 5 spenders. It correctly noticed that these are seeded demo data. It's a little bit suspicious. It's very insightful. Let's give it a slightly more complicated query. What's the revenue trend by month and which category drove it? So again, it knows how to write SQL. It knows our schema, so it can write a pretty good query about it. But I don't know if it's really pretty good. So I'm going to ask it actually to run and explain on the query and then let me know about the results. So it's going to run explain analyze and go ahead and sort of run through some of the insights that it gained from looking at the plan. It can also do, it can also write and update in your database. Again, I've turned the permissions off, but typically this would use a different modify tool. I'm going to ask it to create a new view for me for VIP customers. It went ahead and created that, and I'm going to query it just to make sure it's working as I expected it to. And sure enough, there's the results from the view. So the last thing I want to show is that this is sort of like within an agentic tool, so you can combine it into multi-step processes. So I'm going to go into plan mode, and I'm going to ask it to plan a refactor to normalize parts of my database. So it's going to use the built-in agent tools to come up with this plan. It's going to ask me a few questions about how to handle some of the the relationships between the denormalized tables, how it should handle backfilling for empty data, things like that. And it's going to go and think through this plan, come up with it, and present it to me and see if I want to execute on it. So this is just showing that this fits into the already very capable skills that the model has, but we just give it tools that let it easily know contextually what database you're sort of working with and talking about, and it can go ahead and sort of integrate that into its knowledge and really become a very helpful co-pilot for developing and doing DBA tasks against your database. Great. So that kind of wraps up where we've started from with the VS Code extension, moved into a very similar product, Cursor, and then also into these new products around agent-driven, terminal-based applications. We do have a number of next steps. So we are currently in the process of publishing the packages for Cursor ID. So you can get this on the OpenVSIX. I don't have the URL for it right now, but maybe by the time you're watching this, we'll have this published and I'll be in the chat to talk about it. We have some packaging to do for the PGSQL tools to figure out how to distribute that through NPX and some other command line tools. And after that, we want your feedback because we want to expand into new TUIs like Codex and Claude Code and whatever the next popular AI tool is going to be. So I appreciate you listening to the talk. Thank you very much. There is a URL at the bottom of this slide for our main VS Code extension project where we have a lot of information on that, and we'll also be posting information about these new tools. Thanks again.
Cool. Thank you very much, Matt, for sharing all of these and how much IDAs actually can do for you these days. It's crazy for me. It's like I remember starting with pure Vim, and now I'm moving more and more towards my IDA, and now I'm leaving my IDA less and less. How about you?
Yeah, same here. I mean, I grew up on Vim and Emacs, and to see, and like, your production instance and your database was always something separate, right? You had to go somewhere else to go look at it, examine it, understand the data, and then you have to come back and then do your, coding against it. But I just love the fact that it's all sort of now squashed into one, single pane of glass under your IDE as well.
It also helps a little bit that the computer screens have increased in size over the years. So at least you can have all these windows next to each other.
Yeah. Cool. Again, thank you, Matt. Here's the message again for survey and socks. But let's do a short detour. So we are excited to have Jess Ramos, who's a data analytics educator with a large following across TikTok, YouTube, LinkedIn, and Instagram. She specializes in making SQL and data analytics approachable. Runs a big SQL Energy course, and frequently interviews leaders in the data and database space. So she's, excited in attending Posette. So let's hear a quick short message from her.
Hi everyone, I'm Jess Ramos, also known as Jess Ramos Data Online. I'm the founder of Big Data Energy, and I make data and AI content on social media for over 650,000 followers. And if you've followed me for any amount of time, you know that I'm a SQL girly through and through, and that's exactly how I found my way to Postgres. The things that this community has been building for years are exactly what we need for AI apps, agent workflows, and modern data systems. And honestly, it's really exciting to watch. And that energy is exactly why I'm so glad to be here at Posette today. And I cannot wait for the upcoming live streams. These are the 5 sessions that I'm personally most excited to watch. Number 1, from queries to agents, because Postgres is becoming the backbone for AI agent data retrieval. And I've been wanting to learn a lot more about that. Number 2, the Horizon DB session, because I want to hear all about how cloud-native Postgres service is built for modern workloads. Number 3, the PG DuckDB in action session, because accelerating analytics directly inside of Postgres without having to export your data is huge. Number 4, the Postgres 19 hackers panel, what's in, what's out, and what's next. That should be a super interesting look behind the scenes with 4 Postgres committers into what we actually have to look forward to with Postgres 19 and what it's like to be a Postgres hacker. And finally, number 5, the Hitchhiker's Guide to Postgres Hacking should be a really interesting take of what it's like to become a new code contributor to the Postgres open source project. And this Postgres community is doing awesome things, and I'm ready to learn. Let me know on LinkedIn what you learned today. I'll see you later. Bye.
Awesome.
Cool.
Very cool.
Really cool.
Yeah, Jess has an amazing following and is quite influential in the community. So I'm glad that she's also observing and seeing the impact of Postgres in the broader data community. And really like the line that she said is, it's becoming the backbone, especially for AI and agentic workloads, which is, interesting that it's being seen elsewhere too.
Yeah, it's really cool. Also to see how big you can be when you know a lot about data. I often say like data is so big these days, but then she sells it so well. It's really well done.
Yeah, absolutely.
All right. Christian,
Yeah.
he
Go for it.
definitely taught me some new things about how you should look at data. For me, graphs were always a little bit like, I didn't know what to do with it. And when I think about it, I think of a try presentation from the past where someone tried to explain me graphs and I obviously didn't understand most of it. And now Christian has such a nice way of explaining what a graph is and how you can look at your data. It was really insightful for me.
Same here. Very cool. Also recently learned about Apache Age or AG, so that was also nice to learn more about that. And Christian Miles is the head of product at g.we. And so let's take it away, Christian.
Hi everyone, my name is Christian Miles, and I've been working with graphs and graph databases for about 15 years. My talk is about a Postgres extension called Apache Age that helps you run graph workloads on top of relational data stores. I'll be walking through the graph database landscape and where Age fits in and how it compares with other extensions like PG routing. And then I'll focus on something I'm really passionate about, graph data visualization, when to reach for it, when to reach for Apache Age, and the pitfalls to avoid along the way. Let's dive into querying and visualizing graphs in Postgres with Apache Age. I'm Christian, and I'm based out of Victoria, BC, far left of the map there, the very bottom of that little island. My accent gives me away. Originally, I'm from the UK, but I've been in Canada since 2012. And I've been working with graphs, graph databases, and visualization tools for close to 15 years now. I wear a lot of hats, some sales, some engineering, some product. But the through line for me is helping people do useful work with connected data. And I'm here today with G.V. We make a dedicated IDE for querying, visualizing, and debugging graph data. So here's the plan. I'll do a quick pass through the key questions I get asked about graphs, what they are, why there are so many databases, and where Apache Age fits. And then I'll spend the rest of the time on visualization, what works and what doesn't. Here's a slide with a bunch of pretty things. We have a flow chart in the top left overlaid onto a map. We have a Sankey diagram in the top, a version control graph from Git on the right, a circular dendrogram, as it's called, right there in the middle with the bundle edges, and a network model of a mouse brain on the far left at the bottom there as well. And there's a few others on the slide. But these pictures all have something in common. They're all graphs. Yes, all of them. And there's no shortage of names. Networks, charts, maps, topologies, they all share a common property. They're built from connections between things, nodes and the relationships between them. And that's a deceptively simple set of building blocks for representing quite complex ideas. Okay, I'm already kind of off the rails with the FAQ, but is this a graph database? No one actually asked me this, but it's a really common misunderstanding. And one thing I'm a bit of a stickler about is that many graphs are not actually graph databases. A graph can be as simple as a CSV where there's a source column and a target column. It can be two relational tables with a foreign key between them. A graph is just simply a way of thinking about data that prioritizes connections. A graph database is a system built to store and query that structure at scale. A classic example of a graph is a social network, the graph that underpins Facebook or, say, LinkedIn. In the commercial world, you see a lot of graphs in know your customer and compliance work, following chains of payments across accounts, institutions, jurisdictions, anywhere the relationships between entities are just as important as the entities themselves. And briefly, the sorts of questions you're asking of a graph data tends to be different from relational queries. Things like, how many hops between two entities? What's the shortest path? Which nodes are most central to a network? There's a whole field of graph analytics that operates on this connected structure. I'm not going to go deeply today, but it's worth knowing that there's an analytical layer sitting on top of what I'm about to show you. But it struck me recently that there's no resource to understand the full landscape of graph databases. So I put together a site called gdbengines.com. It lists all the graph databases I could find, along with some important categorizations. Most people hear about graph databases through Neo4j, and they've done fantastic work popularizing the technology. And for some people, Neo4j is synonymous with graph databases. But as you can see from this partial list here, there are over 100 different graph databases, and they differ in important ways. Three categories matter for today. There are native graph databases, where the graph is sort of a first-class concept baked into the architecture. Extensions, where a relational database has been extended to do graphy things. And query engines, which sit as an analytical layer on top of the existing data store. Now, the next question I get asked after seeing all these databases, which is the best one? And I'm going to give you a classic engineering answer. It depends. It depends on your current stack, your data volumes, whether you need graph and relational data together. One underestimated consideration is, what does your team already know? Familiarity with a query language or a particular technology or stack is important. And then the final thing I'll mention in terms of the considerations here is that, is this your primary data model, or is it an analytical overlay on top of existing stores? These are all different requirements. Because graph databases prioritize connected data, they come with query languages designed for that structure. I've got a few on the slide here. I put together this little timeline. Our product is called G.V as a reference to the Gremlin query language, one of the first we supported. So you can see there in the top right there under Gremlin, you can see the G.V with the open bracket, close brackets. That's a sample query there because it represents graph.vertices, yet another name for nodes. Gremlin models traversal as a first-class operation, which tends to appeal to people who think about graphs mathematically rather than declaratively. A traversal is simply walking from one node to another along edges in a graph, the fundamental operation in any graph query. I want to spend a little time talking about Cypher here in the middle of the slide. It lets you query using what's essentially ASCII art, so a little like text representation of the graph that you're querying against. You write patterns that look like the connections you're describing. A lot of people find this really intuitive, and it led to the open Cypher standard, which is now used across multiple databases. Now, I've included GraphQL on this slide too, because it's a common source of confusion. GraphQL is an alternative to REST for API queries. It lets you do nested selective queries against endpoints, but in itself is not actually a graph database query language. Now, some database vendors have muddied this by using GraphQL as an interface, but those are different things. And then GQL there at the bottom of the slide. You can think of this as a formalized standards body-backed future for graph query languages. More collaboration, more convergence. And to answer the original question, SQL PGQ is a parallel effort bringing graph pattern matching into SQL itself, part of the SQL standards since 2023. And you can see there that at the just above GQL at the bottom of the slide. I'm going to take a little bit of a diversion again and talk about knowledge graphs. This is one term you may have heard of. It gets applied nowadays to basically any system that aggregates information across an organization. So the marketing usage of it is broad. But a more rigorous definition of this pairs data with an ontology, which is a formal model of the types, relationships, and rules behind a graph. And this enables reasoning, the automatic inference of new facts from existing ones. So on the left here, you have a property graph where nodes carry buckets of properties, whereas on the right, you have the same data expressed as RDF triples. So this is just a fancy term for the subject predicate object model that we have represented there in the network itself. This structure is more rigorous, and that enables the reasoning I just mentioned. So in this case, this artist, we can reason that they signed to a label because there was an album released under that label. And that's something you can't necessarily do on the left-hand side due to the fact there's no formal scheme or ontology for the label property graph. Now, there are different tools for different problems. Property graphs are more common in the databases we'll be looking at today. I've done a whistle-stop tour of graph concepts, but the terminology doesn't stop here. Folks have come up with ways to apply graph thinking to basically any domain. Fraud detection, network topologies, supply chains, identity resolution, the list goes on and on. At G.V, we support customers doing all of these things, and regardless of the specific language or technique, it all comes down to the connected nature of the data. Now, AI, of course, has reignited interest in the use of graphs to help with things like context management and retrieval. Watch out for people saying things like hypergraphs, which again is another fancy term for just generalizing some of the concepts I've already described today. So you've seen the landscape of over 100 databases, various query languages, and different categories and trade-offs. At some point, someone always asks, can't we just use Postgres? The rest of this talk is about a particular extension that lets you do exactly that, and about what happens when you need to actually see the graph data that comes back. There have been several attempts to bring graph capabilities into Postgres. At the simplest level, on the far left there, you can bend Postgres to your will with stored procedures and recursive common table expressions. It works, but it's pretty painful and verbose, and I'll be showing you an example of that shortly. PG routing, or routing, depending on your pronunciation, is an extension feature focused on geospatial routing, or routing. Shortest paths between road networks, that sort of thing. You can repurpose it for general graph queries, but it's not built for that, and the API reflects that. I've included GEL at the bottom of the slide here, previously known as EdgeDB, which was confusing because people kept thinking it was a graph database in itself. This was acquired by Vercel last year, and it's kind of more of an ORM alternative to people who are familiar with that. And it's got graph concepts baked in on top of Postgres, but it's not really a database in itself. Apache Age on the right-hand side there is the real focus of today, so let's dive in on that. Age stands for A Graph Extension. Great name. It was originally developed in 2019 by a company called Bit9 Global, inspired by a fork of Postgres at the time, Postgres 10. It entered the Apache Incubator in 2020, and it became a top-level project in 2022, which is cool because it's the first graph database to do that with the Apache Software Foundation. It supports and works against Postgres 11 through 18. It uses OpenCipher for graph queries, and it's actually available on Azure database for Postgres, Horizon DB, and a few other providers. And in the real world, it's used against across government agencies, research institutions, and a range of commercial organizations. As for the technical side, the architectural pitch is pretty straightforward. Relational and graph querying in one box. Age leverages Postgres' query optimizer, its B-tree indexing for graph traversals, and the existing table hierarchy. So you get ACID transactions, MVCC, and all the Postgres infrastructure you already know. And Cypher is nice. People like the ergonomics of writing Cypher queries. At G.V, we made it so you don't even have to worry about the SQL wrapper there. You just write Cypher and you get results back. So it's fantastic if you're migrating from, say, Neo4j, which is mostly Cypher itself. So to make all this concrete, I put together a graph data model based on something developers know really well, a source code repository. I took a batch of recent commits to Postgres itself, the version control history, and I built this model of authors committing to files with a self-referential sort of relationship between files based on their includes and imports. So an author commits something against a file, and the file may import other files across the rest of the code base. And here's what a query against this structure looks like in that pure Postgres example, that pure SQL example that I mentioned earlier with the CTEs. This isn't the whole thing. I've cut it off on the slide. It's about 50 lines, and there's a fair amount of boilerplate and kind of brittle SQL to make Postgres do something it wasn't really designed for in a sense. You wouldn't want to maintain a function like this in practice. PG routing is similar. and it's simpler. You can see we're using the driving distance function, which tells you it's not really purpose-built for general graph queries. It kind of cares about things like cost of driving to a particular location, but it does work. And I say it's simpler. The lines of query language here are a lot shorter than before. So here I'm finding the collaborators for one individual within a certain number of hops. So if somebody's committed to Postgres, what files are they been collaborating on with a set of other individuals who are committing as well. And here's our final example of a bit of query here doing the same thing. So this is in Apache Age. This is our familiar select syntax with a subquery containing embedded cipher inside those double dollar signs. That section there is just open cipher, the graph pattern matching I showed you earlier, and it's wrapped inside the SQL that you already know. It's more expressive, it's more contained, and it directly reflects the structure of the question that you're asking. Now, one more thing before we move on. SQL PGQ is the standards-based approach that I mentioned earlier. It's actually just being committed to Postgres core, targeting version 19. It's not guaranteed to be in the next release, but it's definitely something to keep an eye on if you're interested in this space. In contrast, Apache Age is available now. It's mature, it's on all these cloud providers, and it's shipping pretty much anywhere that you're set to use Postgres. So now we have our data in graph format inside Postgres via Age. We can query it with Cypher embedded in SQL, and the responses come back as rows, node IDs, edge types, properties. So this view is just a simple table that I've taken out of G.B. It's informative, but I would say it's pretty uninspiring. And there is a time and a place for using tables. That's not a problem. But what happened to all those nodes and the relationships I was talking about? Let's talk about visualization. These are your sorts of de facto data visualizations. If I imagine like a cartoon character asleep dreaming of data viz, this is probably what they're thinking of, like bar charts, pie charts, maybe a scatter plot not shown here. And they're good at what they do, pointing out the frequency of events, the distribution of those events, categorical breakdowns like there on the pie chart on the right. But notice what they're doing. They're summarizing. They're deliberately throwing away the connections between data points because that's what makes the summary useful. If I show you a bar chart of how many files each author committed to in our Postgres example, you get a summary, but have to dig further to get the details. You can't trace that dependency chain from one file to another through shared contributors with a pie chart. Sankey diagrams like this one, like the one you saw right at the beginning of the presentation, they get closer to what we're looking to represent here in the visualization. There's a sense of flow, of proportion, of things being connected. On the far left there, you see a large proportion of those data points are flowing through to another large proportion, which then get distributed to an even larger portion on the right-hand side. At G.V, we include Sankeys as part of dashboarding, which is a bit unusual for a graph tool because most people favor the graphs I'll be showing you shortly. But there are real cases where this is the right representation. Typically, anything where flow through a system matters. But it's still fundamentally a flow view. It doesn't handle arbitrary connections, cycles, or the kind of tangle structure that a real graph has. And so here's where most people start. They get their graph data into a tool, they hit visualize, and everything lands on the screen. And this is the moment of awe. Look at all those connections. Look at how complex it is. If you look closely in the middle of the screen there, you can see there's a central node and there's lots of individual little nodes there around the edge. It's sort of like a swarm of bees around that node. In the visualization here, that actually represents the fact that those aren't connected anywhere else. They're just sort of child nodes off that middle node there, which is something that's interesting when you look at this visualization and not something that you get from a table. It is complex. This view is extremely complex. Complexity on screen isn't insight. Instead of answering questions, we're drawing pretty pictures. And yeah, I get it. It is pretty and it is enticing to do this sort of visualization. But what typically happens in production or when people are prototyping is they go, okay, that's interesting. And then they move on, because staring at this, sometimes they're affectionately known as hairballs. It doesn't tell you anything that you didn't already suspect, which is your data is complicated. And what's worse for me is that folks don't realize that these force-directed views can and should be tuned for maximum impact. To my eye, this global view of the data set isn't actually the best representation of these dense connections. It's overlapping, and you literally, or figuratively, sorry, you can't see the wood for the trees. So folks get distracted with looking at the wrong big picture instead of thinking of ways to subset and zoom into parts that warrant further inspection. So the idea behind these force-directed graphs, which I'll just dig into a little bit further so you have a knowledge of the theory behind them, is it's based in physics. It's kind of grounded in physics. So nodes themselves repel from each other, and you can see that's happening. So this earlier example here on the left-hand side show that there are nodes closer together. By the end of the layout run, they're further apart. And the edges, this is critical, the edges act as springs. So they don't get too far apart from each other before springing back. And there's lots of parameters you can use to affect how these layout engines work. But there's lots of great heuristics online for how exactly they should be working to get nice looking networks. So what happens is clusters of highly connected nodes pull together, whereas loosely connected regions drift apart. So you remember all those little example nodes, the child nodes in this view here, they're not going anywhere because they're actually only attached to that node right there in the middle of the screen. There's a lot of really rich research in this area. For large networks, Force Atlas 2 is the sort of state-of-the-art algorithm that's out there right now. It works with very large volumes of data, and I've seen it do great results on quite complex networks. But one takeaway for you today is that no single configuration of these will work for all different types of data. This is something that you have to tune, you have to understand a little bit about what it's doing in order to influence how it should represent the data for you. But going back to what's attractive about these is that people intuitively get what they're looking at. The spatial arrangement reflects the connectivity and role in the network. With our Postgres commits data, you can see 6 authors here from those queries I was running earlier, the files they're committing to, and the clustering around their shared contributions. This was invisible in that tabular output I showed you before. But a node's position only represents the connectivity. That's all the algorithm has to work with. It doesn't know about the direction, the hierarchy, the categories, the timestamps, any of those semantics in your data. It's surfacing a single dimension, who is connected to whom, and just how densely. Structured layouts are different. Instead of letting physics dictate where the nodes are going, you use attributes from the data to inform the arrangement. The file dependencies in our commits example have a direction, includes point somewhere. You know, this isn't a case of a bidirectional link where two files are referring to each other. You know, there is a direction there between the imports between those files. If you lay that out hierarchically, the parent-child relationships become legible in a way that the force-directed layout flattens or reorientates. And this matters most when flow through a system is important. Attack paths, dependency trees, any use cases where direction and sequence are part of the meaning. A force-directed layout highlights how things are connected, whereas a structured layout like this emphasizes dependencies of those connections, direction, layers, hierarchy. The most powerful use I see for these is when teams pick a specific attribute from their data, category, severities, timestamps, and they use that to dictate the spatial arrangement on the screen. There's a useful distinction in the data visualization world, and this is the wider world, not just graph visualization, and that's between exploratory and explanatory work. Exploration is the analyst's job, querying, poking, forming hypotheses. Explanation is audience-facing, communicating what you found to someone else. Most visualization falls cleanly into one camp or the other. Graph visualization is interesting because it sits right at the intersection of the two. When you're querying against your age data and looking for the result in a force-directed layout, that's exploration. You're trying to understand the structure. And most graph views, including G.V, allow you to double-click and expand and explore networks in a way that you can't really do with a pie chart or even a dashboard like the one I'm showing here. The moment you share that same view, the same expansion with a colleague and say, look at this cluster, it becomes explanation. And the teams I see getting real value from this, some of them have G.V open all day. They're moving between those two modes constantly. Explore, find something, share it, discuss it, go back and refine. And in this sense, the visualization, the graph visualization, isn't the end goal. Instead, it allows you to understand the data thoroughly and guides how you can communicate it to others. There's no right way to do graph visualization, but there are sorts of infinite ways to do it wrong. And most of them involve treating the picture as the destination, as if rendering the data is the same as understanding it. The best graph visualizations I've seen, anything that takes a complex topic and makes it legible for a general audience, they share one trait. The visualization itself is in service of a question. It's clarifying something. It's not depicting complexity for the sake of it. What I care about at G.V is the moment when someone sees their data in this interactive format after running a query, typically maybe against something like Apache Age, and it relies on their expertise, but it shows it in a way that they hadn't considered. The best reactions aren't, that's pretty. It's a pause and then, I didn't realize that connection was there. Or, wait, that data looks completely wrong. Or, did we really build the model like that? And that's where I see Apache Age with Postgres really shining. The ergonomics of querying against the connected data and the traditional data visualizations in one database is pretty appealing. So in summary, Apache Age is open source. It's a top-level Apache project, and it's available on all major cloud platforms, including Azure. It brings the popular Cypher graph query language to Postgres without adding yet another database to your stack. But those intuitive graph queries are only half the story. The traversals, patterns, and graph results need visualizations designed to emphasize connections. You've got force-directed layouts to surface structure you didn't know was there, and structured layouts to overlay meaning from your domain. Thanks so much.
Thank you so much for this talk. I once again learned that my brain doesn't work in graphs.
Yeah, awesome. Thank you, Christian, for the talk. Yeah, there was lots of interesting content there. I'm also curious to see how, SQL PGQ, like the new graph standard in PG19, will help something like Apache Age, right, to potentially do more inside the database itself.
Yeah, I never realized how much more difficult it is to build visualizations in graphs. Like, I know the complex pictures, but then indeed, your goal is not to show a complex picture. Your goal is to explain something in an easy way to the other person. So how do you simplify a graph? That's really hard.
Yeah, and I like the sort of the distinction between sort of the exploratory and explanatory graph visualization, which was interesting, right? Because so far you just think of graph as something like looking pretty, but then it has to actually convey information, right? So I think sort of using some of these techniques to make sure it's actually conveying the information you wanted to was very cool.
Yeah, it's also funny because we are in the background, we are working together on a document about the talks and how it's going, and we were both quoting the same quote at the same time. It was a really fun thing to see. And another surprise. Look at what we have. We have the survey today. You didn't realize it. We never showed you before today, but we show it so often because it matters a lot to us. So please share your feedback. I know, how do we say this in Dutch? We always say the best helmsmen are at the shore. Basically saying like everybody who's watching knows how to do it better. So this is your moment to share how to do it better and actually make life better. So please share your feedback.
Yes, and then thank you for everyone who has submitted feedback so far as well. Really appreciate it.
Definitely. Did you already have some feedback in?
I have not yet. That's a good point. I should do that as well. And I think looks like we went a little bit back in time from a slides perspective, but I think now we are back on track. Cool.
Yeah. Andrew is definitely the next talk.
Yes. Okay. Awesome. Cool. Andrew is a senior product manager at AMD, and this talk is about choosing the right Azure infrastructure to improve Postgres performance. This was also a very informative talk for me. Especially there's a bunch of alphabet soup which comes into the picture when they're talking about sort of instance types, and just that was very informative to help decode some of that as well.
Yeah, for me, so much was new in this talk. I'm one of the old dinosaurs working on my own hardware, so there's so much new in here for me. I don't even know where to start. So please, Andrew, take us away.
Hey everyone, my name is Andrew Ruffin, and I'm a product manager at AMD. This talk is about the Azure infrastructure choices you have and how that choice can improve your Postgres performance by over 60%, including the economics you care about day in and day out. This talk is best for database administrators or IT decision makers who are looking to optimize their cloud footprint when it comes to Postgres. So in my day-to-day, I focus on launching and growing new infrastructure and service options based on AMD technology with Microsoft Azure. So let's go ahead and figure out how to choose the right infrastructure on Azure to improve Postgres performance by over 60%. If you're not familiar with AMD, we're a major hardware and software provider across all areas of compute. And in the data center where Azure is a leader, We provide primarily EPYC CPUs, Instinct GPUs, Radeon Pro GPUs, and a range of networking and custom products that tie everything together in the back end. So you as a cloud user don't typically need to worry so much about the hardware. Azure does that for you, for the most part. But it's good to understand why the underlying infrastructure matters and where you do have a choice, where you or why you'd want to consider the AMD option to optimize your cloud costs and performance for Postgres. The Azure and AMD partnership goes back nearly 10 years now, and we launched EPYC in the cloud with our first generation product announced in 2017, powering what's called the LSV2 Storage Optimized Virtual Machine, or VM. Since then, we've executed year after year, now with nearly 60 different VM series, or over 60 VM series. And Azure has also launched AMD's first AI-focused accelerator, the MI300X, first in the cloud. So we're aiming for a similar trajectory there as what we've seen with EPYC. With VMs covering just about every area of compute you might need in the cloud, we need several talks to cover it all, but we'll focus on the areas that matter most to Postgres users. All the compute options we've launched are options for you on Azure, and they're also built into many of the products and services that you use day in and day out. If you're using Teams at work, it's likely AMD is powering some of your session. If you're a Microsoft Founder user, inference is likely being served by an underlying EPYC or Instinct architecture underneath. A lot of the agentic AI workloads these days are running on CPUs as well, so EPYC is definitely a part of that. The biggest AI analytics and database services are all using AMD today to handle your workloads, some giving you a choice and some taking care of all of it for you. The nearest and dearest, of course, to us in this talk is Azure DB for PostgreSQL, which gives you a choice in flexible server and provides AMD in the backend for upcoming products like Horizon DB. So when you do have the choice, how do you know if your compute or your VM is powered by AMD EPYC, or how do you even find it? Well, look for the lowercase a in the name. The vast majority of the VMs you'll see on this page have that A I'm highlighting here, from the BASV2 to the NVADSV710 V5. That's a mouthful. There are a few exceptions, like that LSV2 I talked about. That's actually going to be retiring soon. And the H series VMs, which have been AMD only since HBV2 was announced back in 2019. Azure has been very consistent in the naming structure outside of this one exception for many years now. So just basically look for that letter A and you're on the right track. Now I want to show you the alphabet soup that I live and breathe every day so you don't have to. I won't read through all this, but take a look at the number of VM families that you can choose from, and you'll see that it covers just about every workload you might need without having to procure and manage your own hardware and data centers. That's the beauty of the cloud and the beauty of Azure and the choices you can make. So what's interesting, though, is that the PaaS and the SaaS providers like Azure DB for Postgres and Horizon DB also are choosing from this menu of options. For Postgres, we'll focus on the most common VM types, which are going to be the general purpose DA families, the memory optimized EA families, and the compute optimized FA families. And we're going to focus primarily on the latest generation V7 that went live earlier in 2026. Before we dive into the details of those specific VMs, it's worth noting the sheer scale of what Azure offers in terms of regions and compute diversity. I regularly count the number of Azure regions available and where you can find AMD compute or not. And as of my last check, which is probably out of date by this point because everything's changing all the time, you'll find AMD options in each of the 65 Azure-controlled public regions. So Postgres users will definitely focus on the most widespread, general purpose, memory optimized, and compute optimized options. So if you have a favorite region and you don't see what you need, then definitely reach out to your Azure contacts or to myself on AMD. I'll give you my contact info later on. So let's get into the nitty gritty. As a brief intro, the general purpose DA family, this is the V7, is best for many workloads as its general purpose. And it comes with either 4 GB of memory per vCPU or virtual CPU, or 2 GB. Look for that little L in the name for lower memory. If your workload can handle lower memory, you're going to save 10-12% on average by moving to a lower memory SKU. These VMs scale all the way from 2 to 160 vCPUs, which I highlight because the prior generation topped out at 96. So a lot more scalability in this generation. These D-series VMs also come with them without local temp disk. You'll look for that little D in the name to see if there's a temp disk. If you don't need that temp disk, then you can save 3 to 5% on average by not choosing that SKU. Next are the memory optimized EA family, which increase the memory to 8 GB per vCPU. This comes with a 31% give or take cost increase. So if your workload doesn't need that much memory, stick with the DA family for sure. Speaking with the PostgreSQL product team at Azure, if you go to build or you go to Ignite, you'll be able to talk to them directly. And I have. The EA series are often most recommended because the extra memory gives you more room to scale, and PostgreSQL absolutely benefits from having more memory per vCPU. These VMs, like the DA series, also scale from 2 to 160 vCPUs. Last but not least are the compute-optimized FA family, which come with 2, 4, and 8 gigabytes of memory per vCPU. In this case, you get a full core as a vCPU versus a thread. So SMT, which is what AMD offers, simultaneous multi-threading, is turned off here. So you're going to see some of the highest performance in the FA series without having to go to specialized compute options like the H series, and those are way less available around the world. These compute-optimized families, VMs, they scale from 1 down from 2 in the prior gen, so give you a little bit more flexibility, up to 80, which is up from 64 in the previous generation. What's new as well is that they added temp disk on this generation. A lot of customers are asking for it, and so Azure listened and is offering that in the V7 version. These VMs do come with a price increase, about 50% over their corresponding DA or EA series VMs. So it's best to really use them for bursty workloads or where you pay per core for a software license. That's not really relevant to most people using Postgres, and you don't have to think about it too much. But if you do find yourself CPU bound in your testing, so going from an EA, you would look at the FAM series, for example. If you're on DA, you look at the FA, DAL, you look at FAL. So that's the guide for V7, and that's where I would really start to look first and foremost. So going into how we enable all of this hardware and infrastructure in Azure, we're really investing heavily in open source technologies to run optimally on AMD processors and on Azure services. AMD itself is a top 10 contributor to Linux kernel development with a focus on day zero enablement for all of our hardware, CPUs, GPUs, and everything in between. And we've served as a long-time, long-standing member of the Linux Foundation. So lots of projects and contributions there. How does that benefit Postgres itself in practice? Well, the improvements built into the Linux kernel, especially around I/O movements and improvements, they flow through to Postgres. So Phoronix did some really interesting testing of various database workloads using a 5th gen Epic server, which is the same family as what you're going to find on those V7 VMs we talked about before. And they found that moving to that kernel v7.0 from this v6.19, the previous stable version at the time, improved throughput per second or TPS by around 20% and reduced latency by nearly 17%. That's for a mixed read and write scenario. And that's pretty common when you're using Postgres in a multi-user environment on the cloud. So I really liked the benchmarking they did there. If you recall the title of this talk, which is how choosing the right Azure infrastructure can improve Postgres performance by over 60%, this combination of software and hardware improvements over time is exactly how it's done. So typically when I talk to customers, they're maybe, they're stuck, or not necessarily stuck. They just, hey, it's working. I'm on an older Postgres version. I'm on an older kernel version, older hardware. I don't need to change it up. It's just working. So that's really common. It's really tough to justify moving away from something that just works. But let's talk about why it's almost certainly worth it from an economics perspective. So AMD benchmarks each new generation of infrastructure released on Azure, measuring throughput via transactions per minute or TPM, like you saw before in the Phoronix testing. The benchmarking we do might not fit exactly what you do, so obviously go test for yourself, but here's what we do basically, or here's how we compare things. So we go back a couple of generations to a 5-year-old VM on Azure, which is an AMD-powered, memory-optimized E16 ASV5. And that one comes with 16 cores, which we've been told, hey, a lot of customers are using 16 or 8, maybe 32 cores, but often the smaller sizes. One modernization path you might consider is upgrading while maintaining the cores of the vCPUs. So you move up one generation to an E16 ASV6, and this gives you a nice throughput per dollar benefit, even at a slight increase in compute costs, moving from V5 to V6. You'll see that the throughput per dollar uplift goes up 20%, the raw performance is up 26%, so that means there's a little bit 5 to 6% cost increase, but it's more than made up for by the performance. We also measure what's called a cloud OpEx, so operational expense savings, which is basically a calculation for if you're going to do the same exact work, given the performance and the cost, how much less or more would you pay? In this case, to do the same work as what you did on V5, you're going to save about 16% in operation expense. So we talked about V7 earlier. What if you can get your hands on V7, in this case, an E16 AS V7? This is where the title of the talk comes from. So you're going to get over 60% improvement with this play. As you can see, even with the slightly higher cost of V7 over V5 again, that 63% performance improvement translates into 54% throughput per dollar advantage. So ultimately, for the same amount of work, you're going to save 35% in compute costs. So if you can get the V7, absolutely go there. It's definitely the best bang for your buck. Another option you might want to consider is reducing the number of cores driving your database. Even reducing by 50% from 16 to 8 cores, you're going to save quite a bit just because of the sheer reduction in compute costs by 50% typically. So in this case, you can go to an E8AS V7. You're going to lose a little bit of throughput performance, so 9%, but you're going to gain significantly, over 170% in throughput per dollar. If you can handle that slight drop in performance, you can still save 63% in operational expense costs to achieve the same amount of throughput as before. So whether you're in your own data center, looking at 5-year-old or older servers, on another cloud, looking at older instances there, or already on Azure, modernizing to the latest AMD infrastructure is going to mean that you're going to get the same great PostgreSQL experience you're used to while improving the performance and the economics. Simply put, the modern AMD on Azure infrastructure is going to deliver more work per core for Postgres. So absolutely take a look and see if it's worth it for you. I've been speaking primarily here about deploying Postgres on Azure in a self-hosted way. So we're picking the VMs and the specific one that you want. In this self-hosted infrastructure as a service model, you can tune everything from the postgres.conf file to the actual database version, the OS specs, how you compile things, and more. The AMD teams that are working on benchmarking are typically testing in IS, and so they're tuning to get the most performance possible in each generation based on the compute chosen. So we do that often for customers, and we try to make sure we get the best out of every new generation. As an example, we see customers, and what we do with our benchmarking, we typically set shared buffer parameter to 70 to 75% of memory. So you can see just how much choice you have. I already talked about 60 plus compute options across Azure's, as of last check, 65 public regions. The newest V7 VMs we discussed are in 12 regions and growing. And this might be way out of date by the time you watch this, but it's constantly changing. But 12 regions, so not nearly as much as what we have in V6, which is nearly everywhere in 58 regions last I checked. And the V6 confidential options, which I'll talk about in a minute, are in 17 regions. So there's lots and lots of choice, which maybe you don't want to deal with. That's totally fair. In that case, you can, of course, choose to deploy Azure DB for PostgreSQL, the platform as a service option. You can still tune parameters available in the Azure interface, but you won't have access to every option in the config files. That helps you reduce operational overhead, but of course, there's some trade-off in that the service has fewer compute options, fewer choices. That's to be expected, though, and new options are continuously rolling out, so this may change, of course, throughout the year. In this platform as a service offering, you can choose from 3 different tiers: general purpose, memory optimized, and burstable. And AMD is available in the first 2, general purpose and memory optimized, with V5 in 15 regions, V6 in 5 regions, and confidential compute in 3 regions today. No V7 just yet, or confidential compute V6. So if you want that option, then IS is the way to go, but the choice is up to you, of course. So speaking of confidential compute, Azure Database for PostgreSQL was one of, if not the first, managed database service to offer this capability. AMD's built-in hardware security features, including secure encrypted virtualization, or SEV as we call it, you're likely used to encrypting data at rest and in transit, but in use is relatively new, which is what confidential computing is all about. And Azure has been a real pioneer in this space. SEV protects data in use, which reduces your attack surface and protects you even from people walking the data center where your compute lives. A lot of companies have that kind of threat model where they have to be, not overly protected, but they have to really think about how they can protect the data no matter where it is, whether it's in their own data center or in someone else's. With this, no application changes are required. You simply pick a confidential VM SKU like DCA or ECA. See that big C? It means confidential, basically. They're the same exact specs as the DAEA that we talked about before, but with confidential compute feature turned on. There's no cost increase either for this choice, and we'll get into the performance impact a bit. Depending on your industry, enabling confidential compute may be the best way to deploy in the cloud because you need to have that extra trust to make that transition. We see quite a bit of interest from government, finance, and healthcare companies. We see confidential VMs rolling out in government regions for Azure and the sovereignty play. And Microsoft themselves have been very public about deploying a large amount of confidential VMs for their Secure Futures initiative, for Windows licensing operations, etc. So a lot of uptake there. While costs and application changes are not required to adopt the confidential VMs, there is a small performance impact to consider. Veronix, as usual, did some really great testing of the V6 confidential VMs, which you can use in IaaS today, and found 3 to 6% overhead on average. Database workloads are impacted a bit more than others given the significant data movement involved, but that performance hit will still put you well ahead of the performance of prior generations of non-confidential options. What's most interesting I think to me is that there's no tuning required. So you just select a confidential VM and you'll have that small performance impact, but it will just work. No tuning required. AMD is working hard generation over generation to reduce the gap here, and you should see more and more progress in this area soon, and hopefully some more options available on Azure. Veronix also did check performance against 2 Ubuntu versions and found no significant changes. So again, a lot of work is happening in the background on open source enabling to at least stabilize or improve performance of hardware features gen over gen. Speaking of enabling, PostgreSQL has really led the way in creating AI-ready features that you can do more with your favorite database. It really is kind of becoming a one-stop shop for all sorts of data management, not just standard, but going into the AI space. So 3 areas come to mind here: PG Vector, Disk ANN, and AVX512 enabling, which all benefit from the combination of software and hardware enabling that's now here with the 5th gen Epic infrastructure on Azure. PG Vector itself has been around for a long time, I think over 5 years at this point, and it brings native vector similarity search to Postgres. Microsoft Research actually has done a ton of work in developing and releasing Disk ANN, or Disk Approximate Nearest Neighbor, which enables vector indexing on fast storage to scale beyond memory. So maybe you're in a D series and you want to enable vector processing, you can get the local temp disk or fast remote storage and enable Disk ANN in PostgreSQL, the PAS or the IaaS version. The blog post that announced the GA in PostgreSQL for Disk ANN claimed up to 10x faster speed, 4x lower costs, and up to 96x lower memory footprint than the industry standard PG Vector HNSW. This is a really huge deal when memory costs are skyrocketing and fast NVMe SSDs are a lower cost and now pretty much ubiquitous across Azure and data centers generally. And hopefully you're using one in your local PC or work laptop. V6 and V7 VMs come standard with NVMe remote storage, and you can also deploy local NVMe temp disks like we talked about. There's also some storage optimized VMs, the L series, that would be a really great fit for Disk ANN if you're doing massive amounts of vector processing. You can use this again on PaaS or deploy as an extension in IaaS. I think it's a bit more easy on the platform as a service, Azure DB for Postgres, but it is possible to roll your own as well. Enter AVX512 or advanced vector extensions with 512-bit data path. This is what's known as SIMD, or single instruction multiple data. A single CPU instruction can process, in this case, 16 32-bit floating point numbers simultaneously, or 512-bit in total. PostgreSQL first supported this in Postgres 17, and then there were significant enhancements made in Postgres 18, which enabled 3x faster checksums. And this helps improve write-ahead log integrity checks and database backup speeds, for example. So a lot of great work has been put into this. PG Vector itself can use AVX512 for various similarity search algorithms, directly accelerating those operations. What's great about PostgreSQL 18 is that in the runtime, if your hardware supports AVX512, the software checks and should take advantage if available. The V7 VMs on Azure have this capability, as do the V6, albeit they use a slightly less efficient, what's called double pumped 256-bit implementation. You still get the 512, but not as fast as the V7. Once again, Veronix did some really great testing of the 5th gen Epic with and without AVX512 enabled across a wide range of workloads. They found on average 45% improvement over the non-AVX enabled 5th gen and 12% more throughput over that 256-bit implementation I mentioned on the prior gen 4th gen Epic. What's even better is that these modern implementations, you get this extra performance without a significant increase in power usage, or maybe even a negligible increase if you look at the Veronix data there. So you don't have to worry too much about power in the cloud necessarily. It comes across in your bill ultimately. That's why you'll notice a lot of the AMD options are typically lower costs than the non-AMD options. But if you care about your performance per dollar per watt, the Azure AMD V7 VMs will improve all those vector operations, CRC checks, and JSON parses you're doing day in and day out. So you've covered a lot of ground in a short amount of time. There are going to be so many great talks at Posette this year, and I know you'll learn a lot outside of this talk. I covered a lot, so if you want to dig any deeper, I've got lots of resources here for you with these QR codes. Take a look at the detailed tuning database guide we've published. Some of my really expert colleagues have put that out. They're part of the ecosystem enabling team here at AMD, so we're constantly putting out guides for your favorite workloads. We also co-wrote a migration guide to Azure Postgres, whether IaaS or PaaS, with all the nitty-gritty on how to move to the great Azure options we heard about today. You can also look at a general AMD tuning guide for just Azure VMs overall. It's not necessarily Postgres focused, but just shows you all the options and how to get the most out of your IaaS choices. If you're more interested in confidential computing topics, and believe me, it's a fascinating area, I think will become more and more needed and I hope more and more providers use, especially since I, as a privacy nerd, would benefit. Absolutely. Take a look at that ebook in the center about confidential computing. My colleague Noor, who works in optimizing workloads for customers day in and day out, and that's a lot of what AMD teams do, she wrote a really nice guide on how to make sure you're using AVX 512 or it's enabled in your workloads. So absolutely check out her blog post. She did some really detailed work there. I think you'd enjoy. And for more info on all the Azure and AMD products and services, including customer stories and trial offers, you can check out that newly updated partnership page on the bottom right there. Last but not least, you can always reach out directly. Find me on LinkedIn, I'm on Discord, and you can reach out to the Azure team at AMD, which I'm a part of, azure@amd.com. We'll be able to respond to you via that email address. So that's it for me. Thanks for joining Posette 2026 and for taking the time to watch this talk. Enjoy the rest of the show.
All right, Andrew. Thank you so much for sharing this. This was a lot of information for someone not used to the cloud models. So let me try if I understood this correctly. Please correct me if I'm wrong. I think it's important to know what workload I'm running and whether I need more compute or memory. And it's really important I picked the right hardware underneath my Postgres system. Is that more or less correct?
Yeah. I mean, the kind of hardware types available in the cloud these days are quite significant, quite varied. So it's helpful to have talks like this to help you navigate those as well, right? I mean, the other interesting thing was, like, even if your application just stays the same, but as you keep progressing through, new versions of CPUs and new Postgres versions, performance gets better, right? So it's interesting to think about that as well.
Yeah. So basically, if I created a database 5 years ago, I really should check new hardware specs so I can move my Postgres database to a new machine.
Yeah, exactly. I mean, which is interesting. And I think the interesting thing is also sort of the price performance ratio. So there's just a pure performance play, but the example where you gave, if your application can accommodate like a 9% say performance loss, you actually gain significantly in the price performance standpoint as well, which was cool. Yeah,
that's another flaw in my thinking. I only think about performance.
Cool. I think we've talked about surveys. We'll come back to this, but I think this is a good time to take a sneak peek at the Livestream 4 trailer, which is the last live stream as well.
Hi, my name is Derk van Veen. Today I will be talking about Postgres partitioning. This is my Postgres partitioning cookbook based on the past 4 years I've been building this experience with Postgres partitioning. If you are working with Postgres and you need to start with partitioning, this is a really good starting point.
Hello, I'm Ashutosh Bapat. SQL PGQ is the latest addition to SQL Standard. It allows relational data to be treated as if it is a graph. We have committed basic support for this standard in PostgreSQL 19. In this talk, you will get familiar with salient features of SQL PGQ standard and what has been committed recently.
Hi everyone, I'm Rahila Sayed. I'm here to talk to you about a topic titled Journey of Developing a Performance Optimization Feature in Postgres. It is an exploration of how one can develop a feature which will improve performance of physical replication. This talk will be useful for developers who would like to contribute to Postgres or anyone who would like to learn more about physical replication.
Hi everyone, I'm Nitin Jadhav. I'm a senior software engineer at Microsoft and I work for the Azure database for PostgreSQL team. The talk you're going to watch is about PG DuckDB in action, accelerating analytics on Azure database for PostgreSQL. If you have ever wished your Postgres database could just answer an analytical query faster without you first exporting data somewhere else, then this talk is for you. By the end of this talk, you'll know exactly how PG DuckDB makes that possible, and you'll see it running live on Azure database for PostgreSQL Flexible Server.
Hi, I'm Chun-Ling from .NET Foundation. Have you ever deployed your Postgres database and other cloud services to the public cloud service? So sometimes you may have this question. Can I actually performance testing our infrastructure before we actually deploy it on the cloud? Well, today in my talk, I'm going to show you how we can use discrete event simulation to do the shift left performance testing on our infrastructure before we even deploy it on the cloud.
Hi everyone, my name is Hari Kiran. Today we are going to track the full arc of logical decoding and replication. We'll go from its earliest building blocks in PostgreSQL 9.4 all the way to the multi-master distributed future that's being actively built right now.
Hi everyone, my name is Sakshi Nasha and I'm a software engineer at Cohesity. Today we're going to talk all about security in Postgres. Is your Postgres really secure or is it just working? Are you thinking of security as a design habit or just thinking it as an afterthought after you launch your product? So if you have security in mind and Postgres, this talk is for you.
Welcome everyone, my name is Shashikant. Today I'm going to talk about what I think is the most exciting area of improvement in PostgreSQL 18, vacuuming. If you ever dealt with the PostgreSQL database in production, whether that's on Azure, on-premise, or anywhere else, the changes which we're going to cover today directly affects how your database handles bloat, freezing, and overall maintenance.
Hi, I'm Mohammad Osama, and I'm going to talk about Citus cluster scaling. The recent version of Citus landed 2 new enhancements in this area, and I'm going to talk about both of these, how you can leverage those and what they are all about.
Hi there, my name is Jimmy Angelakos, and my talk is titled Listen Carefully, How Notify Can Trip Up Your Database. And it is a real world story. It's a thing that happened in production once upon a time, and it's a real pitfall and situation that can be caused when using this mechanism in Postgres. So I think it's really useful to talk about it and show you what it can cause and also how it can be fixed.
Hello everyone, my name is Hamid Akhtar and today I'm going to talk about where does my insert go, a logical replication story. In this talk, we're going to start with an insert from the publisher to the subscriber database. So if you're planning on understanding the workflow of how logical replication works, this talk is for you. It will give you all the details about the wall, the logical replication, the decoding, and take you from the publisher to the subscriber.
And that will be the
Nice.
4th day of Posette this year. A lot
Yeah.
of good stuff.
Good to see your talk, Derk, on PG partitioning. I'm looking forward to that. I had a question. Do you have a favorite, or do you have like a must-have feature ask or feature request on Postgres partitioning?
Yeah, I've been asking for global indexes for I've been around on Postgres environment, I think. I know it's difficult, and I know it's not the easiest thing to build. But yeah, if you could get it, some things will be so much easier. There will be less trade-offs when it comes to partitioning. So if you can build me a global index, I'm your biggest fan.
Actually, yeah, I mean, I think so. Dilip Kumar from Google is working on this, and I think he talked a little bit about this at PGConf Dev as well, which was an interesting, interesting talk. So I'm hoping it will land soon as well in Postgres, but it's not there yet.
Yeah, but yeah, it will be really nice to have it.
Yeah, I mean, the other one which was interesting was I think it was Chung Ling. I think he was talking about sort of the shift left on performance testing, right? Which is, it's always a challenge, right? You develop something, you test it on dev, but it's not exactly the same hardware, not the same data, and when you actually go to production, like things are not quite the same. So I'm curious how how that talk goes as well.
Yeah, especially when something's really critical, right? It's really time sensitive, or the load will be really high. You want to have a good test.
Yeah, exactly. Cool. All right. Then let's dive into the next one. So Paula Berenguel is a principal program manager at Microsoft, and she's going to be talking about what she's learned teaching Postgres to 200 plus field engineers at Microsoft.
So now I am curious. Did you learn from her as well?
Actually, I don't think I have. I know that the engineering teams do collaborate in terms of developing some of this content and things like that, but I have not, unfortunately, been in one of her sessions.
All right. There are a lot of good lessons here. So also, if you are thinking about trainings or you're participating in trainings, there are a lot of good things to learn, even if it's not about Postgres, but already about the process of thinking about trainings was enlightening for me. So yeah, let's look at it together. This is Paula.
Hi, I'm Paula Berenguel. Have you ever tried to build field expertise across a large organization? I have been doing this for over 2 years, and I will share in this talk what worked well, what didn't work really well, and what are the pitfalls. Let me take you to day one of what I've learned teaching Postgres to 200 field engineers at Microsoft. This is what a real day looked like for a field engineer. So at 8 a.m., a Postgres HA question. At 9:30 a.m., a slow query emergency. At 11 a.m., can we migrate? He get asked by a customer or somebody else. Can we migrate from Oracle by Friday? At 2 p.m., a team's suspicious message. Help. And somehow, I'm always one of the first people that get a panic direct message. So 200 plus engineers and field teams. 0 off-the-shelf playbooks. What could go wrong? So this is what a typical good day looks like. So the human side of teaching Postgres. So people, lots of questions, lots of community, and also lots of typical things that they were not so straightforward to solve. So I will start with challenge 1. One size fits nobody. So look at this slide. We have on the left-hand side, Alex. He's the typical startup solution engineer. And on the right-hand side, you have Jordan, an enterprise cloud solution architect. So Alex is really worried about things like, will this product scale to 1 million users tomorrow? So Alex is concerned about speed, scale, fast way to ship features. Jordan is an enterprise architect for a large organization. He's asking himself, hey, can we just simply fill out this 400 pages questionnaire about security? So Jordan cares about compliance, governance, control, among many other things. The point I'm trying to make is that those things, they don't overlap. And this was my first big mistake. I tried to come up with the Postgres training, the Postgres modules where you could actually feed yourself from and solve each and every customer problem. But boy, was I wrong. So because I realized Alex and Jordan, they are really not the same species. So you should not feed them with the same meal. So my fix was to stop cooking tasting menus and start running a buffet. So this means modular content. So we have HA modules, migration modules, PG vector modules, security, performance, among many other modules. So the idea was to have the same ingredients. Everyone builds from I mean to correct that. Everyone builds their own bowl. You got the idea here. The other thing that was very beneficial for this upskilling effort is to map personas to top scenarios. And I'll tell you how I did this. So after probably 1 year, I actually started surveying my engineers to try and understand what are the top 5 scenarios that you come across every single day, regardless of Postgres. But obviously, my focus is on Postgres. So Alex, our nice and kind solution engineer, is aligned to the startup segment. So he actually is doing pre-sales, which is completely different from a person doing post-sales. So the top scenarios for Alex probably are migrations. So how do I migrate from on-premises Postgres to, flexible servers? High availability and failover configuration. How can I scale this thing should my startup really be successful in the future? Cost optimization conversations, obviously central to the startup needs. There is a lot of cost constraints that goes on. So for Alex, I mapped migration, high availability, scalability modules as priority for him because he's a pre-sales solution engineer. Performance and replication, not so much, because they normally come as a most post-sales typical scenario. So this actually helps me align what is the most important thing for my field teams. So they need to be able to hold a conversation across those topics. And also scenario bingo. That's the other thing that we do internally. So the scenario bingo is also an outcome of a survey. So as we go, this is across all the field roles that I actually touch. So across all the roles, I send them surveys and they mark the real scenarios that they actually come across in the wild. So every single day or every single week, what are the most hot topics that are actually coming to my plate? By all means, nobody will be expected to have each and every scenario ticked off from this bingo card. However, this helps me to understand what is actually my training looking like for the next week and what is actually the concerns across all the roles that I can actually jointly combine sessions for a solution engineer, a cloud solution architect, and a global black belt. Or even a consultancy architect from Microsoft Consultancy. Then comes challenge number 2. The jack of all trades fatigue is what I call. So for challenge number 2, I wanted to call out that the typical field teams at Microsoft, they are not a Postgres DBA. They are actually data and AI professionals. They are security people, they are infrastructure and apps people. So Postgres is just one of the things they are doing on their day. So basically, which means on Monday, they are doing Postgres, and on Wednesday, someone asks them about something completely different, which is kind of causes that panic DM that I showed at the beginning of the slides. So I sit tight and I watched. I'm one of those people that I'm actually, I can pleasantly say that I worked with Postgres since the beginning of the century. So, but I observed a few things. So there is always a new thing in the tech industry. So in 2021, with the pandemic, here on the left-hand side, you will find that everybody was talking about going digital. So lift and shift. So everybody wanted to pursue and come to the cloud very quick to sustain their businesses. 2022, everything was analytics. There was a boom on analytics. Few startups came out to place, and then everything, the focus shifted to analytics. 2023, everything is AI. With the launch of ChatGPT for the first time in November 2022, AI became bread and butter for most of the organizations. And 2026 plus, guess what? Postgres is still here. It's going on for 30 years. This year is actually completing his 30th anniversary. So what I wanted to say is Postgres is the database that never changes phone number. So it means it is something that you should sell to your field teams as something to show them it is worth learning, because Postgres is here to stay. So I had to reframe that story a little bit because, you need to acknowledge that not everybody is either or want to be a Postgres DBA. So the reframe is, you know what your customer have. For example, on the left-hand side, you can find self-hosted Postgres. So you know this, your customer knows this. On the right-hand side here, you can find zero downtime. So your customer wants to migrate from self-hosted Postgres to the Azure cloud and want a zero downtime experience. This is what you want and what your customer wants. Then in between, you have Azure, the migration service, and Azure database for Postgres. These are the gaps. So guess what? These are the modules I was talking to you about. So this is actually what I teach. So the customer already made that hard decision of giving Postgres on Azure or in a cloud vendor a try. So now you just need to make the path clear. You need to be able to teach them how to migrate. That's all. So we reframe that ability I want to correct that. So you can reframe the message about being a super Postgres expert or jack of all trades of Postgres as well on all the topics. And you can just learn as you need as a particular topic. Another thing that actually really works here is give them one story. Most of the customers I talk to and the field engineers and architects that I talk to, they care about the slides, the recording, and the learning session that we covered, but they actually care even more about a story. A good told story is actually beats every time slides. So look at this. Enterprise customer migrated 2 terabytes from Postgres on premises, zero downtime. PG Bouncer was able to absorb the connection spikes. So this is a real scenario that actually went live. At Microsoft, this actually comes in lots of shapes and forms. So it's not only the art of storytelling, it's also being able to articulate a customer reference call, being able to articulate a customer evidence, a case study, as we call. So your next customers, they will be more confident, that this was actually done by other customers at the same industry, and therefore I can do this. So this is actually a very empowering message to leave to your field engineers and architects. So just so we are on the same page on what I actually teach, I teach Azure Database for Postgres Flexible Server. This is our community-compatible, enterprise-grade Postgres on Azure. 4 nines availability. There is a very rich ecosystem of extensions. You can find Citus extension, which is unique to Azure, PostGIS, PG Audit, you name it. Security with Microsoft Entra ID, customer managed keys encryption, Defender for cloud. On the performance pillar, we have our intelligent tuning, read replicas, PG Bouncer. Migration-wise, we have our own migration service, as I hinted before. We also teach other ways of doing this, so by using PG Copy DB. Even the VS Code Postgres extension. And also the offering provides a very observable platform with metrics, logs, query performance insights. So this is what our engineers actually talk about with their customers every single day. Now, that leads me to challenge number 3. After modularized my content and I mapped useful content to actual roles, how do I actually know that my training is being effective, right? So because Postgres unfortunately doesn't have a certification yet. So the Postgres Certified Professional badge does not exist. Which leads me with something to think. How do I actually measure that my field teams, they're learning something from me? They're actually more confident. They are able to do things to actually execute on the day-to-day job. So I actually tried to copy, and I copied a little bit of the Postgres community by itself. Why not? So instead of thinking about certification, we think about contributions. So every time you answer a thread, you unblock a deal, you write a blog post, you give a tech talk, not only to your customers, but to your colleagues' customers, you're helping somebody inside your organization, score. So we call this contributors wall, and this gets sent every month, and people are very proud to be obviously featuring there. It's almost like Postgres employees of the month. So that's one way that we can track their contributions, and we made sure that they are known by the great work that they are doing for the Postgres community internally, and also they'll be able to articulate that manager conversation at the end of the year, should they need to have a conversation about, what is this upskilling program actually contributing to your career. So, and another metric that we use is the win wires, of course. So every win wire, so every time there is a win, so a deal is unblocked or we fixed a very hard problem at a customer, we celebrate. So we actually map as well, what was the situation? What Postgres knowledge was applied here? And what was the outcome? So this is something that actually is enables people to say, this was my scenario and I did it. So this is I'm proud of myself type of moment, which also goes to the contributors wall. Then from time to time, I have to find gaps because trainings, they are movable in the sense that there is foundational training, but Postgres evolve. Every year we have a new version of Postgres, and Microsoft with that also release new features. So I need to constantly be looking at aligning the field gaps, so the field needs, with the new features at Microsoft for our Postgres offering, and also to the Postgres evolving platform by itself that we all need to learn in order to better serve our customers. So I like to say that I started doing explain analyze on our engineers, and not literally, of course, but this metaphor works really well. So where are the sequential scans? Where should knowledge be indexed, but it isn't? So what I mean by that, if you're not a database nerdy, is that I need to constantly survey my engineers, and I need to ask them, what are the things that is actually happening quite a lot and you haven't really been enabled to deliver on that? And what are the things that perhaps I never touched upon and is super necessary? Because, digital platforms and cloud by itself just moves. So we always need to learn more about security, learn more about things. So I need to constantly be looking for new to build my learning and upskilling roadmap, as well as updating previous content that they may be outdated. Even the foundational Postgres content needs a little love from time to time. Then challenge number 4. This is the one that surprised me the most. Keeping the community alive. People join an upskilling program not only because they want to learn something from you or they want access to some particular information or networking. They actually come because they want a community, a safe place to actually ask the questions. Look at this. Azure Data Cat PostgreSQL channel. Alex asks a question. Hi team, has anyone configured a logical replication with Azure database for Postgres? I'm running into a weird issue. And then crickets. An unanswered question is a community killer. So you cannot imagine the power of having people to rely on. So the solution to not letting people without answers, because otherwise they feel vulnerable and they're never going to ask that question or expose themselves again, was to try and map some influencers. But honestly, we internally call them SMEs, so subject matter experts. So we have the migration person, the HA person, the performance person, the replication person. They are your buddies. So we aim to respond each and every question on, between 24 and 48 hours. Even a let me dig in is enough to keep the thread alive. So the effort here is not to let the question go unanswered. On community infrastructure, still. So 3 things that is actually really helping me keep this alive is constantly building FAQs. Every time we have a learning session, every time we have new feature, we have something, we write limitations, we write about use cases and everything that will go with that particular need. And that becomes accidentally good new onboarding material. And it could actually, at times, leave into the public docs. So, and again, score again. So weekly training. So every week we have 60-minute trainings. They are recorded, they are summarized, they are derived, there is FAQ derived from them. So there is always a predefined agenda. You join, you anticipate if you need to be there, if you want to be there. So it's a safe space to talk and ask questions. And ask for help. And the Q&A channel. Program managers and the field teams, we answer the questions within 48 to, we aim, obviously, it's not perfect because, there is weekends, but 48 to 40, let me correct it. 24 to 48 hours is low barrier. Anybody can ask a question. Anybody can answer a question. And we harvest the question and answers as a knowledge base. With AI today, there is no limit on, chatbots and things that could actually help you answer questions for the entire field. We have over 10,000 people in this channel today. So to summarize, if I were to write a note to Paula 2 years ago, I would say your job about what do I need to tell you about your job? I would tell myself, I thought I had to build a training program, but I actually realized that I had to build more confidence. I had to build confidence at scale. I had to let people know where to find the resources, where to find a quick way to have a crash course on a particular module. I have to help them to hold a conversation, enable them in the way that they can find the resources they need so they can hold that particular topic or that particular conversation really well. I observed that not always the best technical engineer was actually the most successful employee. And so 3 things here to call out is, you're not teaching Postgres. You are actually teaching confidence. The second thing is the community is the curriculum. Having a community that you can rely on, that you can ask questions in a safe space to actually, learn and make sure that you understand a concept deeply is gold. And number 3, measure interactions, not completions. If you completed a course or if you have a certification on something, in my case, I could not really have a certification because Postgres has none, like I said, but the completions, the participation, the efforts that people has been, like the questions answered are the things that are actually worth measuring. And to summarize, Postgres survived 30 years without a marketing department. And it survives because people keep teaching them in conferences, in documentations, in Slack channels, Teams channels, even in virtual conferences like this. So don't ever underestimate the power of Postgres and the community. So that's effectively what you are doing. Thank you very much.
This was so nice to watch.
Yes, it was. Thank you, Paula, for the amazing presentation. Yeah, what do you think, Derk?
I have to watch this one twice again. One for the content and one for the quotes. There were so many good quotes in here as well. I wrote a few down already.
I was gonna say the same thing. Yeah, I mean, there's so many quotable quotes on this one to call out. But yeah, go for it.
Yeah, a good story beats a 30-deck slide deck for sure. I mean, humans are storytellers, right? We're not learning from bullet points.
Yeah, no, I really liked the an unanswered question is a community killer. That really stood out for me, right? And even not teaching Postgres, teaching confidence, which was also quite interesting and sort of insightful.
Yeah, I was also thinking every manager, no matter the tech stack, should watch this talk, right?
Yeah, yeah.
And proven there.
Yeah. And actually, it was also interesting to see the kind of different personas that are involved in the Postgres ecosystem, right? And the challenges of training all of them up as well, which is cool. Yeah, very cool talk.
In that respect, I have an easier life. I mean, we have one big set of developers, but at least they're working all on the same stack with more or less the same interest.
Awesome. Cool. Again, thank you for everyone who's submitted feedback so far. And if you have not, please take a look.
Yes, really submit your feedback. We need to be the stream with most feedback. I know Claire's always trying to win this, but I only realized this now, but this is really important. You want to be the stream with the most feedback, so please submit your feedback now you're still in the stream, or at least do it as soon as you stop watching a talk.
And I think this is the last talk of the day for the live stream, and it's a good one. So Taiob Ali is a Microsoft Data Platform MVP, and he's going to sort of compare and contrast PostgreSQL and SQL Server security model. So I think it's interesting, one, like for someone coming from a SQL Server background to understand this, but also for us Postgres folks to understand what might be some of the gaps for us as well.
Yeah, and it gives different insights. I also came from a different world, and I remember first time studying the Postgres security model, and it was like all new, and then you think about it, and now it's like it's all there. You put in the work, and now you don't even think about it anymore. But it's so important to have your security at really high standards. So yeah, this understanding is fundamental.
Yeah. Okay. Makes sense. Sounds good. Let's dive in.
Hi, my name is Taiob. I'll be talking about SQL Server and Postgres security model differences. This talk is for someone like me who is an accidental Postgres DBA coming from SQL Server world, and we will be comparing and contrasting the security model differences between the two database platforms. Okay, let's get started with Postgres and SQL Server security model differences. I'm not going to read my bio here in the interest of time, but I definitely want you to take a note of my contact on the left side, on the bottom left. So you can reach out to me after this talk if you have any question, concerns, and you're guaranteed to get an answer. Before I get started into the technical stuff, as I mentioned at the beginning that this is for accidental Postgres DBAs. And so here I have slide because of compare and contrast slide of SQL Server and Postgres. I'll most likely be spending less time on the SQL Server slides compared to the Postgres slides, but I have those for references so we can talk about those. And if you're watching this live stream, I'll be in the Discord now. I'm there, and I'll also be waiting there after the talk, so you can ask me questions. And if you have any kind of discussions, feedback, I'll be willing to entertain there. So let's make sure you're on the same page, because some of you, as I said, probably an accidental Postgres DB. Some of you are not using it. You are just probably looking at it because Postgres is one of the fastest growing databases now in the world in relational database. What is authentication? So it doesn't matter if it's in Postgres or SQL Server. Authentication is, who am I, right? I'm saying I'm Taiob. Am I really Taiob, right? How do the people check it? I have an ID, I have a passport. So in this case, we check with login, passwords, managed identity, passkey. And it's interesting, I was listening to a webinar of Microsoft, and they said, very soon, you all heard about agents, bots, and all that. They will have their own identity in Microsoft Entra, and we'll be asked to manage permissions for those within our database systems. So that's called authentication. So what's the authorization? So I have authentication to come to your house, or maybe go to a hotel. Like I can get into the front door. Can I go to every room of that hotel? Probably no, right? Because I only booked 1 or 2 rooms. I can only go to those rooms with my key. So that's called authorization. Like I can come to the database, I can come to the server or cluster in terms of Postgres, but what can I do inside? What databases can I get into? And then within those databases, what can I do? That's defined by authorization. Now, login in SQL Server, we all know I just talked about what's a login. Now, I understand with the Azure SQL database and with the contained user, this concept get a little bit blurry, but let's stay to the traditional one that we have a login, and then we also have a user. So a login is at a server level, a user is at a database level, and each login is mapped to a user for every database. And then we give permission or we give authorization to the user when it comes to SQL Server. And I understand, like as I said, nowadays we have managed identity, we have other Entra objects that some of these will get blurred. But let's just stay with this just so you can compare with Postgres. Other thing is a schema. So a schema is a logical boundary within the databases. Why do people use schema? There can be many different reasons. It can be functional. It can be you might have different clients. You might have different operations that you want to put it in the same database for different reason. So you can separate those things. But it's also a security boundary. So we can latch on a schema and we can design our security based on a schema. And I'll show you some of this stuff later on that we'll talk a little bit more on those. Super user. So if you are used to SQL Server, we know something called SA or sysadmin. That means I have the master key. So if in terms of, I talked about a hotel, if you are the manager or supervisor in the hotel, you can probably get into every room in case of emergency, right? So you have a master key. So a super user in SQL Server, we call SA. In Linux, there is a root user. In Postgres also, there is a super user called Postgres. So this super user can do anything. And when a super user comes, other than if they can log into a Postgres cluster, nothing else get checked. They automatically get every privilege then that they have, that they need within a Postgres cluster. SQL Server roles. So in SQL Server, a role is a collection of privileges. DB data reader or bulk admin, backup admin, security admin. It tells that if you are a member of this role, you can do ABC at a server or a database level. And we can also create our own roles, like the user-defined database roles and server roles. And we can then make other people member of these roles. And there's something called application role. I'm not going to talk about this here. If you're interested, you can look up in the books online. It's at a database level. That's all about SQL Server. In Postgres, we'll go into pretty details into roles. So there are 4 things that I want you to really take note out of this talk, because if you're going to be working in Postgres and if you're coming from SQL Server world, you will struggle unless you make your understanding very clear about these 4 things. One is a role, which we briefly touched about SQL Server. We'll talk about the Postgres one. Other one is object ownership. So a object owner is kind of a super user for that object. This is totally different, and you need to understand this object ownership, otherwise you're going to struggle when you're giving permission to other roles and within the Postgres. And there's also something called inheritance. And I know in SQL Server there is also inheritance, because if I'm a member of a role in SQL Server, I automatically inherit all those permissions. In Postgres, the inheritance is a little bit more granular. So try to grasp that understanding. And other thing we will be talking about is a default privilege and how to modify default privilege. You absolutely have to understand that if you're going to be working with a large Postgres cluster to manage permissions, because it works totally different. And if you're not going to understand what is default privilege and how to edit default privilege, very soon it can get very messy. So in SQL Server, whenever we talk about cluster, we're talking about a Windows Server failover cluster or failover cluster instance. It means one or more machines are bundled together to create a cluster. But in Postgres, it's totally different. In Postgres, whenever we talk about a cluster, we are talking about a single Postgres engine and a collection of database inside that engine, inside that Postgres engine, that are all in a one data directory. So I can have a Postgres, I can have a host that can have multiple Postgres cluster. Same as in a SQL Server host, I can have a default instance and then I can have multiple named instance. But in Postgres, we don't call it a named instance. We just say there is 3 or 4 Postgres cluster. But you have to understand a Postgres cluster is same as a SQL Server instance, not a bundle of one or more hosts together that we build during when we talk about a SQL Server cluster. Postgres role. So in SQL Server, we just talked about server level role, database level role. In Postgres, role is totally different. Roles only exist at a cluster level. Every login, every user, every group that we know in SQL Server, everything is a role in Postgres. A role is created at a cluster level, but the permissions, the authorizations are at a database level. So I can have a role that can create table in database A, but it cannot create table in database E because the permissions are different. I have to give it separately for each database. Now, in Postgres, you can also say create a user. Actually, that's an alias for creating a role. Same, you can create group, which is also alias of create roles. So users can log in and groups cannot log in. Now, these roles, what I'm saying as a group, which is alias of role, you can use those same way that we know server level role and database role in SQL Server. So once you create these groups, you assign bunch of permissions, and then you give this role membership to the other roles. That way they inherit this permission. And a very clever way, Postgres implemented something that we use a loose term called like just-in-time access, right? I want to give someone this access for a smaller period of time. With any inheritance, the way Postgres implemented it, it's a very clever trick that you can use for the same purpose. So in every role, if it's not a user, what kind of permission it has? It will get some permissions by default from the public. And in version 15, there was a major change. Before that, any role could create objects in public role. Now it cannot do anymore after version 15. So that public permission is already there, and you can modify those if you do not feel comfortable, or if you think those are too much for every role, you can always control those. And then the role is going to grant whatever you grant directly and whatever is going to inherit. So combination of these three is the total privilege that a role is going to have within a database. SQL Server is a 2-level, and I mentioned this before. Yes, there are exceptions, and I'm totally aware of it, like in Azure SQL Database and contained users. But in general, you come in as a login. Like I said, you have the key of the door of the front door, and then you have users that manage your permissions per database. In Postgres, this concept doesn't exist. in that way, the way I explained in SQL Server. The way it exists in PostgreSQL is you are a role. The same role is coming at a server level, and see if you can come in. You came into the cluster. Now your cluster has 10 different databases, but you're not going to create separate user. You're going to give permission to that same role per database, and that's how you keep it. What I said, user in SQL Server. That's how you keep the permissions separate between the databases for a single role. These next two slides, this one and the next one, I have not tested everything. I have done few, because most of the Postgres engines that I acquired as accidental DBA reside in Azure, in Microsoft Cloud. So I do not do some of this stuff, but I did double check with some of the experts. These are correct. So if you are running in Windows, or if you're doing Windows authentication, depending on your Postgres is running on Windows or Linux, I have these two slides that you can definitely consult, and you have some idea about authentication, what's easier, what's easy to implement, what will be difficult, and you have to do some custom stuff. And some are not supported at all that I posted here. As you can see on the second column, on the third row, it says that SQL Server on Linux doesn't support OS level authentication, but in Postgres, it's very easy setup. So it will be good to know if you are going to admin for Postgres engines or Postgres clusters. As I mentioned, that you must understand role, and if you are admin of Postgres clusters, this is going to be in your wheelhouse all the time. If you look at the slide on the right at the bottom part, you'll see a full list. That's a URL that shows you the Postgres official documentation about role. It lists all the attributes. I only listed the top 6 that I feel like that you should know off your head without going to the documentation every time. So the one that you see is highlighted is the default. So what does that mean? If I say create role, Taiob, if I do not say anything, I cannot log in, because no login is the default attribute for every role you create in Postgres. If I want this role, Taiob, to log in, I have to say with login. And I'm not going to read the whole slide. The other 5 are same. Highlighted means default, not highlighted means not default. So if you mean to role to do some of those, you have to mention those while creating, but you can always change it later on, except the login and no login one. Role scope. I talked about it briefly a few times, so I'm going to mention that again. A role we always create at a cluster level, globally shared across the databases. But when we want that role to connect to the databases, it has to be in the database context, and whatever permission it has within the database context, that boundary doesn't change between the databases. Doesn't matter how many databases I have in the cluster. Public role we mentioned a few times. Every login in SQL Server is a member of public role. You have permissions that are predefined, and you can change the permissions of a public role in SQL Server. If you create a login, it doesn't have any other permission. It will inherit from public role within the server level. If you create a user without any permission, it will inherit whatever is in the database public role. And all these 3 bullet points applies to both server and database public role within the SQL Server. In Postgres, it is very similar to SQL Server in terms of every role is automatically a member, no exception. And a public role exists in every database, and you cannot drop it, right? And the permissions are by default, as I said. And if you think whatever business you are in, that those public permissions are too much for every role, you have the full control to tighten that. And you should review that with your security team, with your app owners, whatever way you do it at your workplace, but you should definitely review it and make sure everybody's on the same boat. Postgres also have a public schema. We talked about a schema before in the definition slides. And I talked about in general because I said it's pretty much same concept between Postgres and SQL Server. So every database will come with the public schema, and every role can do certain things on public schema. I have a list of those things. Version 15 removed create privilege because that was deemed too much, and which is true. Even the one that is today by default, in some industry, you probably want to control some of those. Like there's one called, no, I have that slide later on, sorry. So Postgres object ownership, I mentioned before. Whoever creates an object in Postgres, that role becomes the super user. Only object creator can grant exclusive privileges to other roles. And unless you change the ownership, nobody else can do anything. But one good thing is you can change ownership, and I'll talk about it later on, when you go and see the demo code. Default privilege, this is what I was talking about. So this is a list I copy pasted pretty much from the documentation. One thing you want to notice, I mentioned it a few times. Are you comfortable with any role coming into your database and executing any functions or store procedures? If you are not, you should pay attention, because if you do not do anything, every role within every database in the public schema will be able to execute all functions and all store procedures. So if you don't like it, you should do something. You should tighten your security before you create the roles. I mentioned 4 things that you should pay extra attention, and one was default privilege. And if you do not use this feature, I can guarantee you in any commercial enterprise, you're going to be struggling with setting up a unified and scalable security model within your Postgres. You must use default privileges. So this is what I talked about in SQL Server, where we have built-in server level and database role. This is exactly for that reason you're going to use default privilege to create those roles. And if you want to create those roles for future objects, which is not same as SQL Server, you have to use a code called alter default privileges. So let me show you that. This is a very simple code, and it can be more complex, but I kept it very simple just so we can walk through this and we can talk about it, what I mean by this. What this is saying is this: going forward, when admin role is going to create any object in public schema, another role named dev login will automatically have select. And this will be implemented for the objects that already exist and the objects that admin role is going to create in future. As I said, so this is just a simple one. Your roles are probably going to be a little bit more complex, but this is the way you decide how many roles you need. You create those, and then later on, you make other roles a member of this, so they automatically are going to get, inherit all these permissions. So in the interest of time, because this is a short talk, I'm not going to run through all the demo code, but I'll probably show you a few things that I prepared. And we will be switching to a tool that you are seeing here right now called Visual Studio Code. This is by Microsoft. It's an open source. It's a multi-platform. It's extension based. And what I'm using right now, I'm using an extension called, let me show you this. This is a little bit zoomed out, so I will zoom back and then I'll come back just so I can show you. Okay, no, no. Let me show you these extensions here. So I'm using an extension called Postgres or PostgreSQL. This is by Microsoft. This is a newer one. If you have an older one, I disabled it. I can show you, but make sure you have this current one. And I'm using this for this demo. So let me Okay, I'm kind of a little bit low. I'm just going to minimize this. Okay, good. And what I have here, I have a Docker container running, and that is running a Postgres instance. As you can see at the bottom right corner, I'm connected to a local host. My database is Postgres, and my user name is Postgres, which is a super user. And so I have a demo section 1 and a demo section 2 and 3. I know I don't have time to run through all 3 sections, but I have put enough comment here, more than I'll put even in my production code, because I know that we don't have time here. So once this conference is over, wherever you're going to get our slide, I will upload this, and you just have to change the name of your cluster, and wherever you're running it, maybe the port number. Everything else should work as is. And if you get stuck, as I shared you my contact, and I'll do it again at the end, you can always reach out to me if you run into an issue. So let's try to walk through this pretty quickly and give you some ideas that what I mean, what I want to show you. So you're just creating a database here, just an empty database. Let me go one more up, yeah, just to make sure you can see it good. And then I have some of this code might look complex, but they are here, so I can run this over and over, right? If I need to for demo purpose, just clearing up some stuff. So basically I'm creating a role, but as you see here, I said with login, right? As I mentioned, because no login is the default. Now it created a dev login, and I created a role called read login, and both are login. They're not group, they're users. So I created one with dev login, one is the read login. And by default, of course, these permissions are granted, as we talked about. And now if I go to create a table, I'm going to get an error message because I haven't given any permission to the dev login. And later on, I gave permission to create table. And then the dev login can create a table. But now I ask the read login to read from this table, but it cannot because I also didn't give anything to the read login. Now I gave it grant select, and it can read. Now dev login created a table too, but read login cannot read because what I talked about, the default privilege, can rescue here. Because when I gave the read login permission, read permission to the read login, table 2 did not exist. So now it cannot read. It failed. As you can see, this is going to get very complex, right? Every time you create new object, are you going to come and give it permission again? It's not going to work. It's just not feasible, right? And you will have more and more developers, more and more people probably in QA and your business accounts or application accounts that want to read your data or modify your data. It can get very cumbersome. So then if you go to the demo section 2, here I'm creating roles, as you see, with no login, right? I mentioned it just to be clear. I know it's default. Now I'm start creating groups, as you know, in SQL Server. And I'm also creating, giving the group a permission and then making the dev login a member of dev group. We don't say here member, we say grant. And the same way I'm going to do the same for the read login, right? So I'm going to create 2 groups. I'm going to make everybody member. That way, when I have new developers, new folks in the QA team and other teams, I can just keep making them member. And going forward, what I'm going to do, I'm going to use the default privilege. So I do not, even though I create this test table 3, test table 4, after I grant the permission, things are, I don't have to go and do it again. They're automatically going to have those permissions. So you have to think about how many groups I need, and then create those, give them proper permission. Then you create your users and make them member of those roles, or grant them permission, or make them member of those groups. I also have code for you that I'm going to go down and show you. I created a second database now, and I'm trying to use the same roles that I created before. As you can see, I cannot. This will fail because it says you gave me permission in the first database, not in the second database. So it doesn't work here. Now, if you are a SaaS provider, if you have 100 of this database, are you going to do this every time? No, you do not. So for that, I have put here 5 options. In SQL Server, something called MSDB. If you change your MSDB and you bring your database, will get created from MSDB. You can do something like this. I have 5 different options, and I have a demo 3 as a bonus talking about inheritance that I talked about. So again, download this code. If you have any issues, please let me know. And we are almost out, end of the talk. So let's wrap it up. Go back to the slides. So what did you learn here? As a summary, you definitely want to think about unique sets of privileges. If I have to translate it into SQL Server language, how many database level groups I need, right? DB data reader, DB data writer, that kind of groups. How many I need, create those, and then make other roles member of those groups. Use default privilege for everything I just talked about. And these are some further readings. If you want to go a little bit more deeper on some of the topics I talked about, I have read all this, so consult those. And thank you again and for listening and for attending the conference. Hopefully you enjoy other sessions. Reach out to me with any questions, comments, and you are guaranteed an answer. And take a note of my contacts at the bottom left of the slide. Thank you again.
Nice. Awesome. Thank you, Taiob, Ali, for this presentation. I think it's a great last presentation for Livestream 1.
I can't believe how quickly it flies by. It goes so fast. There was one detail I remember about default privileges. It's like you give them to a role, but then you have to set your role, I think, in order to pass them onward. There's something tricky there. It's worth reading the manual very carefully on how they work and how they escalate down towards the lower level roles you are granting to.
Yeah, the other interesting thing at the very start, he mentioned sort of agent identities, right? And I'm curious how Postgres will need to start thinking about potentially scaling, or what are the challenges as you think about, say, 10x or 100x increase in say number of roles or privileges or something like that as well.
Yeah, it's gonna be a challenge. But who else said it? It's like Postgres never changed phone number over the last 30 years. There were trends, but we are still here, and the database is doing better than ever before. So.
Yes, survey. We just wrapped up our talks. Again, thank you for everybody who's already filled out the survey. If you haven't already, the socks are a nice a gift or gratitude. But what we're really looking for is the feedback on how we and both the speakers can improve as well.
Yes, and we can't emphasize this enough. It is really important for all of us to get this feedback, to do better next year. I mean, look at today's talks. The quality was really good, and I think the quality was better than the year before and the year before that one. So it does matter, and it helps people grow. So please fill in the survey before you log off today, because tomorrow is another day and you easily drop the ball on it. But it's so important. So before you log off from your laptop, iPad, phone, whatever you're using to watch this, please fill in the feedback for both the talks you watched and also the event in itself.
Well said. Cool. And let's take a look at what's next after Livestream 1. So obviously, attend Livestream 2, 3, or 4, it says, but ideally all 3 of them.
So how many talks are there tomorrow? 44 divided by 2, basically, because one starts in the morning for me and one in the afternoon. So you can watch 22 talks tomorrow, I think.
Yeah. And there's the Discord channel. I know there's been a lot of activity on that, a lot of really nice questions and conversations on all of the topics. If you're not on there already, that link will take you there as well.
So, Sumedh, when will you fill in your reviews for today?
Oh, I'm just going to do it right after this, after we wrap up. Although I have a bunch of socks already from Claire, so I don't think I quite need the socks, but I'm gonna do it just to one, give feedback, but I also actually jot down some notes of appreciation for some of the speakers as well.
I think the Microsoft socks completely have taken over my socks basket. I don't think I have any other socks than Microsoft socks these days, but they are really
Yeah,
comfortable, so I keep wearing them.
And then they're great designs, so I actually like wearing them as well. The replay for Livestream 1 will be available at aka.ms/Posette-ls1-YouTube. So if you did not get a chance to see some of the talks or see Livestream 1 at all, the whole replay will be there for you.
Actually, I don't know when they will become available. Is directly after Livestream 4, or will there be some more time involved? Do you know, or should we ask?
I believe it is going to be like today, I think. So I think in the past they used to be uploaded at the end of all of the live streams, but now I think in the next 10-15 minutes it should be up and available on YouTube already.
In a few minutes, as we finish, is what I'm hearing right now. All right. So tomorrow or this evening, afternoon, morning, wherever you are, you can immediately watch back the talk you missed.
Yep. Good. Okay. Walk through this one.
Yeah, I don't know what it will bring. A hackers panel, but it's an intriguing topic. Sometimes you see things on the commit list and it's like, oh, I want to have this, and then still it drops out. And this decision process is something I really can't explain or even understand. So yeah, I am curious about this panel.
I am. And this is the I guess the second keynote in the conference, which I believe is going to be in the second live stream, which is going to be sort of later tonight, I guess, in the central or data, I guess, for you guys.
Yeah, for me,
in the
it
European
will be,
time zone.
Yeah, it will be tomorrow morning for me.
Got it. Yeah, and then this one is going to be pretty cool. I think the first beta version for Postgres 19 has come out, so it's a good sign. I don't think any major features have been reverted yet. So let's hope it stays that way.
Yeah, let's hope there will be no yet. Just what's in will stay in.
Yeah. But also just trying to understand sort of the decision-making process, right, in terms of how they decide. And I know there's sort of a release management team, but how do they sort of go through that process of deciding, when should we actually commit stuff versus, or revert as well.
Yeah, and also when people understand these things better, it's so much easier to not be upset about these things if it's not in your favor or it's something you really wished for, right? So yeah, explaining this to the community, I think, is also a really good thing.
And a huge thank you to all the speakers for Posette 2026. Like I mentioned, it's a lot of time and effort which goes into this, and the whole community benefits when people give these talks.
Yeah, definitely agree with that. And making 25 minutes talks, it's not easy, I can tell you. So yeah, thank you very much, all of you.
And I guess let's look at the schedule for Livestream 3, which is on Wednesday. I guess that will be basically tomorrow at the same time as well. So 8 a.m. to 2 p.m. Pacific, Wednesday, 17th of June. Again, there'll be 11 talks on this one. Any ones over here, Derk, you're really looking forward to?
Yeah, I feel a little bit bad about answering this question, but I want to see Abe's talk because he did so good last year, even though maybe the topic this year is a little bit less to my liking, but I also just can enjoy a good speaker telling the story. So probably I will watch that one. I like pgconf from Pavlo. It's a tool I'm trying to implement at the moment. So yeah, I would like to see the longer version of that talk as well. Actually, I want to see them all.
Same here. I mean, The few here which are particularly interesting, I think the production RAG at scale with Azure database Postgres. I think that's interesting. That's just an area that I don't know much about, so I thought it would be interesting for me from a learning perspective. Even Sharat's talk on maintaining large tables in Postgres. I think it's there's a lot of tips and tricks you learn along the way as you're managing large databases and large tables. So I'd love to understand more of those as well.
Yeah, I will definitely watch that talk as well. Either I learned something on how to do it better, or at least we can share the pain.
Yeah, yes, exactly. Cool. Again, this is the wrap-up, Livestream 1. Sumedh and Derk here. There were 11 talks today, and super interesting, amazing content, super high quality. Well, what was your take, Derk?
I wanted to ask you, what's the one where you learned the most?
From a learning perspective, I thought there were a couple which I thought were very interesting. I think one was the Pamela's talk on the MCP server. Again, that's similar to RAG. It's a very new area for me, so I think it was just interesting to see how you would approach building an MCP server in Postgres. But I found Tomas's talk on random page calls also very interesting. Like, again, I have a very before the talk I had a very surface level view of what the random page cost was sequential page cost meant, but it was very helpful to see some of the actual numbers and benchmarks that he ran for his talk as well.
Yeah, I think for me it's the same one. It's so easy to say like, oh, today's disks are faster, we should decrease this number from 4 to 2 or something. And then he kind of demystifies that it's not that trivial. And even maybe the value of 4 was kind of a random value in the past, but still it's like, it worked really well. And changing this lightly or slightly, it's something to be very careful with. And then you learn a lot of insights, and it's tested and all kind of hardware, and the hardware you found in the house, then it's been properly tested.
Yeah. And even actually, like the Fuzzing Postgres talk by Adam was also quite interesting and insightful. Again, just a primer for how you would approach something like fuzzing, right, on Postgres as well.
You know what stands most with me, actually? If I look at this overview, it's such a good overview. It's cool to be part of this evening for me and watch all these talks and so many good speakers, and I learned so much.
Yeah, and what continues to amaze me is the size and scope and breadth of the whole ecosystem, right? I mean, if you just look at this list of talks, the variety of topics being discussed here is huge, right? So it's pretty cool to see that as well. And I'm like you said, I'm really glad to be part of this.
Yeah, not for today, but thank you everybody for joining. It was nice. So many of the speakers joined. They answered a lot of questions. Some of them were hanging around really for a long time. And please join again tomorrow and the day after tomorrow. It is about the community. There's no sales team, as someone put it, or there's no Postgres marketing team. We do it all together, and sharing things, coming together, it really drives the community forward. So join us.
And the conversation was fun. I mean, there were people, cracking jokes, making observations, and sharing insights as well. So it was a nice place to be.
Like a hallway.
Exactly, like a hallway. Yeah. I guess where to find the Posette talks. Just the PosetteConf website /2026/schedule. Fairly straightforward there.
Yeah, and it's so easy to select your own timestamp, because it's always a hassle, right? Is this in the morning for you or in the evening for me? But you can really, first thing you can easily find is this is where my time zone is, and then you pick it.
Yeah. Again, on the accessibility and caption side, so videos which will, I guess, be on YouTube in a few minutes after this live stream is done, will have captions translated into 16 languages, which I think is amazing. Right?
Yeah, it's really good.
Doesn't know English. Yeah.
I mean, if you struggle with English, and I mean, I think almost for all of the people in today's the talks, but also the people watching, probably English is not your first language. So how amazing is it if you can watch the subtitles in your own language? It might increase the learning so much. I think it's a really, really good offer.
Exactly. Amazing.
Did we have surveys today?
Yeah,
maybe
I
we
forgot.
to. Yeah, I think we forgot to mention this.
But yes, get us complete the survey both for the event, and there are two different links. One which gives feedback, for the entire event, and then one which you can select to and select a specific talk that you want to give feedback to.
So how do we give feedback? Make it concrete, right? Say something, this is how you can improve. I would love to see this next time. Or maybe you can leave this one out. Really help the speaker forward, please.
And get your swag as well. So again, supply is limited. You can get your voucher code at the end of the surveys, and then just go to the URL below to get your swag.
And then we have another one for the Posette and friends. So if you joined the Discord today, you can have an additional set of swag you can share with your friends. I always put them on my laptop, but actually that's a really bad strategy because every now and then I need a new laptop and then I'm so sad about losing all my stickers.
I actually heard somebody had replaceable back screens or something like that, so you can take your stickers with you for new laptops as well, which is interesting. So a quick recap of the different live streams. So we just are wrapping up live stream 1. Live stream 2 is coming up, tonight Pacific time, but tomorrow morning, European time, and then live stream 3 will be back in the Pacific time zone as well.
And yeah, the ordering of all the talks and how do you call this? Like almost the tags you can search for if you want to learn about specific talks. This is where you can find them, nicely ordered.
Yeah, and like the variety of the Postgres ecosystem talks as well over here, outside of the rest of them as well. And there's the ultimate guide for Posette. So the link will take you there. I think it's a really nice overview and really help you navigate the amount of talks and essentially find what you're looking for and what would be relevant to
and
you
most
and
important, when to be there.
Yes.
Because that's ultimately what you want, right? You want to quickly find, this is what I would love to see, and this is where I need to be online. Yes.
Upcoming Postgres events. Go for it, Derk.
I was making jokes about we need a lot of time in the wrap-up to talk about the upcoming events because I'm, how do you say this? It's preoccupied?
Yeah, I guess if people don't know, Derk is one of the organizers for PGD Lowlands. I have not been there, so I'm, hopefully, if not this year, I'll try to make it next year.
Or maybe you have to wait another year because we try to organize PGD Lowlands on Texels one year. Texels is a beautiful island in the Netherlands, and we are really aiming to go there. And it will be an amazing place. So that's
nice.
It's definitely not the first one. First is PGD Swiss. It's already in June, next to a beautiful lake in Switzerland. Then we have Hyderabad PGDs, which I actually didn't know about. Did you?
Yeah, I mean, I think even PGConf India started as sort of a PG day in Hyderabad, which then started becoming larger and larger, and so they sort of made into a larger event of PGConf. But yeah, this one should be interesting as well. I think there are a couple of folks from our teams who've submitted talks to this one as well. There's also a PG Day UK coming up in September.
Yeah. Chris is actually a organizer of PG Day UK. We did talk as well today in the live stream. And Boriss is one of the organizers of PG Day Lowlands as well. So
nice, awesome. And finally, I think we rounded up with PG Down Under in October. And I guess the CFP is still open. So I think it's open till July 15. So if folks are in that area or in the region or going to be there, I think that's a great opportunity.
And important, PG Day UK and Lowlands are only 2 days apart. So if you have to travel from far, this is an easy way to get to conference for the travel time of one.
Nice. And then there are a couple of big ones coming up as well. These are some of the larger conferences. So there's Postgres Summit in the US, I think formerly PGConf New York, from September 30th to October 2nd.
And PGConf Europe in October 20 till 23 or 23rd. And the Community Day on the 24th in Spain this year. And rumor is there will be a storytelling workshop organized by Boriss and friends as well. So
nice. Is he going to talk about the SWBS?
The Swabbus and the
Swabbus? Okay.
The Swabbus and the Snubbus. The Snubbus is somebody needed, but that's a more complicated storyline.
Nice. Looking forward to that as well. We mentioned this early in the live stream, but Talking Postgres is a really nice series of podcasts hosted by my colleague Claire Giordano. As you can see, my co-host Derk is there on episode 12, but it has a bunch of other folks in the Postgres community, and it's a really good way to understand the people behind the community as well.
And it's also just a good way of building more and more and more of the community. I mean, how amazing would it be to get this list to 100, right? 100 months where you just learn about someone in the community who drives something or has a passion for something. I love the initiative.
Yeah, and then you can see a bunch of folks that we've already heard from, like Boriss as well. I know there's Floor, who's going to be one of the live stream hosts coming up as well, and she's also there here on Talking Postgres. So I think there's something you can find on all of your favorite podcast apps as well.
Yeah.
And yeah, sorry, go ahead.
No, please go ahead.
No, I was going to say again, gratitude to Microsoft for bringing this conference to us. And thank you to AMD as well for partnering with us for the first time for Posette 2026.
And it is really important, this one. This organization is not a small task. You will be easily mistaken by multiple orders of magnitude how much work it takes to organize a conference like this one. So massive thanks to Claire, Daniel, Divya, Melanie, for the talk selection teams. Picking talks as well is not an easy task. You want to do it well, you want to be sharp on it. You don't want to judge talks better on one day but less on the other day just because you were tired for some reason. So it's a really tedious process and you have to take care of it.
And it's also a large conference. So I think selecting 44 talks, you have to go through like hundreds of them, right, and really understand and try to find the right balance. But also thank you to the organizing team. Right? Like I said before, I think we just got a small sneak peek into the background as hosts, but just the amount of work that's been going on the last several months in putting this conference together. So again, thanks Aaron, Claire, Cornelia, Gauri, Henry, Jeremy, Linda, Pooja, Srirama, and Silvana.
Yeah, thank you very much. It's amazing to have the 5th conference on the way. Slightly sad the first live stream is over now, but thank you so much for organizing this. It's really cool.
And thank you to the hosts. Thank you, Derk, by the way. I think it's been great.
Thank you as well.
Co-hosting live stream on with you. It was a lot of fun. I really appreciate your time and effort. I know it's late right now for you as well, so you should go take a go hit the bed.
I will definitely not easily jump in my bed now. I need time to cool down. I'm energized now, so yeah, I don't know. Maybe I'll take a walk.
But again, tell your friends. Like 44 talks, 50 speakers, amazing content, really high quality. We mentioned this before, not right now, but for the next live stream, please do join the virtual hallway track.
And if you have your questions, put them on the channel. Even if it takes a few days for the question pops up in your head, please post it anyway. There are people around in the chat. They know the way in the community. It might take a while, but probably you get your answer.
And I think that's it up. This is exactly on time. I'm surprised we managed to get everything wrapped up. But again, thanks for co-hosting. It was a great opportunity and a great learning experience for me.
Yeah, thank you very much as well. And thank you for all the people watching. It's an honor to have you on the live stream. It's so cool to have you on board. And we all hope to see you on the other live streams as well. Thank you very much.
Absolutely.